Hello, good morning.
Hello, hello.
Welcome
Morning.
Global Azure ANZ 2026. Well, we have like
Good morning.
special a special team just to start like the day, and we're gonna go in here like if you don't know me, my name is Marcel Medina. I'm here like as a Microsoft MVP and a MC, but we have others here in the team like Luke. If you can please
Good
introduce
morning.
yourself.
Yeah, so my name is Luke Murray. So I'm Microsoft Azure MVP from New Zealand. So hello, welcome. It's going to be a great day. Eager to learn some great sessions happening across Australia and New Zealand. So it's yay for us.
Yeah, that's true. Hey, Ahmed, a little bit of
Yeah,
yourself.
thank you, Marcel. Yeah, I'm Ahmed. I'm an Azure MVP. I'm based here in Melbourne. I just moved actually recently. And yeah, so it is really exciting. Looking forward to the sessions. And yeah, it's going to be a great day.
It's awesome. Shanshan.
Hello, everyone. My name is Shanshan. I'm a cloud solution architect from Microsoft. I'm based in Auckland and focus on Azure infrastructure. Nice to meet you here today. I'm very looking forward for all the topics today. Thank you.
Oh, that's awesome. Yeah, so we're cross like the ditch in Australia, New Zealand, and we're just being here like connected, right? That's part of the community. We're just like kind of coming together to share like well, to talk about Azure today, right? So it's always special, right? So I think we've been doing that like for a few years. It's always like so great like to receive like a lot of feedback from people. I hope like that the people really come and to join and ask questions and get like the best like out of the speakers really like because they're here putting like time and dedicating like to the community to talk about Azure, right? Their experiences. So that's like and they are great like professionals in the markets, right? So they're just coming to share like what they know. Yeah.
It's worth mentioning as well. Like I think it like the name Global Azure. There's a whole bunch of events happening across the next couple of days.
Yep.
Not only for for the sessions today, but across the globe as well. So when we finish today in the afternoon, there's even more like work and sessions happening across the night because essentially it's a follow the globe. So it's
Yeah.
awesome. There's a lot to learn.
Yeah. So what I'm gonna do in here is just to bring. So we have a plan for the day, and we have like multiple speakers coming. So let me just share like the screen. Right. So this is like for today's sessions. We are splitting into two rounds. It's just because like the morning sessions would be aligned to New Zealand, but while here it's not necessarily it's not going to be afternoon yet. So it's going to be morning. So we have the first round and second round, right? So we're going to start like with Dylan. He's going to be talking about this the layered Azure landing zones. Then going like every session we have here like 30 minutes. Having like Matthew Levy, so he's coming like to share like with us like from South Africa. Then Rory coming like and sharing also like on identity. And Renato, he is also like bringing from Brazil. So he's coming to share like about the Microsoft Agent Framework. Then we have Peter Wards from America coming to talk about agents as your new intern. That's gonna be
Mhm.
interesting. Yeah, I think it's gonna
Yes.
be a fun session, right? And yeah, you're gonna learn like lots of that. We have Will the leader coming to share like the WASP top 10, right? New concerns like for agentic applications. That's also very interesting, right?
It's
Because
very top of mind at the moment. So
yeah,
Yeah.
yeah, we're all doing like agents, AI
mhm.
engagements, and yeah, that's a really interesting topic that he's bringing. Then we have Santosh Kumar bringing like about Azure Networking Services, which is also like really interesting topic. Then the second round, right? Then we have a break in between, and then the second round we're gonna talk about like SQL, like with Javier. So he's also like coming from overseas. Then I have like my session about like AZD. Then Sinan, right, from New Zealand, coming like with Aspire, and Stu as well from New Zealand, coming like to show like a bit of his experience and putting like those Terraform plans. So I think he's worked on a specific bug with the open source, and he kind of made it like available like to others in the community to leverage.
Nice.
And Intcap, also like from New Zealand, coming with a fabric, right? So that's like the data view. Then we have Chris Hales like bringing about Azure VMs, and that's interesting, like because we have like a variety of sessions, right? And that's going to be a full day for us, like New Zealand, like up to 3:30, while we're here, like Australia, yeah, 1:30. So it's going to be pretty good day. And do you guys have any sort of views on the sessions or something? Luke brought about like OWASP top 10. Any other
Yeah.
sessions that you guys are interested, like, or I don't know, maybe for a particular use case you're doing at work?
Yeah, I'm actually really interested to learn more about the agent framework. And there's a lot of sessions here about AI. So Will's going to talk about AI agents and security. We are very interesting about the AI intern. That is super cool. And there's a lot of other sessions. There is, for example, Azure networking. It's always top of mind. How do you secure it? Layered Azure landing zone is actually sound very interesting. I'd love to learn more about that. And and I see actually is a lot of people even from not just New Zealand and Australia, a lot of people from I think when you mentioned South Africa, from the US, which is wow, that is super cool. So a lot of great sessions actually.
Oh yeah. I think like we had like submissions from all over the world.
Wow.
But priority was given to the speakers like in New Zealand, in Australia, right? And yeah, as much as we wanted to accommodate everyone, it's just really like if you were to bring like everyone, we would have like three days in a row. That's like based on the number of submissions. We had like more than 60 sessions, or I have the final numbers, but yeah, that was pretty good. Like it was nice having like the sort of volume really of submissions, right? And unfortunately, accommodating everyone was impossible. But yeah, that's thanks so much for people that tried submitting, and but maybe next year, and then always keep like submitting.
Yeah, it's worth noting as well as that like coding night, Azure Cloud Commanders, like we do these sessions virtually all the time as well. So yeah, feel free to reach out to any one of us on the call, and I'm sure we'll be able to set you up with running a session and publishing it externally as well. So we're all here to share knowledge with everyone. So.
Yeah, I think actually as a cloud solution architect, I have many customers to communicate with different requests or different questions. These topics are really hot topics at the moment from different customers. And even for me as an Azure infra people, I still need to upskill myself to get a basic understanding, have a fundamental knowledge for the agent AI framework, and to help customer to build on some new applications. Yeah, it's really good to come here to upskill myself and also for the audience who will join today. Really exciting.
Yeah, there are lots of learnings in there, and people are coming from like experiences like that. They are running workshops. They are talking to clients, and they're bringing like the latest and greatest, really. So we have here like sessions that you can apply like to your business, right? So, yeah, to your team. So just knowing like what's available and then perhaps adopting, right? So, but like all the speakers we have in here are people from the markets, from the field, right? So just bring like their experiences. So that's really valuable.
Yeah, really
Yeah,
valuable one. Yes.
yeah, yeah. So yeah, so that's like what we're having here, like the plan. So people could just stay with us. Like we're gonna be here like the full day, and depending on your sessions, like I think like the attendees would just come and watch particular sessions. Everything is going to be recorded, and later on, what we do, we take like all the sessions and we make them available separately, right? So people can watch these specific sessions if they wish to, right? Um, I think like with in here, we have like our speaker Dylan McCarty just coming in the next um, coming with the first session, and then yeah, from here we are going to be full day just helping and bringing like other speakers really. And I'm going to be watching the comments section and bringing the questions to the speakers. Yeah, going to be awesome and very excited for the day. All right, so from here, we're gonna have Dylan, and we should start soon. And
Yeah.
cool. So good luck to us, and welcome. Be very welcome to our sessions. Just
Hey, welcome to our first session of today for Global Azure 2026. Rocking out to that music, I was just like, we just can listen to this all day. But even better than the music is our first session. So welcome, Dylan. So Dylan's coming to present to us today on layered Azure landing zones. So designing scalable, composable platforms. So really interesting, especially in the world of platform engineering, which I know Dylan is very passionate about. So welcome, Dylan. Do you want to introduce yourself? And
Morning, Luke. Yeah, thanks. Yeah, hi. Also, Dylan McCarthy here. I'm Melbourne-based in Australia. I'm a principal solution consultant for a company known as Versant. So I work with modernization, which does include things like platforms. So landing zones is pretty much a core part of what I do, as well as things like developer technologies, developer experience, which kind of all fits into the whole platform discussion that we'll cover a bit of today as well.
awesome. So if you wanted to share your screen, happy to get
Yep,
going while I
that's
put my phone on mute because I can hear it ding in the background.
Oh, good.
Now, you are the first speaker today, so we may run into some technical difficulties. We'll just see what happens. Are you able to present?
Oh, good. Just getting that up now. And here we go. Sorry,
It's worth
PowerPoint
noting
in
for the
PowerPoint.
audience as well is that it's about 7 a.m. in Australia at the moment. So even though I still sound half asleep, it's actually 9 a.m. in New Zealand. So I've had a better start to the day than Dylan has. So I appreciate you giving up the morning for coming and presenting to us today. So
That's all good. All right, so we should be presenting. So hopefully that's all
Yep,
come
I
up
can see
nicely.
it. So,
Great,
good.
cool. I'll get going. Oops, thanks everyone for coming to this talk on layered Azure landing zones. So again, just to recap for people, so my name is Dylan. I'm a principal solution consultant at Person, focus on platform engineering, DevOps, and DevX in Microsoft domain. Also MVP for developer tools and DevOps. And I started off my career as a .NET developer. So I've seen kind of the whole progression from development and how we deal with developing things, deploying them, and then moving over to the side that's actually handling those deployments and seeing cloud infrastructure, things like that. And I'm an all-around tech enthusiast, passionate about AI and emerging tech. Cool. All right, so let's get started. So what's really the problem we're talking about here is that landing zones feel hard. And it's not always the case. It's kind of like they feel hard, but then when you get into the environment, they're often really complex. You've got lots of moving parts. You've got lots of infrastructure as code if you've got to that stage. Lots of people touching the same thing. And then they become really hard to manage because you've got lots of different owners, different tools. So you've got security teams, you've got your cloud teams, you have your application teams, and they're all trying to manage the same things. And that makes it really slow to change. So when you need to actually make a change to your landing zone, like you need to add a new area to the landing zone, or you need to update some governance, it becomes this huge issue of trying to coordinate everyone into the same thing, know where the effects are going to land of what you're changing. And then that just slows things down, like delivery. So it takes ages for that to come through. There's risky changes because someone may have changed something they're not aware of the impacts on other parts of the landing zone. And then that ownership component. So who actually owns this part of the landing zone and the change that's going through. So what's actually wrong here? Well, it's not actually the complexity that's issued. It's coupling. So if we look at all of these kind of layers, like the idea of a layers where we have our networking, we have governance, we have our application, so these things are all very tightly integrated. So if you make one change, it's going to really likely affect a lot of these different areas all at once. But we've seen this before. We've seen this issue with coupling before. And it's from software development. If we look back at software development, we've seen systems where they're tightly coupled and they cause all sorts of issues with how do we manage that coupling. And we came up with this idea of the separation of concerns, where we want to have each part of a system should address a separate concern. So really what we should be doing is looking at how we manage that in software and thinking, well, how do I apply that to the cloud? Can we start to separate things by their concerns of things like networking, governance, and the application layer? And do we want to try and separate each team out to that as well? So the shift that we're looking at here is that we've got our kind of monolithic infrastructure as code, where we've got our networking, governance, application, and everything's all interconnected. One change can break many things, and teams feel constantly blocked by waiting for other teams or trying to all manage the same thing. And what we're actually looking at doing then is looking at, okay, we want to separate these concerns out. So we've got our networking layer, where we have our connectivity, our network topologies, our segmentation, and that's all managed by a special networking team. Because this could also include things like connecting back to on-prem. all part of that same layer. Then we have our governance layer. So this is where we're looking at how a policy is applied to our Azure environment. How are we ensuring compliance? What guardrails are we putting in place? What are the structures of the management groups? All of that kind of thing is all managed on its own layer rather than trying to fit that in with, say, the networking layer. And then finally, we have our application layer. So this is where we're actually looking at our workloads, our services, development tools, all this kind of stuff that would sit on top of these other two layers. So again, you've got your core networking, and your application obviously needs to use that networking. You've got your governance layer, which is adding in those guardrails and that kind of shaping of confining what can and can't be used within an environment, so that the application is made sure it's using the right things that have been approved. So the idea is we really want to be separating these things out so that each layer does effectively one job. And through this, we also want to reduce what we call cognitive load. So when you're looking at a layer, you don't really want to have to think about what are the other layers here doing. I just want to think about the application layer, or I just want to think about the governance layer. I don't want to be sitting there having to go, well, I'm deploying an application. How do I manage the networking? Because that should really be being managed within the networking layer itself. This also then enables us to move forwards with a lot of self-service, where we have layers in place and we have things well defined enough that when we actually need to do something like add a new application, it's not a huge task because we've already got things structured in a way that we can easily add new applications on top of the existing layers. We don't have to go back through all of those layers to do that. So let's look at what a layer actually is. So a layer is an area where there's responsibility for one thing. So, and we say one thing, in this case, one reason to exist. So networking isn't just one thing. There's lots of parts of networking, but the idea of connectivity and how the cloud manages connectivity is very much that one layer. And then for that ownership, now, it could be a network team, it could be the platform team, could be integrated into that. So, but again, it's the goal of having one owner for a specific layer. And that doesn't mean that you don't have other teams giving input. So if you've got your networking layer, you might still have a security team that's giving input to say, this is how we recommend this gets set up, or this is how we want to do the firewall rules. But at the end of the day, the owner of that layer is the team that's going to be implementing those changes. The change frequency, this is also really important. How often is this layer getting changed? In the way of networking layer, may not be very much, but say in an application layer, that's going to see a lot more change a lot rapidly. And then the blast radius. So if you're making a change on a layer, you know that this is the thing I'm going to affect. So the application layer, pretty low blast radius, you're just affecting one application. Your governance layer has a larger blast radius. So you're a bit more aware of, okay, I'm going to make a change here. This is going to have impacts on the application layer and then the networking layer as well. Going to have broad impacts. So by being able to scope those blast radiuses, it gives you a good idea of what is the risk involved in doing this change, how much planning do I have to do, how much change management do I have to do, things like that. So let's dive deeper into these layers themselves and really try to figure out what does each layer actually contain. So for our networking layer, we've got our connectivity. So this is if you're using a hub and spoke model, that would be where this is, or using a virtual WAN topology, that's where you would define this core part of your networking topology. And then your routing. So how is traffic going to flow through my environment? How am I going to get connectivity from my database to my application, or from on-prem up to my application? And then DNS, how am I going to deal with naming? Do I need to account for kind of the on-prem using domain controllers and doing DNS there? And how do I want to handle that in Azure? Am I using private resolvers with private DNS zones? How am I going to connect all of that up together so that that works seamlessly without other layers having to think about that? And then private endpoints. How am I making sure that the traffic in my network stays in my network? So if I've got storage accounts, am I making sure that they are not publicly accessible and they must be routed through my actual networking layer so that I don't have traffic kind of exiting the environment constantly just to wrap around to a public endpoint? At its core, this is the foundation layer. This is what everything else in your environment will sit on. So this is the hardest change. So you do need to spend a lot of time really considering how this layer works. And it has the largest blast radius. Because we all know if you change a route and suddenly you can't connect something, doesn't matter how much governance you have over it, the application is going to fail. So this is where you've really got to put a lot of time and effort to creating that solid foundation. Layer 2 is your governance layer. So this is where you're making sure you've got your policies in place. So your guardrails, your enforcement, you're doing things like enforcing tagging. You've got specific requirements on kind of VMs, like what size they can be. You're trying to really put that barrier around the environment, say this is what we allow in the environment. We also have our RBAC. So really managing who has permissions where. So making sure the right teams have the right permissions in the right areas, making sure that that kind of scales as well, because you have teams that might need to use privileged identity management so that they can escalate their roles. Is that being set up correctly? Managing all that layer, tagging itself, as we start with like requiring tagging, but is that tagging set up to allow for cost management so we can do FinOps and understand how much the environment's costing, which teams have different cost centers, which owners are for particular things as well. So, and then lastly, compliance, where we want to overlay our kind of compliance checks. Are we making sure that we're ISO 27001 compliant? Have we applied the right controls to layer over Azure to make sure of that? Are we reporting on it? Are we auditing it? And the key thing with the governance layer, though, is that we're not trying to block everything. We're not trying to put hard walls up. A lot of this stuff works just by having it in an audit mode, because what we want is information. And as Brian says here, good governance constrains, it doesn't block. So we're not here to put up brick walls when we do a governance layer, but we are here to constrain what's being used, put those guardrails in place, and make sure that the right things are happening in our environment. And lastly, we have our application layer. So this is really where the value for your platform is delivered. So at the end of the day, this is where your workloads are. So you've got your things like App Service, Azure Community Service, Azure Functions. They're all running inside this layer. But you also have your other services. So other APIs that might be there, messaging, so Service Bus, other integrations, so Fabric, and even more commonly now, Azure AI Foundry, where you're running all of your AI workloads, your agentic workloads, your data, so your databases, Fabric, storage, analytics, all gets run inside this layer as well. And this is also the layer where we're seeing the fastest change. So you're seeing new applications come in, new services get deployed, more and more requirements for adapting and creating new things. So this is the layer that we see all of that change happening. And we really need to try and make sure that when we change this layer, we can do it quickly. We're not kind of held up waiting for, oh, okay, I have to wait for the networking layer to put in this basic thing, or I've got it every time we want to do something, networking has to come in and double check. So, or governance has to come in and say, are you using the right tagging? So you really want to have set those previous layers up so that when it comes to actually deploying your application into that layer, this is the only thing that development team has to think about. They don't need to worry about those previous layers. So these layers don't live alone. They do stack essentially on top of each other. So your networking provides that connectivity, routing, DNS, private endpoints which underpin everything else. Your governance sits on top of that with the policy, RBAC, tagging, compliance, and kind of shapes how things work within the environment. And then your application consumes those previous layers where it's using those governance layers to enforce tagging. It's using the networking layers to control communication and routing. And it just sits on top and is able to then provide those workloads and those services for those workloads to use. So when we look at it in this way, though, we're not really just looking at infrastructure anymore. We're really looking at a platform because we're stacking things on top of each other. And that's what really we start to come down to. When we start to look at applying things in layers, we're starting to see that now we're building this platform for people to use. So in this case, where like that network is your base foundation layer, your governance is your control layer, but then after that, with the application, that's just kind of sitting on top. And that's really where we want to be with this. We want to be looking at these environments as a platform for your development teams to be able to deploy onto. And if we treat them as a platform as a whole, we start to kind of reframe how we think about delivering these to our client, which is, in this case, the development team, who then provides value to the business. So really what that looks like from like a golden path here of what you really want is you have a developer that needs a new service. There's predefined patterns on how that's done. So you will have a template, which is that pattern which the developer needs to kind of fill things out. It'll have best practices. It'll already have kind of like security, naming, tags, and that's, again, that governance layer coming into play here, so that when you deploy this template, you know it's going to deploy with these specific requirements. And then once deployed, we know that it's running and compliant. Developers already start shipping to that environment. They're not having to worry about how have I set up my private endpoints, or is the routing in place and connectivity? How do I have to manage the firewalls? All of that's done in that networking layer. So from a developer point of view, you've developed a service, you've used a template to say, here's what the service is, and then you've deployed it and run it. And that's it. You're not having to think about any of that deeper layer, while the platform team looks after, does this layer exist? Have I put automation in place to be able to take that template and know how to apply it to the layer that it needs to be applied to? And can I monitor and make observable all of this environment? And this is where we come into actually the pipeline. And even though we're talking about separating these layers, and especially where we separate them in code, where we have different layers defined in our infrastructure as code, what we're not separating, though, is kind of the delivery of this. We're still talking about when we deliver something, it still needs to go through the layers. So if you do have a brand new application that needs new networking, there does need to be a delivery of that. But this is really where we start to look at it as it's a delivery in order. We're not trying to do everything all at once. We'll start off with the networking. We'll put that foundation in place. If it's a brand new thing that needs some specialized networking or an extension to our networking, that networking layer has to be in place first. Then we have our governance layer. Do we have the right controls? Do we need to modify controls? Do we need to adjust how we're doing tagging? Do we need to add a new cost center? Again, that's put in place before you then go and put your application in place, which then deploys on top of the previous two layers. So really, we want to make sure we're deploying in order, but each of these layers has different owners. So we can manage this in the way that we say, okay, we know that the networking layer is owned by platform, governance layer is owned by security, and the application layer is owned by the application teams. With governance, so when we say owned by security, it could be that security is defining what happens, but again, platform team is the one actually implementing that. So yeah, as I said, when we actually do those changes, there's different impacts. So get new app can affect all layers, where you need networking, governance, and the workload together. But when it's just a new feature, then you only need to worry about the application. Policy updates themselves only affect the governance layer. They're not going to directly change the application layer. There could be impacts on it where it will maybe cause an alert or try and constrain the environment. Then that has to be obviously looked at as a change to further parts of the environment. And then networking routing changes. Maybe you've got a new VPN that needs to put in. It doesn't actually affect the other layers, but it does need to be handled within that networking layer. So when we talk about ownership, what teams are actually owning this? So I've said a few different teams at the beginning where we say different teams have input, but who actually owns the core of this? So if we look at, we've got networking, we've got governance, and we've got application. Now, this is going to depend entirely on your organizational structure. So my answers to this are very much from the look of what I've seen within industry and what I've seen that works well within the industry. So if we start with our networking, that's your platform team. So this team has your network experts, it has your cloud infrastructure experts. So really, this is their bread and butter. This is what they're doing day to day. They are ensuring that the foundation of your platform is in place, it connects, it has all the correct routing, it has its firewalls, it has all of those components in place, observable, monitored, and they know what's happening with that environment. Governance. Now, in this case, I say platform team again, and this is back to that comment of, while other teams have input, it's down to the team that implements, that really owns that particular part of the layer. So in governance, even though you would have security, compliance, all coming in and saying, I want this needs to happen, or finance saying, I need this particular tagging, it's still the platform team that actually goes ahead and does that deployment and sets that up. And then lastly, the application team. In this case, we actually want to ship the ownership of this layer to the app team themselves. And we do that by providing them things like templates and patterns. But really, once we have given that to them and they have deployed their application, we want them to own this layer. Now, this doesn't mean that they own the infrastructure. What they own is things like their monitoring, their alerting. They know what their application's doing in the environment. They've got feedback from that application. So if there is issues inside the application themselves, they can surface it. But this isn't something the platform team needs to own. The platform team does need to provide the automation and essentially the base level foundation for it to sit on. But the platform team themselves don't have to own the actual applications. And this is where we see that kind of the split between what is the core part of the platform, which is your governance and networking, and then what is the actual services being deployed on top of. So what does this enable? It enables faster delivery. So we're able to do smaller, contained changes and ship quickly, especially if we're on that application layer. We're not having to constantly redefine or be worried about the other layers. We're just shipping changes to that top layer. Reduce the cognitive load. So when the app team's thinking about, well, what do I need to know about this environment, they're only thinking the application layer. The governance team is only really thinking about, what do I need to do within the actual governance layer here, and what are the impacts that it's going to have further on. And then the platform team with the networking layer doesn't reduce as much code. They still need to know about the whole platform, but it does mean that they don't have to know so much about the intricacies of the application and how that's all working. Safe changes, so we know what the blast radius is. When we're making a change, we know what the risk profile is. We know what the likely, if this breaks, how much does it affect further down the line. And we can really manage our kind of change management around that to make sure that everything is managed. We know if there's outages, when they're going to happen, things like that. And then we have a clear ownership. So There's no gray zones. Every part of the environment is owned by someone. And those layers have clearly defined teams who are responsible for them. Cool. So that's enough for me talking about it. But how about I actually show you some of what this looks like? So you can see kind of what the code structure of your ISC may look like. So let's quickly just bounce.
Just to note, we've only got a couple of minutes left. So,
yep, all good. So let me switch over this one, bounce here. Okay. So my MacBook keeps deciding to hide screens from me. Alrighty. Cool. So this code will also be up on GitHub. So don't worry if you don't have time to read through what I'm showing. You will be able to go view this on a public repo in GitHub. So what we have here is we have our infrastructure folder, and this is where we start to see the separation come through. So if we look just at the base, we have our layers. So we're defining each of our layers, and this is actually where we define a lot of our core structures of what each layer, and we have specific modules, things like that. So we've got our application layer, we have our governance layer, also governance layer on top of the subscriptions themselves. So we know how we're applying that. And then we have our core networking layer. And these are kind of set, this is your base implementation here. So this is how you do the functional part of this. But what you want to then have is you want your parameters files. So in this case, we actually split them out. So we have our networking parameters. So this is where we start defining the values. So we can know what our different networks are doing and how we're slicing them up. We have our governance layer. So this is where we've got our management groups. We've got kind of any retention for workspaces in our logging. And then we also have policy assignments where we can assign those policies to specific management groups. And then we have our applications layer and with how we define these applications. And in this applications layer, this is where, in this case, is a very simple way of approaching it, but we actually have a structured way for application teams to provide what their application needs. And what we do here is we create a template, and we give this template to the developers and say, please fill this out. And when they fill that out, we can then add this to our list of applications. So when we run the pipeline to actually deploy this, it will go through and check that these applications have all been deployed. So this all then wraps up. So we've got, again, clear layers where we know things are happening. If we need to change anything foundational, we have these layers again split out. And then this means that even though it's in a monorepo and all the code's here, you're only really needing to look at what layers are you really affecting. Cool. So I'll just switch back.
I love this. There's a couple of things that come to mind when I look at this code. One is, the alignment to monorepo seem to be happening quite a lot across the industry at the moment. I think mainly due to agentic context. So, but it makes sense. So you've layered it in terms of those functions, in terms of like the governance and the networking, who they're owned by, and then there'll be a level deeper of going, okay, only run these pipelines if these files in this specific folder have changed, for example. So you don't have to go through and do the full deployment for every single thing a time application gets added. So,
yeah, exactly. So you can shift things as you need. You can use, especially so GitHub, you can use paths in your work, in your actual workflows where you're deploying that to check where changes are. It also helps you validate things and catch issues really quickly as well. Cool. So key takeaways for what we're really talking about is that complexity really isn't the problem here. The problem is coupling. So how tightly have we been coupling these things together? By splitting out these layers, we're reducing the cognitive load for teams who need to use this platform. They don't have to think about those other layers. and really the platform enables speed and safety. So we're able to deploy quickly with confidence, knowing that our applications can land on this platform and get going without having to take a month of back and forth with all the different platform teams and trying to get everything all aligned. Cool. So, and any message I really want to leave you here is that the platform team builds the system, but the application teams are the ones that build the value. So when we're looking at platforms, we're really serving the application teams because the application teams are then serving the business. And if we start to think about it like that, it helps us kind of scope those things a bit better.
Yeah, I like that, and it doesn't compete with the cloud adoption framework either. It works side by side. So
yeah, really all of this fits within your standard cloud adoption frameworks. You're still checking off the same boxes. You're still making sure you're using the right Azure settings. You've got your firewalls, your private networking. You're using your endpoints properly. All of that good stuff.
So we're at time, but before we go to our next session of the day, how do people get in contact with you, like through social media?
Yep. So my LinkedIn is usually my most responsive. Yep, it's just there. And also there's my GitHub. So if you're looking for the code from this demo, then yeah, go check out that my GitHub there. It'll be under Azure Layered Landing Zone. I think it's what I've called the repo. And you'll be able to see that. I'll post it up on LinkedIn anyway, post this session. But yeah, if you've got questions, feel free to message me on LinkedIn. That's where I respond the fastest. But yeah.
Yeah. Awesome. Thank you, Dylan. And yeah, thank you for coming. Hopefully everyone watching this has learned something. We'll skip over to our next session now. So thank you.
All right, great. Thanks.
Hello, everyone. Let me introduce our next speaker, Matthew Levy. He will introduce governing guest access with Entra ID governance. And I will let Matthew to do introduction for himself and start share his screen. Thank you.
Thank you, Shenzan. Good greetings to everybody. It's nearly midnight on my end, so on a Friday night, but it's good to be here with everybody. I will share my screen and I will do an intro within my screen, within my session. Share screen. Hopefully I share the correct screen.
Yeah, let me check. And feel free to leave a comment for your questions. I will monitor the chat and we will have a Q&A in the end.
Awesome. Okay. Cool. So you can see my screen okay? Excellent. So welcome, everybody. This is going to be a lightning session on governing guest access with Entra ID identity governance. My name is Matthew Levy, and I work at a company called Threatscape as a solutions architect focused on identity and access management with a specialization in Microsoft Entra ID. I am a Microsoft MVP in security, specifically in identity and access and Intune, funnily enough. This session is going to be a fast-paced 30-minute session. I will try and do a live demo, so I'll keep things moving. If you have any questions along the way, please hold them just to the end. I've got some time at the end for some Q&A, but the goal for today is quite straightforward. By the time you leave, you will know exactly how to apply identity governance controls to your guest users. And I'll explain how the MAU, or monthly active use billing model, works, so you're not afraid of unexpected costs and where the common pitfalls are. So let's go. So here's just how the next 30 minutes will look. We'll start with the problem, because you cannot solve something if you have not clearly defined it. Then we will do a quick recap of the Entra identity governance capabilities, so that everyone's on the same page, before spending a bit of time on the monthly active use billing model, which is the piece that often causes confusion and inaction in organizations. After that, we'll cover the 4 key governance controls you should apply to guests, and then we'll jump into a live demo showing the Azure billing setup. This is something you can go and do in your own tenant today if you have guests, and we'll finish with some common pitfalls, key takeaways, and then, if there's time, Q&A. So let's go. So let me start. The question is, how many guests do you have in your Entra ID tenant right now? And I'm guessing you probably don't know the answer to that off the top of your head. Don't worry, you're not alone. And that is actually part of the problem. So guest users are often the least governed identities in any organization. They get invited for a Teams meeting, a project, or some kind of partner integration, and then they just stay. Months later, years later, they still have access because nobody reviewed them, nobody removed it, nobody thought to even ask. And it's not just stale accounts. Guests routinely have access to sensitive SharePoint sites, Teams, channels, line of business applications. And so when a partner employee leaves their organization, your tenant has no way of knowing that automatically, so their account keeps working. And just incidentally, in an Entra ID tenant, the all users group includes guests as well. So the reason most organizations do not tackle this licensing confusion in terms of governing identities and guest identities is people hear identity governance and immediately think that requires the identity governance licensing for everyone. While that's true for member accounts in your tenant, that's not true for guests. And today I'm going to show you exactly why. But the bottom line is this: guests are often the biggest identity risk that you are not managing. Before we get into that billing model, let me quickly ground us in what Entra identity governance actually gives you, because governance is a broad term and it helps to be a bit more specific. There are 4 main pillars, and if we look at an Entra tenant, I've highlighted the identity governance piece. First, we've got entitlement management, which is how you bundle access into packages and let users request access in a structured, auditable way. Second, access reviews, which are periodic recertifications of who still needs access to what. By the way, there's a new AI-driven recommendations in access reviews now, so add some AI to the mix. Third, we've got lifecycle workflows, which can automate identity tasks when users are created, they change state, or if they're removed. And fourth, privileged identity management for just-in-time elevated access. Maybe a little bit less relevant for most guest scenarios, but it's worth knowing about for elevated partner accounts. And incidentally, you don't need identity governance licenses for PIM. You just need Entra ID P2 licenses. And as long as the tenant is licensed for that, guests can leverage PIM. For guest governance, however, the two you will use most are the entitlement management and access reviews. Those two cover the vast majority of what you need to govern identities properly. So this slide should remove the number one blocker to guest governance in most organizations. A lot of people get confused about what, how would you license your guests? There used to be a rule of thumb of 1 to 5, where one member account meant 5 guest accounts could be licensed or utilize the features that you're licensed for. Microsoft introduced the monthly active user billing model, or MAU, as a pay-per-use model for external identities within Entra ID. So that is basically a ticker or a tracker that's linked to an Azure subscription. It's not a per-user identity governance license assignment, and you can leverage the identity governance features as long as you have a single identity governance license in the tenant. The key difference compared to identity governance licensing is that you are charged based on how many external users actually authenticate in a governed month and leverage any of those identity governance features, not based on how many guest accounts exist in your directory. So if a guest account sits dormant and never signs in, it costs you nothing. The right-hand table here is a summary of the comparison. The key message: both models give you the same governance features in terms of internal member accounts, whereas monthly active use just costs far less for external user scenarios. So this slide is one of the most practically useful slides in this deck, because this is where billing confusion actually lives. And so I'll go through the pros and the cons, or the, what it is and what it isn't. So monthly active use billing is triggered when a guest user authenticates and actively uses features that are exclusive to Entra ID governance. So if a guest signs in to request an access package, that is a billable monthly active use event for that calendar month. It's once per user per month, regardless of how many times they authenticate. What does not trigger billing is equally important. An admin viewing or editing a guest account in the portal, that's not billable. A member user completing an access review on behalf of a guest, that's not billable. Creating or configuring access packages, not billable. A guest account that exists but never authenticates, not billable. So at the bottom of the slide, you can see the one thing to remember is billing is based on authentication events, not identity count. Dormant guest accounts cost nothing from an MAU perspective, though they are still a security risk, which is exactly why you should be running access reviews on them. This model helps you in predicting and controlling costs much more accurately. Now let's talk about the 4 controls you should actually implement. This is the practical meat of the session. Access packages are your starting point for structured guest onboarding. Instead of ad hoc invitations and manual group assignments, you can create a package that bundles everything that an external partner needs. A Teams channel, a SharePoint site, maybe a group based app assignment, and they request it through the My Access portal. You define who can approve, how long access lasts, and what happens when it expires. This is the right way to onboard external collaborators at scale. Access reviews are how you keep things clean over time. You schedule a quarterly or annual review, assign reviewers, potentially the resource owner or the guest sponsor, or even the guest themselves, and you set the policy to automatically remove access or deny a non-response if they don't respond to that access review. So this is your primary tool for eliminating stale guest access without manual effort. You can create just a stale guest access review as a once-off and clean up all your stale guests to start off with, and have recurring access reviews for guest accounts. So entitlement management is the broader framework around access packages. So you define connected organizations for your trusted partner domains so that guests from those domains automatically can qualify to request certain packages. This also incorporates the cross-tenant access policies that you may have set in your tenant. And then lifecycle workflows let you automate what happens at key moments. So there's trigger points or trigger moments when an access package will then expire, or when a guest account is flagged for removal, or when you want to send a reminder because before access is revoked. So that kind of like governs the life cycle of the guest accounts and closes the loop on that governance cycle. So together, these 4 controls give you a complete and auditable guest governance posture. All right, so next up, I will switch to a demo, and I will show you how to set up the billing. I just want to confirm that you can still see my screen, although I've shifted to the Entra portal. Can somebody give me some confirmation? Okay, I'm going to continue, assuming that you can see, because I haven't heard anything. So in the Microsoft Entra Admin Center, under Identity Governance, if we go to the dashboard, you'll see it brings up some of these tiles, and this tenant has got at least one identity governance license assigned to a user, a member user, not guests. And so this tenant is licensed for identity governance. And you'll see here, there's a tile, guest access governance, and it's saying identity governance for guest access is a premium add-on. We have the license, but we need to enable the monthly active use billing, and that's this Get Started button. So I click the Get Started button, and it prompts me to select a subscription. So I'm just going to select another subscription. It's recommended to have a dedicated identity governance subscription, so that you can separate the costs for the governance features. It does give you at the top an indication of how much it costs, 75 cents US per guest user, billed monthly. That's what I mentioned. And we need to create a resource group or select an existing resource group. I'm actually going to create a new one, and I'm going to call it ANZ MAL. All right. Now, just one thing to note, you need to be an owner. So this user needs to be an owner on the subscription or the resource group if the resource group exists already, to be able to turn this feature on. So I hit the turn on button, and it does take a couple of seconds to notify me that it's created the resource group, and it has also put a management lock on it, and it has then enabled the monthly active use billing. And so now we basically have the ability to manage those guest accounts. So we can go into entitlement management and create access packages. We can do access reviews and review stale guest accounts, etc., etc. So now we can leverage those identity governance features, and we'll get billed for guest accounts that use those on a monthly basis. Just incidentally, if that get started button is not visible, it's not in here as a tile, you can go to the Entra ID external identities blade, and then go to linked subscriptions. And you can link a subscription here in the similar way. However, this is linking a subscription for external users, for external IDs, for example, but it basically requires the same kind of Azure subscription linking. So you can come in here and link a subscription. Funny that it doesn't show that subscription listed. Okay, the other thing that I want to show you, and I just want to check my time, is you can create, and it's recommended to create a budget for external ID or Entra identity governance. So in Azure, in the subscription, come into cost management and go to budgets. And I recommend creating a budget, and you can filter for specific metrics or meters in the subscription. Give it a name, the period that you want it to reset, and recommend starting with $50, for example. And then you can set thresholds that will then alert you and notify you according to where you are on that budget. All right. And from within this, you can also view your current monthly active use consumption. All right, let's go back to the presentation. And so I just want to go through the common pitfalls and cost controls. So the first pitfall is not having the correct permission on the target subscription, or at least the resource group where you will be linking MAU. So you need to be an owner, as it says in the documentation. The second pitfall is not setting a budget alert before you start. Maybe a large Teams meeting where hundreds of guests authenticate could create a spike and create a surprise from a billing perspective. It takes you 5 minutes to create the alert, a budgeting alert, so just do that. The third pitfall is the most common misunderstanding, confusing MAU coverage with Entra ID P2 coverage. MAU billing covers governance features for external users. If you want PIM for internal users or access reviews for member accounts, those still require identity governance licenses or Entra ID P2 and assigned to those member users. But guests can leverage the P2 features at no cost without an MAU linked subscription even. MAU does not replace ID governance for everything though. It replaces it specifically for external user governance scenarios. The fourth pitfall is linking the wrong subscription. If you link your primary workload subscription, your external identity billing gets mixed in with compute, storage, and everything else, making cost attribution very difficult. So use a dedicated subscription for identity related costs. And then the two tips at the bottom are just positive things. Use access package auto expiry as a feature, and run quarterly access reviews. Both of those will reduce your active guest account, which directly reduces your monthly active use exposure and your attack surface at the same time. So let me just bring it all together with 6 things I want you to remember. Number 1, you can govern guests without ID.gov licenses for them. MAU billing covers the full feature set for external identities. Just need to have an ID.gov license in the tenant. Number 2, provided your tenant has an ID.gov license for member users, you can govern guests. Number 3, entitlement management and access reviews are your highest value controls. If you implement just these 2. Fourthly, billing only triggers on an active guest account utilizing a governance feature. A dormant guest costs nothing financially, but it's still a risk operationally and from a security posture perspective. Number 5, link a dedicated subscription and set a budget alert before you start. Number 6, start with access reviews. If you're not sure where to begin, they are the fastest win. You'll reduce stale access, reduce monthly active use exposure, and improve your security posture in a single access review. So after today's session, run an access review against all of your guest users. That single step will show you exactly who you have, what they can access, and give you a defensible, auditable process for cleaning it up. And this is my thank you slide, and I've got some resources. There are some links to read. You can access these slides if you go to my GitHub repository. So thank you for joining the session. If there's some time, I can take some questions.
Okay, thank you, Matthew. Thank you so much. Let me have a look at the comments. No questions so far. I think it is all because you have a really clear guidance on the topic. And this is really something exciting, which align with our Azure landing zone best practice. We can link the Entra ID cost to the identity subscription, set up the cost budgets, and also easily to make a cost control from a central place by using the cost management. That is really an awesome feature to know today. Yeah. And I think we are almost right of time. And for the audience who may have any futures in the future, feel free to reach out to Matthew, as he has already shared his contact info. And I think, thank you so much, Matthew. Thank you for your effort to make the session in your late evening. Really appreciate for your effort. Thank you so much.
You're welcome. Thank you, and enjoy the rest of Global Azure, everybody.
Okay, thank you.
Thanks
then we will hand over to the next speaker. Thank you.
Hello. Yeah, how you doing, Rory?
I'm well.
Good. Yeah. So next we have Rory. Rory is the Microsoft MVP for identity. He's going to talk to us about Azure B2C migration to intra-ID external ID. And yeah, the floor is yours, Yufori. Thank you.
Hi, can you see my slide?
Yep, I can.
Awesome. So, hi, everybody. It's 10 a.m. in Auckland, New Zealand, and I'm going to be talking about Azure AD B2C and the migration kit to enter external ID. So just a bit of context. If you have a company with an online e-commerce site, the people inside the company doing Teams and SharePoint and M365, they'd be using Enter ID, but all your customers that buy stuff from you online would be using Azure AD B2C, which is the SIAM product, so customer identity and access management. And basically it's massive scale. You know, you're talking like 400 million users in some cases, and also self-service, because you don't want 400 million people to contact your help desk. Now, there are hundreds of thousands of Azure AD B2C tenants, but Microsoft has decided that in 2030, they are going to turn it all off. And the successor that they are pushing is called Enter External ID. And so there's a huge amount of users and tenants and stuff out there that need to migrate to this new database. And that is obviously a huge job. So they have they've started to introduce a tool that does all this for you, or some of it for you. So there's a lot of things that you can migrate. You could obviously migrate users, you can migrate passwords, maybe using just in time. You can migrate email and username logins.
Hey, Rory, mate. Sorry. Rory.
Yeah.
The team is telling me there's something wrong with the slides, as in you are sharing the slides from the other side, or like I can see migrate what right now.
Yeah.
This is the second slide, right?
Yeah, it says migrate what, and then underneath it says users, passwords. You can't see that because it's the same slide.
Yeah, I think I am seeing both slides, as in like the current slide, and then I'm not sure. I'm seeing like the presenter view, maybe.
Must I take off presenter view?
Oh yeah, so like right now we are seeing the presenter view. So yeah.
So how do you take off presenter view? I've never done that before. Is there a presenter view here? Oh yeah, there we go. Let me take that. Okay, it's turned off now.
Okay, and then present again.
If I now go from beginning,
right?
Is that
yeah,
better?
Yeah, it's so much better. Yeah, if you click next and next, yeah, sweet. That's brilliant.
You can see the whole thing. You can see the words now. Yes.
Yeah, it's all look good now. All look good.
Go ahead. Good. Okay.
Sorry for interruption.
So,
go ahead.
Yeah. No worries. Okay, so user flows you can sort of migrate because the way B2C interacts with the user flow is different to the way that external does it, but you cannot migrate custom policies, which is a major feature in B2C, and that is causing quite a lot of angst, shall we say. Okay, so you can migrate your custom attributes, you can migrate your federations, self sign up, sign in, password reset. There is no profile edit at the moment, and you can migrate all your MCell configurations. MCell is the Microsoft library that the app uses to talk to Entra. Okay, so how would you do this? So obviously, very, very simplistic way is you can use Graph API, you can read all the users, you can write all the users, and then you can send all the users an email saying, dude, we have migrated you, please go and reset your password. Now that's not a very good plan if you've got a ton of users. Another way is to migrate the users, but set them up in intra-external ID so that they use email OTP, right? So now you don't have passwords, so that solves that problem, right? And there's some other ways that I'm going to go through now, which is using an Azure function, a hybrid approach, just-in-time migration, and the migration tool. So if you've got a custom policy at the moment, you can imagine that inside your custom policy, there's a call that says, read user by object ID. Now you can take that call out and put in a graph API call, and the graph API call goes to Cyan, which is on the right-hand side, going through an Azure function. So now you're still using the custom policies, but all the users and all the action is happening inside of enter external ID. And so that means everything is ready for the final migration when you migrate the app over. And when they turn off B2C, you've done a ton of preparation already. Another alternative, and this hasn't got to GA yet, but it's been talked about. You can imagine one of the things they've done is they've put enter external ID, the tenant, into an Azure AD B2C tenant. So B2C apps talk to the B2C endpoints, and enter external ID apps talk to the enter ID external endpoint. The artifacts are slightly different, as I've just discussed. The app registrations are exactly the same because it's still client secret and client ID and all that good stuff. But they're in the same user directory, so there is no migration. You could reset a password on the B2C app, and you could log in with that new password on the Enter ID app. So that's another approach that you can look at. Now, just-in-time password migration is something that they have introduced to do just-in-time migration when the user logs in for the first time. So basically, imagine you've migrated all the users over. You can't migrate the passwords, so you've given everyone a random password in Enter external ID. So the first thing you do is you migrate them with this random password. Now, the user signs in, so step 2. And then what happens is we ask the user to log in, and they are going to use their B2C password, which doesn't match the password in Enter external ID. And at the same time, when we migrated them, we set an extension attribute, something like require migration equals true. So if the passwords don't match and the flag is set, that causes a kick into a custom authentication extension that calls a Azure function, and the password and the email is passed across to this Azure function. It's encrypted, so the Azure function has to decrypt it. And that function then calls B2C and says, is this a valid credential? If it is a valid credential, we then take the password that they were using in B2C and we write it to enter external ID. So now we have seamlessly migrated the password from B2C to enter external ID, and it's done seamlessly, transparently, just in time, whatever words you want to use. Okay, so that's kind of a background of where we were until they introduced the migration kit. So the migration kit is a massive GitHub sample that has all kinds of stuff in it, and really, it'd probably take you 2 to 3 days to really get through everything. So the 3 key components are a kind of rich set of CLI tools with 5 bulk migration commands. So export, import, harvest, worker migrate, and phone registration. And I'll discuss the last 3 soon. We've got the Azure function that I've just told you about. And there's a whole lot of PowerShell and C# and core services that are shared across the whole kit. So there are 2 modes. There's a simple mode and there's an advanced mode. And the kit really is, at the moment, is primarily around users and passwords. So the first step is you run a script that exports all the B2C users to blob storage, and it puts it into different blobs. So maybe 200 at a time in each blob section. And the idea behind that is because Graph API has throttling. So you do one blob, wait a while, next blob, wait a while, next blob, wait a while. Once you've exported the whole lot to blob storage, you then import them into enter external ID from blobs. So you run another script which goes and reads all the blob storage, all the attributes, and imports them into enter external ID. Obviously, the passwords are just random. So when the user logs in, you get the just-in-time password migration that I discussed earlier. Now, the advanced mode basically is around phone numbers, MFA, and all that kind of thing. So what it does is it gets the B2C user IDs and it enqueues them in batches, but not Azure storage, not blob storage, it puts them into a queue. And then the worker migrate takes out the IDs, fetches those IDs, fetches the user information from B2C, creates them in Enter ID, and gets all the phone and MFA information and enqueues that on another queue. And then the phone registration fetches all those details from B2C and registers them in EID. And obviously, that is all throttled using all kinds of throttle mechanisms that are built into the kit and are configurable. So there are a ton of scripts in this thing. For example, at the top, you've got configure enter external ID. That sets up all the stuff that we've been talking about. It sets up keys because you need keys to encrypt. It sets up the custom auth extension. It sets up the event listeners. It sets up app registrations, creates a test app for you to use for testing. It does a ton of stuff, right? And then on the right-hand side, you can see at the top, start local export, local harvest, local import. So those are all the scripts, and it's all PowerShell. So again, you can change it to suit your requirements. So that, yeah, like I said, there's a ton of scripts. And there's a massive app settings.json. So it has different sections. So we have an export section where you can select what you want to export. You don't have to export everything. And you can see that you can export extension attributes. We have an import section in the JSON. So we can map stuff. For example, in B2C, we call this extension attribute legacy ID. Well, that doesn't make sense anymore. So let's rather call it custom ID in extension in enter external ID. We can exclude fields that we don't want to migrate. And we can add extra attributes. So for example, we can store the B2C object ID in the enter ID user. So we now have a link between the user in enter external and the user in B2C. So if we need to do any troubleshooting or anything like that, we have this link between the two. That's the flag, that's the name we're going to use, for the just in time. And then we can tell the toolkit the name of the attribute that is used for just in time. Now I'm just going to, unfortunately, I cannot, why can't I see? No. Why can't I see my browser?
I think you need to, yeah.
You can see
I can
that?
see the browser. Yep, I can see.
Okay, so the problem is that if I run the script, it exposes a ton of tenant information that I don't want to expose because it's being recorded. So this is in my blog. So this is how I'm just going to so here are the keys that you use for encryption. And there's a script that does all that. And then down here, you start running the keys and it'll tell you it's created. It creates self-signed certs. Okay, and then you have to do some work here about copying these keys into the app settings.json, do a bit of work with the custom attributes. Then when you try and run the script, it uses device code authentication. So it does that, and you set up permissions and stuff. And then it starts running the script, right? So the first thing it does is the authentication. It configures the custom extension apps, configures all kinds of stuff, sets up all, gives it admin consent, API permissions. It configures the encryption certificate. It creates the custom extension policy. It creates the test client for you. It creates the event listener. And then it gives you a whole summary down the bottom. And then it tells you, hey, you need to go and do all this stuff next. Okay, so there's a ton of stuff there that you can get into. All right, so just hang on, let me go in. share my screen again. All right. And I just want to. All right. So this is the local export. So this is the script that does the export. And so it validates that you've got a config file. It detects if your emulator is running, if you want to run it locally, creates the blob storage, rebuilds everything and runs it. And so you can see there's a ton of stuff in the configuration file. You can set up your password policy. This is where you configure your B2C stuff, your B2C, your tenant name and app registrations. The same for there, enter external ID, what storage you're going to be using. If you want to run it in production, obviously use key vaults. You can set up retries and delays for throttling, all the kind of extension attributes and stuff, the size of the batches, the size of the pages. And then when you run the script, it basically starts the export and you can see it just reads through the users. And at the end, I only did 4 because I don't want hours and hours of migrating users. So, and then because we talk about B2C, we have millions and millions of users. It gives you all kinds of projections for, obviously not very accurate if you only got 4 users, but how long it would take for 1 million users, right? So it's going to take a fair amount of time, but it does give you a whole lot of good stuff. And then at the bottom, it gives you a summary. So there were 4 users that we imported into Blob, none failed, none skipped. We didn't need to throttle in. Okay, so that is the export. And now if we go and look at the import, so basically it does the same kind of stuff, does a whole lot of checks, and then it starts to run and it goes through every user one by one. And so it goes through, check stuff, it makes sure all your target, you need to make sure that all your custom attributes are already set up in enter external ID. And then it finds one file to processing 4 users. Now, enter external ID has to have an email address. So if you don't have an email address in B2C, it tells you that it's going to use the UPN as an email fallback because you have to have an email address. So it goes through every user and tells you, did it work? Did it not work? This is what was wrong. So you can go through, fix the problems, run it again. And I ran this on users that I'd already basically imported. So, it just, it processed 4 users, but didn't actually import any. Okay, so that's how that script works. Now, if I go back to here and start from current slide. All right, now there's 2 ways of running this. The one way is running it in test, so you can go through a whole lot of stuff before you actually do the import and the export. And there's a way of actually running it in the cloud. So when you're running it locally, you can run your Azure function locally. You can use local keys. Obviously, B2C and enter external ID need to talk to your local host. So you have to use ngrok, which is just a proxy. And you use the Azure Blob Storage emulator. So you can do everything locally, the just-in-time, the Azure function, everything you want to, and it'll just work. When you run it in production, and there's actually a script that swaps the 2, so you can go test production as you find errors and as you fix them. So obviously the Azure function runs in the cloud. We're not going to be using local keys. Of course, we're going to be using Key Vault. We don't need ngrok because it's all in the cloud, so there's no problem with access. And we are going to use Azure Blob Storage, right? The real Azure Blob Storage or the real Azure Q Storage. And at the end of it, again, this could take quite a long time depending on how many users. But again, you don't have to do them all at once. You can say, just import, export this number of users, do a bit of checking, do the next blob, do the next blob, do the next blob as you wish. So you can stage it. And hopefully at the end of it, you have moved all your users from B2C to enter external ID. And then the last step is you take your application, which is using MSOL, and inside there, there's a JSON file that contains the tenant ID, the tenant name, the client ID, and the client secret. And you replace those four with the equivalent information in enter external ID. And then basically you've switched over. And when the user signs in for the first time, they use that just-in-time migration that I showed you to migrate their password. And so basically from then on, you are now running in enter external ID. And so when they turn it off, okay, it's all good because everything's been migrated. Okay, I have some references. Now, if you want to see these slides and actually get the references, you just have to Google Rory Braybrook presentations, and there will be a link in there to the slide deck, and inside the slide deck are all these references. So yeah, how are we on time? So 25 minutes, that's cool. Ahmed, are there any questions?
Yeah, I see a question from Matt here. The question is, migration script seems rather complicated. How does the migration process handle human error and where you might have missed like a line of code in the script or made a typo and so on? So like it's basically about like troubleshooting and how smooth is the migration?
Yeah, so there is a whole lot of tooling to do logging, and which I haven't discussed. So there's a ton of stuff about how you log it, how much you log, which you can use to debug it. In terms of making a mistake in the script, yeah, I mean, basically you can just use the scripts as they are. I didn't change the scripts. But if you, at the end of the import and export, there is a summary. It does have the errors. The errors are highlighted inside the script when it's running. So you can use that, or you can go and look at all your all the logs that you've created.
Nice.
But again, you know, I mean, the way to do it would be to, you know, run it in test first, make sure that it's all good, and then run maybe one batch, because remember at this point no one's using external ID, and you're not ever writing to B2C, so you're not screwing anything up. So maybe run one batch, see how that goes, run the next one, see how it goes, and then slowly build up to, you know, actually migrating the whole lot.
Yeah, that is brilliant. And a question of mine, which is like, how do you see intra ID, external ID? How do you see it compared to B2C? Have we lost any like some functionality or flexibility that was only B2C, or do you see intra ID, external ID actually much better solution?
So at the moment, enter external ID is not feature complete with B2C, but they are adding stuff all the time. So it is getting more and more and more feature complete. And it also, obviously there's things that they're going to add, things like pass keys, things like you know, Microsoft Authenticator, all these things are on the roadmap, which will never be in B2C because B2C is code complete. So all the modern, shall we say, security features are in enter external ID. The big one is the custom policies, because they allow you to create workflows. And I don't think Microsoft has actually documented recommended approaches for custom policies yet.
Yeah. It always that always happens when like a tool, you migrate to a new one. There's a lot of customization that you might end up losing, and it takes a while for the new modern approach to catch up. Sometimes some of the old customization is no longer needed. So because the new technology has like removed the need for that. I don't see any other questions. That's all good. Thank you, Rory. Appreciate your time.
Well, thank you, everybody. Thanks for the opportunity. And yeah, there's 2 minutes left to the half hour, so So
Yep. Is there a place for people to reach out to you or communicate? It's just like search Rory and then they can reach out.
So if you just search Medium Rory Braybrook, you'll see my blog. You can, if you look for me on Authory, you can ask me questions, or else you could just connect with me on LinkedIn. There's only one Rory Braybrook in LinkedIn.
Yeah, that is brilliant. Yeah, I really encourage people to reach out to Rory for any questions, or if you need Rory help in something that you're currently working on, look him up. He is, as I said, he is the identity guy, and he's got tons and tons of experience there. So thank you so much, Rory, again. And yeah, thank you for your time.
Thanks, everybody. Bye.
See you, mate.
And we're back. Our next speaker, Renato, how are you?
All good. How about you? Long time no see. So 2 weeks.
Time, hey.
Yeah.
Well, thanks so much, Renato, for joining. Like you're bringing a really interesting topic, right? That's like you're building intelligent agents with the Microsoft agent framework, right? And if you have your screen and would like to share, then we can bring it up.
Yeah, let me share my screen. So it's a pleasure to be here and also to share a little bit my knowledge because I'm learning a lot of things with Agent Framework. So we have been using this solution. So yeah, I shared my screen.
Awesome. Thanks so much. The floor is yours.
Thank you very much. So hello, everyone. So first of all, thanks for to be here, and also it's a pleasure to share my knowledge here, and also it's a pleasure to share my knowledge in a Australian event. So happy to be here. So it's been amazing. So I was learning a lot of things about security in the previous session and the best practice and so on. So it's good to learn. And also we have a few good sessions in the first and in the evening as well. So right now is like Friday evening for me. So it's 7 p.m. But yeah, the idea for the next 30 minutes is to discuss a little bit about the agent framework. If you have any questions or comments, feel free to drop your message in the chat. I can answer during the session as well. But yeah, we can see a lot of things about AI. We can see a lot of AI solutions and people in general are trying to build agents and try to implement in different places and try to make it production readiness, and also make it available for their employees. But the main challenge is when we are using AI, sometimes we don't have enough details, or the data is not prepared for the AI, or sometimes we have some challenge with the quality of the response. So I have been working a product, AI product, since last year, and the main challenge is the adoption and to understand the user behavior. So we have a couple of challenges when we are talking about AI and agents. So in today's session, the idea is not to just simple build an agent, but to understand how can we leverage our agents to the next level. So first of all, let me introduce myself, quick introduction. My name is Renato Romão. I'm a Microsoft MVP in the business application and Microsoft Foundry categories. So I have been working as a software developer for 12 years. And also I started with .NET, so it's a pleasure. If I'm not wrong, the first global Azure I present a session, it was like 8 years ago. So yeah, it's good to share my knowledge. And also I have most of the content that I share on LinkedIn is about Microsoft Foundry and Copilot Studio. But yeah, if you want to learn more about both technologies, feel free to connect with me on LinkedIn. So the agenda for today is introduction, the architecture, the demo part. So we will discuss about the agent framework in a bit. So what can be done with agent framework, what are the best practices when we are using AI solutions and so on. So let's go to the next slide. So agents are the next layer of application logic. So we can see a lot of people trying to build agents, but as I mentioned before, people are just building agents to implement AI solutions. People are not thinking about the main problem and to solve problems with the AI and the agents. So in this case, we can see Lovable, .dev, we can see what else? Cloud Code, we can see ChatGPT, and also we can see a lot of AI platforms that we can build solutions quickly and agents. But the main problem is we are resolving a lot of problems. We are resolving with the AI space and so on. We automate the process, but we are not governing it behind the scenes. There are no governance when we are implementing AI solutions in Cloud Code only. So we need to understand the best practice, mainly for enterprise solutions or enterprise companies. So for small companies, that's fine. We can start by using Cloud Code or Lovable. But when we are going to a medium and enterprise companies, sometimes we need to understand the best practice, where the data is. We need to understand the governance structure, the architecture, and the security place, and so on. So in this case, we can build application quickly with agents. The agent can build application as well. So we can create some agents to build the applications. But how can we build a solution that can be autonomous? We can have autonomous agents. We can see, we can connect to different platforms. So we can create an agent, connect to SAP or Microsoft 365 or any other platform that we have, Excel or PowerPoint or any other platform, or Google Drive, Google Sheets, and so on. So how can we connect all of them in just one single place? And also the main, another challenge that we have, 8 in 10 enterprise use agent-based AI today, but most of them never make it to production. So as I mentioned as well, so I've been working a product, an AI product since last year. And also we saw a lot of people buying the products and installing the product in their companies, but not trying to use or not using them on the daily work. So it makes the agent not useful, and people are uninstalling, or people are not paying for the monthly rate and so on. So this is the main gap. as you can see, we can see, so when we are building agents in Microsoft, we can use agent framework, we can have Microsoft 365 Copilot, we have Microsoft Foundry agents, we have the agent framework that we can build custom agents behind the scenes, we can connect to LangChain, LangGraph, and so on. But the main problem is we are building agents, but what is the problem that we are resolving behind the scenes? So Microsoft released in October 2025, so 7 months, 8 months. So Microsoft released this product called Agent Framework. It's not a product, it's a framework, SDK, that you can install in your machine, you can install in your projects, and also you can develop based on that specific project. So in this case, you can customize your agents, you can build on top of that, and also you can deliver solutions and agents under the Microsoft layer. And also before that, we had semantic kernel that has been released has been launched in 2024 or 2023. And also we have AutoGen. Both are good, but they have different limitations. So AutoGen is really good when we are talking about multi-agent and orchestration behind the scenes and so on. So basically, Microsoft decided to unify both of them and to have a framework that we can build .NET solutions and Python solutions customized with agents. So this is a table. I will share the PowerPoint presentation with you later. So feel free to take some screenshots if you want, but I will share the PowerPoint presentation later. There's no problem. But yeah, Microsoft Agent Framework supports several types of agents and accommodate different use cases when we are talking about AI solutions in general. But yeah, you can build AI agent in .NET, and also you can build based agent in Python. And basically, you can use different agent types as well right now in Microsoft Agent Framework. So in this case, Microsoft decided to unify the best of both solutions. So right now we have multi-agent, we can connect to MCPs. So if you have like MCP of HubSpot or WhatsApp or Telegram or any other platform that is not inside Microsoft, instead of developing the integration, so you can just connect as an MCP and the AI can connect directly. So this is really good. And also we have the main point here when we are using Agent Framework is the observability, because right now we have more visibility about our agents and also the things that are being executed behind the scenes. So for example, just to let you know, one of the challenges when we are using AI agents is because sometimes we are building agents. We know that the agent is working as expected, but how can I understand the user behavior? So once we have the observability connected behind the scenes, we can understand when the user send a message, they are expecting to receive that specific response. So they are expecting the message is going to the Microsoft Azure AI search, searching for those terms, finding the response, and then going to SharePoint, connecting to SharePoint, and then going to the Azure, combining both of information, and then like have a bullet point list with all in output messages. So in this case, this is the user expectation. But once we send a message to the agent framework, to the agent behind the scenes, the agent is only retrieving the memory on the large language model and responding it to the end user. So this is not useful because it's not retrieving the data behind the scenes. So once we have the observability connected behind the scenes, we can understand that basically the user is sending a message and it's not going to the correct way. And also we can see the second message of that specific user. And the second message is a complaining about the system. So you are not using the correct information. You are not sending the correct information. And then we can use the observability to train the AI. We can understand the user behavior. We can use like sentiment analysis. We can implement any type of solutions behind the scenes just to understand how can we improve the solutions, not only for that specific user, because if it's failing for that specific user, probably like other users will face the same issue. So in this case, you can understand the user behavior. I know that most of the people that are building agents are technical, but once we are releasing the agent to companies in general, people are not technical. Sometimes we need to understand that people that are using agents, sometimes they have no experience with ChatGPT, Cloud Code, or any other AI solution. So sometimes they are sending, what is the message? What is the table? Where is the table value? But there's no table. There are like 10 or 15 different tables in the same data, in the same document. So in this case, you need to understand the user behavior. Once you understand it, you can improve the agents for your company. So this is the architecture, not the architecture, but the options that we have when we are using agent framework. So we can connect to so let me reduce the, yeah, here you go. So we can connect to Microsoft Agents SDK. We can connect to Copilot Studio. We can connect to Microsoft Foundry. This is not the main solutions when we are using agent framework, but this is one of the options that we have, because most of the people that are trying to use Microsoft Agent Framework sometimes have their agents in different platforms as well. So instead of building one agent in Copilot to do another agent in Foundry and have two different agents in different places, you can centralize everything in the Microsoft Agent Framework. So you can connect to them, you can receive the same, you can use the same response, you can have the same experience, but you're using different platforms to connect to them. And also on top of that, you can connect to Twilio, WhatsApp behind the scenes, Teams, Copilot, and also as a database, we can connect to MongoDB, Gemini, Anthropic, and different SQL Server, Azure Blob Storage, Azure AI Search, and different other platforms. So this is one of the benefits by using Agent Framework. And also, if you want to build your simple agents, so this is not like a joke, because sometimes people are, you can create your agent in 5 minutes or something like that. But yeah, this is not a joke. If you want to type this type of code, you can. This is not enough. Sometimes you need to have a solution if you're using .NET. But yeah, this is simple. With simple information, you can create your agent. And then you can put more details. Of course, sometimes you need to connect to Excel. Sometimes you need to connect to SQL Server. Sometimes you need to connect to Azure AI Search. But if you want to build an agent from scratch, you can create in 5 lines or so. So in this case, this could be simple when we are using agents in Agent Framework. So basically, you can pass your project in Foundry, you can pass your credentials, and then you can have your output. And also one of the things here. So I've been working with Agent Framework and Microsoft Foundry for a year. And also during this period, Microsoft renamed and rebranded the solution. And also previously it was Azure AI Foundry, then we had Azure AI Foundry, and in the last few months we had Microsoft Foundry. And also during this transition, previously we were creating Azure OpenAI projects in Azure, and then we were creating our models based on the Azure OpenAI resource. But the problem right now is we are creating first the Microsoft Foundry project, and then we can create the model inside the project. So in this case, if you are trying to use Agent Framework, be careful with that, because in the second line, in the third line here, you are passing the Foundry project credentials. If you are passing your Azure OpenAI credentials, because if you are using an old version, an old resource, you need to switch the dependence, otherwise it will fail. So in this case, be careful with that, because for the demo, sometimes we are creating with AI, sometimes we are using a Cloud Code, or we are using GitHub Copilot, and also in the most of the documentations we have. So I have another, let me check the battery. Yeah, this one is ending, but I have another one, that's fine. And also most of the AI solutions, the large language models structure are explaining that we need to use Azure OpenAI. But yeah, the new library, we must use Microsoft Foundry project. So this is like a provider comparison that we have. So we have, so as I mentioned, we can connect Microsoft Agent Framework not only to Microsoft 365 Copilot, not only to Copilot Studio, not only to Microsoft Foundry, but we can connect to LangChain, LangGraph, Anthropic, and different platforms as well. So we can use Agent Framework as an accelerator to build different agents in different platforms. And also this is like a comparison and also possibilities that we have, and also the limitations that sometimes we have when we are connecting to different things. So in this case, if you're using Agent Framework with Copilot to do, you can only use function tools, not structured output, code interpreter, file sort, and so on. So be careful with that when we are using with different platforms and integration as well. So another benefit when we are using the agent framework is the workflow orchestration that we have behind the scenes, the patterns that we have behind the scenes. So this is the 5 orchestration patterns that we have. We can use sequential, concurrence, handoff, group chat, and Magentic. So in this case, we can send a message and we can have different agents, and the agent, or we can have a like supervisor, the main agent, and the agent can decide the best practice and the best way to go to different places. So in this case, we can like use different user like AI behavior to go to different places with agent framework. And also another benefit when we are using agent framework, we can connect to like a human in the loop. So in this case, we can have an approval process in the middle of the agent execution. So in this case, we don't need to go directly to the AI and just skip the human. So in this case, for example, if we are building an AI solution for invoice process, so once we are receiving an invoice process, I need to process those information, and then I need to like orchestrate it. And depending on the value that we have on the invoice details, I can go to different places. But if the invoice is not correct, I need to send like a human. I can connect to a human in the process, and also I need to send to the HR to approve the invoice first. So in this case, we can connect to a human in the process, and depending on the value. So for example, if the total amount is over $100,000, so you can go to a human in the loop. Otherwise, you can skip it and approve automatically. So in this case, this is really good. So let's go to our demo part. So I built this agent. So it will be free for you in the GitHub. I will put it as part of, I can share the GitHub repo later with you in the chat. But if you want to download this project, if you want to build on top of that, feel free to connect it. So basically, I built a simple agent. So with AI, so I was using Cloud Code and GitHub Copilot to build this platform. But the idea is to have a FinOps agent using Agent Framework connected to Microsoft Foundry projects. And basically, I can upload my requirements to the AI, and the AI can recognize not the questions only, but the project requirements. And also, depending on the project that I have, they can like have some highlights or something like that, using the best practice. So in this case, I was using Agent Framework and the FinOps framework. So this is one of the best practice when we're using agents, and also if you're using AI, this is really good. So basically, I have a sample here, and also this like project customer support Copilot. So let me zoom in to make it better for you. So project to support Copilot for a mid-size retailer, and also architecture front end with Azure App Services, backend .NET 9, AI with Azure OpenAI, GPT-4. So in this case, it's using an old version, but could be like GPT 5.4, or could be Cloud Code or something like that. If you're using an external service, we can highlight it to the AI. Like if you're using Anthropic, be careful because the AI can train based on your data. So you can like have something like that. And also I can pass some expectations like expected usage, 8,000 users per month and so on. So let me execute it in parallel. And also you can pass some best practice. If you are not using like all information needed, so what you can do, you can train the AI that if you have less information, you need to highlight to the end user that probably need to improve it or something like that. So this is the output that I have. So final assessment, customer support copilot for mid-size retailer, and also the identified service workloads. So it's using Azure. The recommended item is P2V3 using Azure SQL database, Azure OpenAI, and the model. We can have like the price for the Azure AI cert, and also the cost drivers as well, like high for OpenAI, and also the estimated cost based on the large language model knowledge. So we can teach the AI, we can have like, instead of using hard-coded it, so we can connect to the Azure calculator price API, or we can customize it, or we can train the AI based on the public knowledge. And also this is like recommendations, what can be done. So as you can see here, we have a lot of information, useful information that I can share it internally, or instead of using, so some people are using forums or so have some discussions to approve it internally in the company when we have a new project. What can be done? You can build an agent. So instead of people sending a message to you and grouping with the IT team, so basically the IT team can build an agent in agent framework, putting the best practice for their IT department, and that's it. So the people in the company can just upload the requirements, and the AI can help them to leverage each. And also, as you can see here, we have some panels. How I built these projects. So in this case, I was using .NET to execute it and also to run this project. First of all, I was using Azure logging first. So this is really important because in this case, instead of when we are building agent framework, sometimes we have the option to store all the necessary information like keys and so on. Sometimes people that are not developers, sometimes people are storing the keys in the code. So this is really dangerous. That is the reason that Microsoft is releasing a lot of applied skills related to the like secret scanning and so on, because people are sharing their knowledge and sharing their keys into the code. So this is really important. So it is relevant for the project. So in this case, what can be done is you can connect, instead of using keys, you can use manage identity to connect to your project. And also in this case, you only need to use AZ login to connect your project locally to the Azure portal. Otherwise, also, so this is local project. But if you need to deploy it to the Azure portal, also you have it in the Azure portal as a web app or like a container or AKS or any other type of solutions that you have. So basically you can connect using managed identity. You can connect the Microsoft Foundry project with the web app or the service that you are using, the resource that you are using. And both can have permissions to access, and also you're not sharing the keys. You don't need to have key vault or something like that. You only need to have like managed identity to connect both services. So in this case, I can execute AZ login. So this is the first step. I can connect to my account, and also I need to choose the subscription that I have, and also it will be available 3 subscriptions, and then I can execute .NET Run. So this is to execute the project. What I need to do, so first of all, you need to update. So I will not share the credentials that I have in the app settings, but I created another one called app settings template. But in the app settings template, you can see that we have the Azure OpenAI project. So in this case, this is not the Azure OpenAI project. This is the Microsoft Foundry project. And also you can change the model. So one of the reasons to have like a powerful response is because I'm using GPT 5.4. So in this case, if I want to use like a different model, you can switch it, and also you can use another one. And also, if you want to put your API key, that's fine, but this is optional because in this case, you're using Azure credentials. What else I have in my agent just to complete the session? So we have the agent factory that I have the agent description and also the configuration that I have to my agent. So in this case, I'm explaining the endpoint, the deployment that I'm using, and also the configuration, the necessary configurations, the endpoints and suffix that we have. We have the FinOps agent prompt that you can customize it. So in this case, I've hard coded it in my project, but instead of doing it, the best practice is to connect it to like an API, or to connect to a back office, or to connect to like a database, just to retrieve the prompt, because you can switch it quickly instead of redeploying the solution all the time. You can just have one single place to do that. And also the tools. So in this case, I'm just using the best practices that we have for agent frame for FinOps framework. But if you want to connect to different tools, you can store all the tools available here. Like if you want to connect to Excel or Cosmos or SQL Server or something like that. And basically, I built like a simple HTML page just to execute my project. And also in the program, as you can see here, we have all the assessment and connection to the agent framework to execute the project. What else? The last minute. So what I can do is I can go back to the Microsoft Foundry to access your project. You can open ai.azure.com, and also you can build your projects in Microsoft Foundry. If you don't have a project, you can create your project. Once you have your project, you don't need to build an agent from scratch. You can just find models, and you'll be able to choose all the models available for your environment. And basically, you can select it, create your project, and then you will be able to see the endpoint and the information available to connect to it. Useful links for you. So this is the GitHub, official GitHub repo from Microsoft. You can use aks.ms/agent framework to access the GitHub repo as well. And also the Microsoft Learn. If you have any like questions or comments, feel free to drop in the chat. So thank you very much for your time here, and also it's a pleasure, Marcel, again. Thank you very much.
Yeah. Oh, Mark. Wow, nice. Well, so you shared like those links, right? What about like your personal or the particular
sure.
project they put in there? Because I think people would just be watching this session and then they are like, oh yeah, how can I get to it? Awesome.
Yeah, this one. Thank you very much.
Wow, thank you. And we're coming next with the next session. And like, have a great day, Renato. And we get to talk to you next time. Yeah, thanks so much.
Too. Thank you.
Hey, welcome everyone to the next session. So we've been talking a lot to people across both Australia and New Zealand, but today we've got Peter joining us all the way across the ocean and another landmass from New York. Welcome, Peter.
Hi, Luke. So where exactly are you actually located?
I'm in New Zealand.
All right. Okay. What part of New Zealand?
Hamilton, so about 2 hours south of Auckland. So I'm in the North Island.
Okay, very, very cool. So about 20 years ago, I saw this unknown comedy duo called Flight of the Conchords from New Zealand.
Yes. Yeah.
Okay, and they were completely unknown in New York. Okay, and it was a weird place in the Lower East Side, and I thought it was quite funny. And the about 2 years later, or maybe about 5 years later, they were on HBO. They were big time.
Yeah, because they did, like, in New York was essentially their ground that they were in. Yeah, totally. Trying to. Yeah, they're coming back to New Zealand for like a one-off show, I believe, as well this year. So yeah, it's quite interesting. But
so
today,
were you at the MVP conference last month?
Yes. Yeah.
Oh, okay. So was I. All right. We obviously missed each other at the bar. I don't know.
We were all talking about agents, which brings us to today's conversation. So the session that we just had was on agent framework. So very, very useful, very detailed in order to build your own. But you're taking a different stance on this about making AI agents your new intern, which I think is very top of mind at the moment around where AI agents work. Like, how do we work with them? Are they the boss of us, or are they the intern of us? So
okay. I always take a bit of a contrarian view on things, and yes.
Introduce yourself and take it away.
All right, let me kick off the presentation. So, if I'm going to do, I'm not going to present in Teams. Okay, so let me just hang on. Let me share my screen. That'd be the best thing. Okay. So, firstly, what is this? Was it 10 o'clock in the morning, New Zealand time, is it? Oh, here we are.
11, but yes.
Okay, all right, okay. So it's 7:05 New York. Okay, I've just finished work. I'm actually still in my office. So I've just wrapped up. Everyone has gone home. And I did actually try and get a cup of coffee, and somebody cleaned the espresso machine, much to my horror. So let me just kick this thing off about sharing. I'm going to share this.
How dare they clean the espresso machine?
I know. Well, there is a bit of that. Yes. Okay. Right.
While we wait for that to pop up, how's the weather? Because, good old weather.
Here, I'm actually wearing shorts to work, actually, on the first day, as you can see. Yep. Okay. Nice. Okay. Right. Okay. I am sharing my screen. You see my
you can see the StreamYard browser. Yeah.
How does that look?
That all good. So I'll disappear off screen, but I'll monitor the chat and
let me ask you this. I quite like my sessions quite interactive. So are you okay if I hit my Q&A with you? Are you?
Yep. I'll monitor the chat, and we'll just appear like a genie when needed. So, yep.
Okay, sounds very good. All right, so I kick it off now, shall I?
Yep. Sorry. Yep.
Okay. Very cool. Okay. So today's session is how to make AI your agent your new intern. So firstly, thank you for having me, and for the folks in New Zealand, it's Friday night, about 7:05, and I would say I'm sure you're enjoying your weekend here. Okay, a little bit about myself. Okay, we'll do a quick few introductions here about myself, about what the session's about. Job descriptions taken from Copilot, of course. 4 intern functions that basically an intern will actually do. I'll do a quick disclaimer, and I'll do wrap-up thoughts on the whole thing as well. Quick in-flight debriefing. All of this will be on my blog. If you got any questions, Luke, if you got any questions, interrupt me. I like to make my sessions conversational. If you've got any questions, feel free to hit me up on that QR code in the top right-hand corner on actual LinkedIn. So introductions. Luke, I know you're in New Zealand. Just remind me, what is your role in your, who do you work for, by the way? In terms of the audience, I'm assuming, Luke, you're the only person I can speak to. Everyone else is on mute. Is that correct?
Yeah. So we're streaming across YouTube, Twitch, a whole bunch of mediums. So yeah, people will comment on the chat.
Yep.
So because Global Azure is an event happening across the globe, we've got audience mainly for these sessions around Australia, New Zealand, Singapore, so the APAC region primarily. But yeah, I'm a Microsoft Azure MVP, and we'll just sort of monitor the chat throughout.
Okay, very, very cool. Okay, so out of interest, in terms of agents, where are you seeing that as replacing tasks and roles in the organizations that you're working with?
Yeah, it's mainly around like task based. So instead of we're going to replace an entire role with an agent, it's more around customers and organizations are starting to ask more around what tasks can we look at doing, and then that gets compounded up. But a lot of organizations, and I'm sure this is true across the globe as well, is the questions are around data governance, like how is the data enough to be able to use to build on for these agents? Others are, let's just give me the shininess and let's just get in, give the agents all the access. So we've got customers that are at a broad scale of these things.
Well, okay. Yeah. So one of the things is, it's like, I'm going to talk about replacing internship, and that's like AI. Like if you look at it, particularly in America, Oracle knocked out 30,000 jobs. And that's like I said, everyone was blaming AI. But the reality is a lot of AI is a headline use case for like, oh yeah, we're resizing, we're downsizing. Okay. That is really what's going on. It's not AI. It's basically companies are repositioning themselves and restructuring themselves. And also investment often swings from capital investment to labor investment. And that's what's going on. But for the stock market and the shareholders, if you have the headline, AI is replacing these workers, it's all a good thing, which in reality, that's actually not the case. Okay, very quickly about myself. I'm the founder, former CTO, now CEO, depending on what day of the week it is, okay, for a company called Soho Dragon. I've co-authored 4 SharePoint books, written Leadership in the Zoom Economy with Microsoft Teams, which was an Amazon bestseller. Organizer for days in New York. I have a podcast, I have a meetup. Okay, and my first version of SharePoint was 2003. Luke, what was your first version of SharePoint you were working on?
Oh, probably not that one. It would have been 2007, maybe, if that was the version, but it comes to mind. Yeah, it's something I usually would put in like a bin in the back of my mind, never to remember again. But
oh my god! So you remember deploying like WSPs into the GAC, and then the central admin disappears for 5 minutes, basically.
Yeah, and it required a lot of compute to run these back in the day as well.
Right. Yeah. Okay. That's all right. Okay. So I always like say that some people beat me with like 2001 and stuff like that. Hobbies, yoga, vegetarian cooking, and chess on that. Alrighty, okay. So this presentation will be on my LinkedIn. So if you've got any questions on that, take it from there. And I just want to say, like, here, it's your weekend, and thank you for taking your time to watch this presentation. I want it to be as educational, as entertaining as actually possible. A disclaimer, I am not talking about Visual Studio Vibe. I am not going to do a step-by-step code walkthrough. You can get that off YouTube or LinkedIn Learning. Okay, so for intern job functions, okay, that you can actually replace with AI: job posting, invoicing, newsletter, and summary of documents. Luke, how long have you been in the workforce for?
Over 15 years, give or take. Yeah.
Were you like an intern, or did you do like a graduate sort of like role when you first graduated?
I was an apprentice, so I come from a system admin background. So fixing people's home computers and small medium businesses. So as part of like working in the local high school, after hours, I would go in and do like volunteer work at the local computer repair shop. So that's where I came in.
All right, very, very cool. So basically, was that working for like an MSP or something?
No, it was just a small mum and dad's shop, but yeah, MSP later in my career. Yeah.
All right, okay, very, very cool. All right, so quick, what I wanted to say for this presentation, any slide you see with a green dot is something you want to focus on because it's a good power tip for this presentation. So let's just talk about job posting, okay? I'm going to basically talk about write-ups, posting, screening, and interviewing, which you can all now do in AI. All right, okay. So let's just talk about like if you're going to hire an intern, okay, you would write up this job script or a job rec, and Copilot can do all that, obviously. So you can actually do all that, okay? Okay. So firstly, instead of getting your intern to write this up or your HR, you can. It's quicker if you use Copilot yourself to do this. Next point as well is that you obviously, if you want to get a good job, get a good candidates for jobs, you can then post this on LinkedIn, okay? And then basically, if you're going to post this on LinkedIn, these are the hashtags. Copilot will basically will write to you the hashtags that you actually need to actually basically boost this job spec across the LinkedIn network as well. Okay, so basically, let's just summarize this. Copilot has written up a job spec. It's also told you how to hashtag this, and then all you need to do is basically post this across actually LinkedIn. So that's your first job, okay, or the first task. So well, now let's talk about invoicing, okay. Now, obviously, like when an intern joins a company, they're kind of like doing like the low-level stuff, okay. And one of them is basically writing up job specs. Maybe HR is doing it, but they'll be posting this. And then I've just told you how Copilot can do this. But let's look at invoicing. They might be doing admin stuff or invoicing. We're basically reviewing invoicing and seeing how well it works, approving this, okay, comparing this to what was the PO numbers, etc., etc. Okay, so let me show you how AI Copilot can actually do this. So here we got a centralized email box, and I actually recorded this. So let me just see how well this is working. Okay, centralized email box, and let me just go back a second. Hang on a second. Right, hang on one second. Okay, so basically here I'm showing you how Copilot can actually scan the invoices and process the invoices. And I'll show you how the agent can actually do this. So here we have a shared email box, which is what you have there. And basically all of your vendors email their invoices in. And I'll just get that sorted out. Okay, the video should be starting right now.
This reminds me of the latest episode of For All Mankind going through.
Live, yeah, as you can see, well, this is recorded, okay. So this is your shared email box. All your vendors are emailing their invoices in, okay. Goes into a library, a SharePoint list, okay. So you notice there's meta tag data here. It's reading this. This is your invoice. Bill to, ship to, this is your standard invoice. You know, nothing too wild and exciting here. Okay, so you notice with the invoice, you've got the vendor name, it's already picked up, the amount and the escalation. So it's already extracted this. Okay, if you actually open up the item, you can see all of the metadata is already tagged there. So it's actually extracted this, and Copilot can do this. Okay, so then let's look at the Power Automate the flow here. Okay, this is the email, shared email box. The current time, initiation. Let's look at the prompt. Okay, so you notice I've written this in English. There's no hard coding here or anything like this. This is all basically logic in English. I.e., this is what I want to do. I could put this in a Word document and give this to my BA and he can code this out, or I put it into Copilot and it does it automatically.
I like the control prompt there. Do not include any punctuation, explanation, quotes, or additional text to avoid just going, just give me exactly what I want, nothing else.
Yeah. Okay, and that's great. Thank you for bringing that up, because that's basically that edge case to say, this is all I care about. I don't care about anything else on this. Okay, now, so you've sort of seen the process. I've not gone into the details, partly because we haven't got like 3 hours here. This is all on the Microsoft website about invoice processing and processing the rebuild AI model. This is all there on the Microsoft website and all part of Azure. No fancy code whatsoever, and it's all actually out of the box. Okay. Now let's talk about a newsletter, okay? So typically with a newsletter, you sort of get the intern to basically write up the content and then blast this out. But wait a minute here, what would it be like if Copilot can do the prompt using a bit of Claude? Now, Luke, this presentation was actually written about 3 months ago, where it was all kind of like Copilot and a bit of Claude. Now, I know things are moving quite quickly, and like at Soho Dragon, Claude is a bit flavor of the month. Are you finding that a little bit there in Australia?
Yeah. I think it's a battle for the latest and greatest features between like Copilot CLI, Copilot Claude. But I think a lot of people I talk to actually use all of them. So it's pick and choose which one has the best capabilities.
I think there's a little bit of a flavor of the month. Like at the moment, Claude, here we are, it's April 2026, and Claude is flavor of the month. 2 months ago, it was like ChatGPT. 6 months ago, it was ChatGPT.
Yeah.
Okay, and of course, like Copilot is hovering around there. So there's almost like sprints going on. And basically, who's going to get ahead of everyone else, and who's got the best PR machine? So here we are. We're going to talk about newsletters, okay, and how it's used with a purpose in terms of competitors and a job website. So basically, this is now an agent. All Copilot, and this is an agent here. So what this agent does, it generates a newsletter on this. So you can see I've given it the instructions. They're all English style. Okay, now it's searching our Soho Dragon website, okay, and it's going to be looking for case studies, okay, because it can be choosing a newsletter based on the case studies on this website. This could be any website. It could be a competitor website. It could be the New York Times or Sydney Journal. I don't know. What is the national newspaper in Australia?
New Zealand Herald, I think, would be in New Zealand would be
New Zealand, yeah. Does Murdoch actually own newspapers in New Zealand or not?
I honestly have no idea. But
okay, so Murdoch owns the Wall Street Journal actually here in New York. Okay. So basically, you can see I've gone to the Soho Dragon website. I'm looking at case studies. Look at the prompt I'm doing to test this. Create a newsletter based on case studies on a website, which happens to be our company, Soho Dragon, and it's given me the formats. Okay, the reference, and these are the references.
I like this workflow primarily because, for example, your website could be sourced by marketing. So you would have a marketing arm that's doing all the case studies, but then you might have another team potentially doing the newsletter. So instead of sending emails back and forth and sharing things, it's grabbing it straight from the source of truth.
Yeah. So if you're writing when you think a newsletter for customers, okay, this could be for your sales team. Okay. Also, even internally as well, it's not uncommon that most internal employees for government agencies or big companies, they have no clue about what their company's doing or promoting out on newsletter or on PR wires as well. So by just doing this, you can basically have a schedule agent which create an internal newsletter about what the company's doing. So here I'm testing the agent and it's coming up with the output. Again, I can hire an intern or a marketing agency to do this or somebody. And this is a good example of Copilot doing this. And I can get this up, scale, and get it going scheduling every month. And this is all in the Copilot Studio Microsoft environment.
Which also means that if your knowledge sources were internal, it would be adhering to Purview and all of that capability as well.
Exactly. All your SharePoint site. Yes, exactly. Yeah. Okay. But you can see you have a newsletter here. You can go to your competitor websites, okay, to see what new models they're doing. You could even basically do this to see what your competitor PR engine is doing as well. And then have that instead of it being a general newsletter, having a targeted newsletter to your marketing team, to your product team, or to your sales team as well. Okay, on that. So that's your newsletter idea. So let's now look at summary of documents. Okay, it's not uncommon that somebody basically is in a company and they join a project. And it's almost a bit like, okay, I'm joining the project and it's 6 months. the project's been going on for 6 months and there's about 50 or 60 documents going on. So therefore, the challenge you've got is about onboarding this. And this is a particularly challenge for a consulting company because you have somebody who's left the project and then, you have, this is our new project manager. And the client is saying, well, wait a minute here. I do not want to spend 2 weeks training up, paying for your project manager to figure out all the tribal knowledge of this project. Well, hang on a minute. You actually don't need to do this because basically, if you can have Copilot to summarize all these documents, that will allow this new resource to come into the project and basically observe what's going on and get that tribal knowledge about what's going on and really figure out basically how to actually basically add value to the actual project as well. So that's a great way of onboarding new employees to a project, but also new employees to the project. And I'm not necessarily talking about the employee manual, but quite often you get a new employee to a project, a new employee to the organization, and there's an element, well, okay, what's going on, okay, or what initiative and what projects they're going on. You can forward them 30 or 40 documents, and they can then summarize all this information with Copilot, and within an hour, they've got a pretty good understanding about what's actually going on. Okay, and this is also goes into the sense of the term of a digital wheel. Okay, now when I talk about digital wheel, okay, a digital wheel is about replacing something that already existed, but you're making it better. So, Luke, can you give me an example of the best of one of the first digital wheels in our human, in human history? And you can go back hundreds of years here.
Oh God. Ooh.
On the spot here, I might just add, but yeah.
Yeah. I don't know. Electricity comes to mind. It might sound a bit weird, but yeah. I mean, it's not about the generation of electricity, but it's the way that electricity is transferred, across massive global regions. So I'm not quite right, but that's the first thing that comes to my mind. So.
Well, no. I would agree on that. Now, like people say, like AI is just like is going to have one of the biggest impacts in human society than we've ever had. And I would probably say electricity probably is something very similar. The literature is another thing is very similar, and also the printing press as well. Okay, but the idea with the whole thing about the digital wheel is that making things better than it was before. Okay, and the wheel was a good example. Before you had the wheel, you had rollers. You would put sort of like some building block on a roller to build a pyramid in Egypt, and it would go on rollers. But then you had a wheel, and suddenly people could actually travel on this as well. And that's the idea of making things bigger and better. Okay, Luke, quick question for you. What TV show is this picture from?
Silicon Valley.
Very cool. Good man. All right, okay. Good example is the BlackBerry, okay? The BlackBerry, everyone had email, okay? And BlackBerry, the idea was that suddenly you can do emails everywhere with a keyboard, okay? And that's what's known as building a better mousetrap. Okay, and that's exactly what it is. Okay, you have an existing situation, a technology or process, and you're making it better. Okay, so this is where there's a little bit of a disclaimer going on with making things better. So even though I work for a technology company, okay, I'm always a bit skeptical when you get these McKinsey consultants coming in, okay, and they'll probably go to like a hotel, and this is what's known as a doorman fallacy. Okay, they'll go to a hotel chain and they'll say, wait a minute here, you don't need a hotel doorman because the doorman's going to cost you $40,000-$50,000. You can do that with a bit of AI, facial recognition, and door opening. And so, well, wait a minute here. Okay, you implement that, and of course the CFO loves this. Okay, because as far as the CFO is concerned, technology is only compatible on the spreadsheet. But wait a minute here. After 2 years, the occupancy rates are down, are very down. When I'm in New York and I'm staying at the Four Seasons, okay, which is a very expensive hotel, I actually want a doorman because it provides status. Okay. Likewise, if I'm on a date night with my wife, okay, I do not want to go to a restaurant where they give me some kind of like device and it buzzes after 5 minutes to tell me my food's ready. I want sort of like some kind of a human to come over. Okay. So the doorman in a hotel, okay, does not just open the door. He provides status for the organization. He welcomes people. He tells people about local restaurants. He carries the luggage, which is particularly heavy. Okay, he orders a taxi. So you've got to understand the role, okay, and it's not just the job description. And that's a key thing with an intern, okay. The intern is not doing a whole bunch of tasks. There's a whole bunch of proliferatory activity and association which is associated with that intern. Okay, and
just a note as well. We've only got like 2 minutes left, so
okay, very quickly. Okay, the intern actually makes the coffee. Okay, the intern makes the coffee. So let's sort of wrap up for thoughts as well. Okay, the value of face-to-face communications is super important, and that cannot be replaced with technology. So the Royal Mail spent hundreds of thousands of dollars basically figuring out how to improve their service. Okay, and they couldn't figure out what the hell was going on. Because where the service was very, very good, the perception was low. Where the service was not good, the perception was good. It turned out that basically your perception of your Royal Mail basically related to your relationship with your postman, your mailman, but put the parcel behind the door when you're on vacation to wish you a happy birthday. It had nothing to do with technology, and that is a human issue. That is a human element. Same as call centers. I'm absolutely fanatical about call centers, okay? But I'm actually terrified about AI. People talking about AI effectively automating everything. You've got to remember when somebody calls a call center, they can't figure it out on their own, okay? And they can't figure it out on Google. And so this is the perfect opportunity to actually basically create a relationship with your customer and have a meaningful relationship with your customer to figure out what's going on with your actual product. Okay, and if like United, I was actually at a Microsoft conference, and basically some guy he was a product manager for Microsoft products, and what he said was basically he put the call center in the same location as the developers, so the developers could get present to everything they're doing right and everything they're doing wrong. You know, like I live in New York City, and I'm telling you right now, if I was a shareholder aboard United Airlines, I would put the call center right next to the boardroom, so the boardroom can actually witness what the customers who are generating their value are actually saying. And actually working with them. So let's just talk about this. Okay, so this is a good example of customer service. Can you hear this, Luke?
Chris Hearn goes to the Ritz with his wife.
Yes. We're running out of time, so we'll just finish
The
this.
boy leaves his teddy behind in the hotel by accident. The boy can't sleep without the teddy. Oh my God, the father's onto the hotel. Please tell me that you found the teddy. Yes, sir, we found the teddy. He was all wrapped up in the linen of the room. We'll get it posted back to you. We'll mail it back. Don't worry. Stay patiently. Wait for Joshy the giraffe to be mailed back. And a few days later, it arrives. The envelope. He takes them out. And out of the envelope, not only comes Joshy the giraffe, but comes loads of Polaroid pictures of what Joshy the giraffe got up to on his extended vacation in the Ritz. Here's Joshy at the pool. Here's Joshy having a spa treatment. Joshy even got a job as a loss prevention officer. He has an ID badge. There he is at work. Someone took the time to have an experience, to go beyond, above, surprise and delight, to build a relationship. Where will the Chris Hearn take his family on the next vacation? I can guarantee you it will be a Ritz-Carlton hotel.
So let's just jump through some of this stuff, okay? Because I know we're out of time. Basically, that video says, like, yeah, AI can get rid of some of the low-level tasks of an intern, okay? But you've got to remember, okay, you have to create relationships with your customers. If you don't, you are creating a commodity business. If you create a commodity business, it's a race to the bottom. So that's where AI is fantastic on things. But if you can actually basically use your intern to basically create a value add and engage with your customer and your employees, you're going to get a better business model, okay? And this is kind of like, well, finally, everyone says AI is going to be replacing jobs. That's not true. If you think of the movie Blade Runner, the intern is programming the robots. That's really what's going to be going on in the future. So let me just jump through a few slides, and that's about it.
Yeah, thanks, Peter, very much for coming and presenting to us today. Definitely some food for thought. Yep.
All right.
So just to finish, how can people get in touch with you?
I will basically, you can get touch with me on LinkedIn, which I will, that's it. You scan my QR code there, or just go to my blog, www.peterward on LinkedIn, and you'll get
awesome. Cool.
All right.
Thank you very much.
Okay, Luke, thank you very much, and thank you for having me as a guest and hosting.
No worries.
All right. Thank you.
Hey, welcome back, everyone. And yeah, we have Santosh here. How are you doing, Santosh, mate?
Hey, Ahmed, all good. How are you?
Good. Yeah, so Santosh is the first MVP actually to reach out to me when I moved into Melbourne. He's like, hey, Ahmed, would you like to speak? Thank you so much, mate. Yeah, so what are you talking about today? Talking about Azure.
Today, talking about the power of Azure networking services to safeguard the applications. It's most about how do you protect the applications with the networking services and security on top of Azure.
Beautiful. Thank you so much, mate. The floor is yours.
All good, mate. Thank you. Always happy to connect, Ahmed. Hope you're able to see my screen, right?
Yeah, I can. Go ahead.
It's not the notes because I saw some other chat.
No, it's all good. Works good.
Thanks, guys. Really appreciate your time. Hi, everyone. Good morning, good afternoon, wherever you're based on. And thanks for the organizers, Ahmad, Luke, Marcel in the back, who has been doing this amazing job here. And let's kickstart with my session. I'm trying to get into my flow now. Yeah, you're able to see does my slide moves? Okay, using the slideshow. Yeah. So my title on my session is about the power of Azure networking services to safeguard your applications in Azure cloud. My name is Santosh Kumar Anandakrishnan. I'm one of the Azure MVP across the globe, and I have my MVP for dual categories. I'll give you a quick intro about me. Just mostly on cloud. With the public cloud, Azure is my predominant space with infrastructure and the cybersecurity. It's been 19 years now, stepping into 20th year. I'm based out in Melbourne, originally from Chennai in India. I have my Microsoft Azure MVP. This is my third year, and I have my dual MVP this time with networking and security within Azure. And other than professional things, other than my work, I'm a cricket enthusiast. If someone follows in India, they might know it's big cricket fan. And then that I have my own blog, which can provide you some information about what I'm doing out of the technical things in that space. Okay, let's quickly get into agenda. So today we will be discussing about the components of Azure networking services in high level, then just go into detail level of how do you protect your application with different networking services, which is available within Azure, and how to choose it, what are the functions, what are the services and benefits it gets it, and just give you a glimpse of it on what it level it can make it for application more secure. Okay, this slide will give you the overall Azure networking services, which is available within Azure. It can be divided into 4 different categories, which I like to specify. One is connect, which can connect all your networkings, DNS, all those stuff goes in there. Second thing is monitoring, which is essential to get all your logs and diagnostics being captured for any of your troubleshooting. The third one is on protection, like your firewall, your WAF stuff, on DDoS protection, all those things comes under how do you protect your workloads within Azure. And the last section is deliver. How do you deliver the applications to the customers, to the internet for a safety mechanism? How do you secure that? There's a lot of different services within that, like load balancer, friend or traffic manager, application gateway. On top of this, some of this will have an addition on protection like Azure WAF. So this is what we're going to look into this today's section, mostly on the delivering side, where you can just use the services. How do you deliver the services to the internet to the customers with the protection enabled on the security of Azure cloud? Okay, so this is our main section today. As I mentioned, Azure Application Gateway, Friendro, WAF, and Load Balancer and Traffic Manager. Let's get into the first one, is Azure Load Balancer. As the name specifies, this is load balancing services, distribution of incoming traffic between the backends, and making sure your backend resources are healthy, and it provides a high availability with a low latency, and you can do health probing to make sure if backend resources has been not healthy, you can just migrate your services into the other available resources within the backend. So it helps you with that, making sure it is in the layer 4 transport layer and the networking layer, on the network level, and that helps you to have this kind of deployment. This helps you to deploy within the VNet, or it can be a public facing IP of the load balancer. It provides 2 options. Deployment type one is external and internal, and that's how it helps you to keep your load balancing services healthy. Under load balance services, there are multiple tiers. The basic load balance tiers is been retired now. As of September 30, 2025, it's been retired. So if you're running in with that, I think your services will be affected. So it's best to move into the standard load balancer services. That is a key takeaway for you today, to make sure you are in top of the updates happening. And for the standard one, which comes with high performance, and it just provides a zonal load balancing, which can be, you can just do a availability zone, and making sure your resources across the availability zone provides a high availability on top of that. And gateway load balance is designed for the transport insertion of third party, like virtual network appliances, like a firewall or third party firewalls to be used. That's mainly for an appliance that supports service chaining and flow symmetry with VXLAN, and more into the networking side of that side. And the last one I really love on the load balancer is cross-region load balancer. As a general, load balancer has been standard SKU. It's all mostly on the region based. If it is within Australia East, then it is Australia East. You can't extend that load balancer to the another region of New Zealand or Australia Southeast, or anywhere in Singapore or the US, or anywhere in the Azure region. So the cross-region load balancer is kind of a newest in the addition to the load balancer services, which helps you to protect your layer 4.7 of endpoint distributing traffic across the multiple region. This is a global services. It uses the Azure backbone to route that users to the nearest traffic on the healthy region based on your backend resources availability. And on top of that, there is a cross subscription and load balancing as well. It's gone in a GA. Probably it's been now more than a year now, which enables the front-end IP and the back-end pooling just to be in a different subscription, enhancing your architecturally. If you want to have some flexibility across your workloads from different subscription for some other reason, yes, that's been allowed now. So these options will help you to load balance your application in the layer 4 services, which will be mainly on standard load balancers, which is within your region, and the gateway load balance is mainly for your network based appliances or any kind of services you want to use it. And the cross region is really one of the great feature into using. If someone wants to use a traffic manager on top of that, yes, there is a pattern available, which I will be covering up in the coming up slide, so that if you have some application on top of L4, then you want to have a traffic manager to point your global DNS, like a global DNS or global load balancer services. Yes, that's been available within Azure. That's called traffic manager in a service within Azure. I'll be covering up in the coming slides for you. So yeah, the gateway load balancer it's transport layer 3 and 4, with that enables you to insert your NBA like firewall, IDS or IPS. You want to inspect the traffic without reconfiguring your routes or the clients. That's been services have been available here. The most primary use cases for this is mainly for the firewall, IDS, or packet capturing services. You want to use it, some kind of scenarios with that, then it's been primarily use case for that. Cross-region load balancer, as I mentioned, it is a layer 4.1. And again, it's kind of global load balancing solution. It distributes the traffic across your Azure workloads from different region, and that supports within for a low latency, for a DR, for a HA. You can use this, and all the route happening on the back end is mostly on traverse on pretty much into the Microsoft backbone. So it just works with that way. It's a single unique globally load balancer can be used to distribute traffic to the closest region, ensuring the low latency when a user wants access it very close by. Okay, the key takeaway from the load balancer section, make sure you have it in a zone redundancy, which provides a high availability and reliability, making sure it is in standard SQ, there is no basic or the risk has been gone retired. And if you're using anything for a cross region or a cross subscription one, you could just make sure you enable that, which provides you that availability and reliability much more. And the other takeaway is basic SKU has been retired. If something is running on your basic SKU, it's time to migrate into the standard SKU for the deadline. So this section covers up how you can secure your layer 4 services like VMs and other stuff which has been happening on the load balancer. You want to just use that and making sure it's been available across your services being secured in the way. The next section, which will be on Azure Application Gateway, this is one of the next services within Azure, which can be used to protect your web-based traffic load balancer, which operates at layer 7 in the OSI model, which can perform URL-based routing, which can be like URL rewriting. All these additional options in the layer 7 level can be done. The load balancer, what we discussed earlier, it's at layer 4.1. And it is fully, and this is fully managed kind of a PaaS version. The layer 7 is a web traffic load balancer. That's what I used to call it. This is web traffic load balancer. It's kind of a reverse proxy. If someone wants to understand the technology backend, how does it proxy service works, it's the reverse proxy. It handles the advanced routing such as like path-based routing, TLS termination, header rewrites. You want to integrate some WAF functionality on top of that to protect your services, then Azure Application Load Balancer don't have the much way to go forward towards it actually. And what are the functions and supports it provides? It provides SSL termination. The first thing I mentioned is it just provides SSL termination, which helps you to have an end-to-end TLS termination from the start to the end. And it provides in 3 different networking options like private, internal, private or internal, or if you want to do it with the public and external facing to an internet facing one. And the other bigger functionality it supports is it has an auto scaling, and you know to provide about that, and it supports zone redundancy and availability zones, and it has 2 different SKUs, and SKU 1 and V version version 1 SKU, which is a older one, and V2 is been like V1 is called, we call it as a legacy SKU, but it's not recommended to go in that path now if you're starting new. But if you are in V1, the version 1, it is better to migrate into V2. So the V2 provides much bigger options like auto scaling, availability zone, redundancy, higher performance wide, and faster operation. And other key thing you have to note for this is if you are factoring application gateways to be part of your applications to be protected, then you have to be factored, like you have to have a separate subnet to be used. And this subnet cannot have any other workloads to be placed into the application gateway subnet. It's just dedicated for application gateway. And if you have existing version 1 of application gateway subnet, you can't mix and match that version 1, version 2 in the same subnet. It is not supported. And the subnetting size has to be minimum of /26, which has been needed for up to 32 instances, because this is purely required for auto scaling. That's when Azure comes up and say, we provide auto scaling, but you have to make sure the subnet size has been supportable for your auto scaling. So it supports all the backend workloads, like it can be VMs, it can be scale set, or it can be AKS, and all other available Azure services can be supported as part of application gateway. And we will just go in more detail this, how it works in the coming slides. Yes, as I mentioned, the version 2 has been provided with the functionality of auto scaling, improved performance, reliability, all those stuff. And it factors in like operational excellence, like ensure the WAF logs are ingested into the SIEM to make sure you are being captured with the SOC capability. And reliability version is deploy, it just deploys the gateway into the availability zones for a zone level redundant or fault tolerant. And the best thing out of it is you can use your health probe within the application gateway, like making sure this specific HTTP has been accessible. Then it just redirects that access into the backend source. If that is not available, then you can just consider that a probe load and dependency check, and that helps you to have that availability into a next available healthy workload in the backend. And you can have some kind of adjusting your ideal timeout to making sure the backend behavior to avoid a premature disconnect or with this information may disrupt that. And that helps you to placing your availability on the backend. So it's been ensuring that it just supports that way. And it has been auto scaling as based on the connection comes into the resources of application gateway. It just has that grows and shrinks on application traffic requirements, and there is no need to provision or over provision or something. You want to do it as part of it. The minimum capacity is true, then it just goes out on the scale based on the load it comes up. Azure application gateway has another backend, supports all the backends, but there is a specific application gateway which is called application gateway for containers. One of my favorite services within Azure is like this supports all your containers based application. If you want to have your application gateway as part of your containerized workloads, then AGC is one of the best way to go. There is an older version of AGIC, which is called Azure Gateway Ingress Controller, which was it's been there for a long run now, but it doesn't support that the gateway protocol in that version of containers. So AGC is where you have to go forward essentially. So application gateway containers is specialized in layer 7 load balancing solution, optimized for the containers workloads, especially within the AKS environment. It evolves from the older AGIC, and it provides the better version of real-time updates and the scaling options and enhanced performance. The one bigger key factor in AGC is like it just provides a real-time update, where AGIC has there is a delay of around 30 seconds when there is an update on your backend. Say you have two different pods and you have AGIC on top of it. If you change your pods, or if you're adding in another pod in the backend, there's a slight delay to get that information back into AGIC. There is that's been what it built. But AGC, the application gateway for containers, gets you the real-time update, and it is one of the best solution to go forward in layer 7 to protect on Kubernetes side. So AGC is one of your best way to go. On the AGC, there are two different options where you can just provide it, like deployment options can be two different options. One is bring your own, that is like infrastructure first, which becomes as part of your deployment, and other option is like managed version or ALB, which gives you deployed inside your Kubernetes cluster. The first option brings you is like you explicitly provision AGC via your Terraform core or whatever deployment method. Then you just connect that associated Azure resources as a backend of AKS into AGC. That's one thing. So you have a Kubernetes cluster existing, then you just provision your AGC and just get your resources tied up with that. The second option is like it's a managed version, which you can deploy within your AKS cluster, and it just automates the provisioning of lifecycle of AGC will be integrated within your Kubernetes. It just includes front-end association, subnets, all this thing is part of your Kubernetes. So you just manage it from end to end with that. The reason for these two different options is like, if you want to migrate from AGIC or some other third-party services to Azure Application Gateway for containers, then the first option is you have to bring your own. Like you have a service available, just get your AGC tied up to that. So that way it helps you to pair up your resources into AGC. And it just supports ingress solution as well, where AGIC doesn't support the ingress solution. And enable WAF and secure with TLS, network policies, everything has been supported with this AGC. That's one of the best thing. I'm just quickly checking, did I missed anything? It just supports all the protocols, TLS 1.2 as of now, and it can perform SSL termination, and it just gets all your logging enabled. And the addition thing is you can support now WAF. WAF is enabled. The web application firewall can be used within your AGC for the containers. That's one of the biggest features that we introduced recently. Yep, I think that's it. And it supports CNI, all those other networking advantages, networking services used within AKS has been supported with AGC. Okay. So we discussed, this is the second section. Load balance is the first section. Second section is Azure Application Gateway. The key takeaway here is making sure if you're using AKS resources, the backend, making sure you use Azure Application Gateway for containers, enable the private link enable. So the application gateway supports private link enable. If you are just using it in the backend to have a connectivity, you don't want to expose it to internal endpoints to publicly, just making sure you have the private link enabled. That's one of the best practice, and making sure it is a MTLS, like enforcing the stronger client verification, making sure your backend is much more secure, and use a WAF and avoid UDRs as possible for the application gateway subnet, because that disrupts the health monitoring which is required for the backends to be resource to be ensured. And the other thing is making sure your auto-scaling zone redundancy is being captured as part of your availability, and that helps you to have the better resources to be used of. Yep, I think that's what I covered up. I want to cover it up. And I think I have one more, probably two more sections, which speaks about Azure Front Door. The Azure Front Door is a global HTTP load balancing with instant failover. It supports WAF, and Front Door is a globally fully managed layer 7 entry point. The difference between application gateway and Front Door, application gateway is specifically on regional based. I just want to give a comparison. That's why I didn't touch it in application gateway side. Azure application gateway is just region based. Say for example, you have two different workloads. One sits in Australia East, another sits in Singapore or New Zealand as a GR region. Then you just need to have two different application gateways required here. If you are happy to go outside of application gateway, then the application gateway is just being regional based. Azure Front Door helps you to keep it across the globe. Like you just provision a Front Door, which is a global resource that will have a backend into Australia East or New Zealand region, so that can, if Australia East goes down, your resource can be redirected back into the back end of the New Zealand region based one. So that is the difference between the Front Door and the application gateway. Which one you want to choose is based on your application, how your DR has been set up. If it is in different region, yes, Front Door is the best way to go on top of it. It provides performance, reliability, and security options like application by routing traffic to the nearest and the healthiest background. And it provides the same options like load balancing, SSL offloading, application acceleration for web application. It is, since it's a global load balancing, it routes traffic to the nearest and most available backend resource based on the geography, health check, or the latency, ensuring the performance to the end users, the customers on the internet, is being better. And it just provides you a dynamic site acceleration, which accelerates the delivery of the dynamic content by improving experience by reducing the page time workload. It has some cache which has been stored up, and it just provides you a better performance for the end user. and it just provides an instant failover. Say your primary goes down, your secondary has been very instant. You don't need to do anything because it's just been a global load balance. It just directs your traffic back into the DR or the next region, whichever you want to prefer as a secondary option. Other good information is WAF can be used within front door. It integrates WAF with the application layer security to ensure it's been protected across your application security. You can just do it WAF in two different options. One is detection mode. This makes sure this mode detects only actions based on the rule. It just simply monitors and logs the request. This will be better to use it in development to make sure you are just getting the logs which is being monitored, which is need to be denied. So next stage is a prevention stage. This mode takes the specific action based on the rules defined. And the rules, there are some rules which has been defined within Azure, which just provides you the managed rules. You can use all your managed rules to making sure you've been starting with the best practices part of your application to be protected. How does this application works in a global? Because as I'm mentioning, it has been global surveys. It goes on a different region. How does it works? Just look at this slide, which gives you the information like you're a user here, you're accessing a friend or resources created in a global network, and it just has a data center across the globe in Azure. It just takes back to the nearest and the closest friend door solution where it's been hosted in the region as a primary. Then it just goes and connects. If someone is accessing, you have two different resources, like one is in Singapore, one is in US. If someone is accessing from Australia, the Singapore region is the closest one. The friend door decides that user is been closest to the geography based on their location, and it just gets that user back into the closest and the fastest performance wise for them. That's a best practice. That's one of the good things with this. And there are multiple routing methods available, like latency, to want to ensure the requests are sent to the lowest latency, like based on the region or a specific location, and the priority, right? If you want to use your backends, when you want to configure in primary, this is my primary backend and this is my secondary backend. All the requests comes here as a first priority, and second priority is like least priority. The DR can be the least priority. So that way you can choose your thing. And there is a weight-based method as well with the routing methods. And the last one is on session affinity. Allows you to configure the user's affinity for your front-end host or the domain. This helps or ensures the requests are the same, users are the same to the same backend. So it just provides a different option. Choose the best option as is possible to make sure it is being tied up with the best performance of your applications. This just gives you how the friend door works up. If you look at here, this is all in the internet, and this is all managed on top of for you in friend door. It just has its own firewall proxy. DDoS application has been enabled on top of that. It has a caching method as well, which cache all your performances on the website and just gets back to the user based on the best performance for them. So from then it just redirects to your backend workloads here. So this is how the friend door has been works, which is, you can call it as a Microsoft Global CDN as well, a content delivery network, which helps you to deliver the network of your information into a user in a very fast method, and it's a performance-wise great. This is just an example where you want to show how the friend door works. When a user has been accessing on the internet, it just based on a friend door, it decides whichever the edge location is closest, then the traffic diverts into them the closest one. And all the traffic goes behind this is all on Microsoft Backbone. One of the best example I can give you how the friend door is being used in a real internet-based one example is like LinkedIn. This is on friend door. Bing, the search is on link. Used in the internet is on based on the friend door. Microsoft has all these primary services on the back as a predominantly on the friend door, like Xbox, OneDrive, and few M365 apps are being primarily used with the friend door so that they can just reach to based on their location and performance based. So that's a powerful tool. So I would recommend to use this friend door as an option when you're delivering in services to globally wider people that can be usable for your performance and enhancing your acceleration of the site. Actually, it helps you to have a private link as well. Backend can have a private link. It just completely takes out your backend to be exposed to the internet. It's just purely on, and it just provides active or active passive. You can just do both, and WAF has been added an advantage for you. And you can do a geo-filtering based restriction, like if I don't want access on specific traffic from this specific country, you can just block that as well with this. I think this is the last section with me. Azure Traffic Manager. This is a DNS-based traffic load balancer. The difference between the friend door and here is like friend door, it just gets out kind of extension of your application gateway in a global service, but Traffic Manager is purely a DNS-based traffic load balancer that distributes traffic to applications or the endpoints, improving application availability and responsiveness. What it does is it just redirects a client request to the most appropriate endpoint backend based on the configured routing methods and endpoint health monitoring. Say, for example, if I have my priority 1, just primary is my always go there priority. If it's my priority is 2, my request, whenever the primary is down, it just gets the traffic back into the second region. So the other thing I want to say is, as I mentioned earlier, in the front door, you can have the architecture which can be used with the load balancer, or your backend can be your application gateway. On top of that, you can have your front door. So you can have a front door on top, you can have an application in the backend, and your backend resource will be the third level, so that you can just protect that as well. That's an option for you to use it. How does Traffic Manager works? When a client attempts to connect a service, first it resolves the DNS names, the DNS query. Then the client then connects back the IP address to access the service. Traffic Manager uses the DNS to redirect the clients to a specific service endpoint, which is being located based on the health checks and performance base. And if there is, the Traffic Manager is not a proxy or a gateway. The Traffic Manager does not see the traffic that passes between the clients and the service. It just gets the traffic and responds back based on the DNS query and response, and just gets back to the user and say, this is your best backend resource which you can access a specific website or an URL. Same as a front door, you have a different routing mechanism here as well in Traffic Manager, like weighted option, priority, geographic based. So these routing methods helps you to distribute the traffic to a specific set of endpoints based on your routing mechanism you choose. Like a weight, it's just based on a weight, it just detects which is my backend to be provided to the end user. Like a performance or a geographic, if you want to make sure my Asia specific or APAC region is being used, Singapore or my Australia region, then you just go with geographic routing. Yeah, I think I'm a little over time. I heard now. I'll come to the
yeah, it's all good. No.
All good?
Yeah, we still have 2 minutes.
Yeah, all good. No problem. All good. I thought it was a little... Okay. On the Traffic Manager, key takeaways is based on it's a DNS-based routing, and it can be used with Azure or non-Azure endpoint. Like if you have something on your on-prem, you have a public endpoint that can be used as well as a secondary option, then you can just keep that as one of the backend to be used. And it just helps in that way that you can redirect your traffic from the hybrid deployment from Azure to non-prem or Azure to any other cloud providers as well. It supports with the public IP address. And the last thing I want to cover is Azure Web App. Web App, as name suggests that it's a web application firewall, which has been a cloud native solution that helps you to protect your web application from common web vulnerability, which has been like cross-siting with the SQL injection, with all those bot attacks. And WAF provides something with it's an out-of-box as a rule set where it just comes out with a specific predefined rules that can be used for you to protect your application. And this can be tied up with front door application gateway. So it just helps you to have some kind of a security for your application. This helps you to block your default vulnerability, which has been commonly available to the users on this topic. And the last slide here is to just give you how to choose your application delivery services. We just spoke about a lot now, but as an end user, how do I choose that? Can I have something specifically from Microsoft recommended? Yes, this slide helps you to that actually. As when you design your solution or a service you want to be, you have to make sure what is your need. Like if you want to have it as a global load balancer with WAF or without WAF, then if it is with the global load balancer, you can just choose front door. Or if you want to use it just purely a DNS based without WAF, then probably Traffic Manager is your option. So this slide will help you to choose for an end user or an application developer to work with a team to get an understanding. Yep, I think that's it, guys.
Thank you. Thank you so much, mate. That was brilliant. I really love you have gone through all the networking for Azure, which is brilliant. It's networking is a topic that I really love, and it is always something new to learn. So really appreciate sharing your time here with us. Really appreciate the information. Thank you so much, Santosh, mate.
Thanks, everyone. Thanks, Ahmed. Thanks for.
Thank you.
Catch you later. Bye.
Sweet.
Hello.
Hello. How are you?
Yeah, good. Yeah, welcome back for our afternoon session. I don't know if it is morning, afternoon, or evening for you.
Here is 10 p.m.
10 p.m.
Yeah.
Wow.
On
Also
a Friday.
on
So
Friday,
maybe.
yeah. We live in the future on Saturday
Yeah.
afternoon now. Okay, so let me introduce our speaker for this session, Javier Villegas. I try to pronounce the name.
Yeah, it's fine.
Yeah, thank you. And the topic will be SQL Supercharged Azure Fabric Copilot in action. So next, I will hand over to you. You can do an introduction and start to share your screen.
All right. Very good. Thank you
Yeah,
so
thank
much.
you.
I'm ready to start. First of all, thank you for having me here, for the invitation, and to have the possibility to present one more time in the global Azure event. I know that you are a quite active community, and you have a ton of events like this. So again, one more time, thank you for the opportunity. So there are no application, no analytics, no AI without data, right? So here is why we're going to talk about the Azure databases. In this specific case, SQL Server, right? Not the same SQL Server that we've been using for a while. Now we have like what it is, a big platform, right? SQL is not a product anymore. SQL is an ecosystem, a platform. So the name for this presentation is SQL Server Supercharged, Azure Fabric, and Copilot in action. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I'm Microsoft MVP in the Data Platform Award area. I'm also Microsoft certified trainer, and I'm one of the local organizers of our community here, SQL Argentina, where we have our monthly events in Spanish. So if you feel comfortable with the Spanish, feel free to join us. At the top of the screen, you have a QR code that will connect you with my LinkedIn. And you also have on the left side of the screen all my contact information. Feel free to reach out to me in case you have any question regarding to this presentation, or if you only just want to connect. Happy to connect with all of you. All right. So Microsoft SQL from ground to cloud to fabric, right? This is some sort of marketing phrase, but it's quite, accurate for what we're going to be talking about, right? As I said earlier, SQL Server is not that product that we download or we have the installation media. We put it in our on-premise Windows server, and probably we have it on the data center or underneath our desktop, right? Now, SQL Server is an enterprise environment. And, what is interesting about SQL or Microsoft SQL, how Microsoft would like to call it now, is that it's not only SQL Server, the product. It also includes Azure SQL and SQL databases in Fabric, right? the most important thing is that doesn't matter where you deploy your user databases, there are certain things that are common for all the cases. T-SQL, the language that we use to manipulate, to do query, to create tables, functions, views, store procedure, is common for all of them. The SQL Server engine, the core of the SQL Server, is exactly the same. Of course, the tooling, right? If we want to connect with Visual Studio, Visual Studio Code, Management Studio, the connection string of our homemade application, well, it's exactly the same. Doesn't matter which one is, if it is SQL Server, Azure SQL, or SQL database in Fabric. Later on, we're going to describe each of them in a little bit deeper, right? Of course, integration with Microsoft Fabric that we're going to touch base in a bit, and AI, of course, and Copilot, right? Copilot, Microsoft is adding these capabilities to all the product and services, and well, Microsoft SQL is not the exception. If we try to expand a little bit more the previous slide, we can come up into this one, right? SQL Server, the latest and greatest version is 2025, which was released last year during Microsoft Ignite, right? We can still run it in our bare metal SQL Server on-premise or using Windows Server, but since SQL Server 2017, we also have the possibility to run SQL at the top of Linux OS, the major distribution, Red Hat, SUSE, Ubuntu. At the same time, we can also run it at the top of containers within, for example, Docker or Kubernetes. That is what is the SQL Server platform, right? Then we have Azure SQL. Azure SQL has the possibility of giving us 3 flavors that we're going to describe later on. SQL Server running at the top of virtual machines, Azure SQL Database, and Azure SQL Managed Instance. We're going to dig deeper a little bit more. And finally, Fabric SQL Database. This is the latest and greatest addition into the Microsoft SQL family, right? Also announced last year during Microsoft Ignite. So let's start with SQL Server 2025. Another marketing phrase, which is also quite accurate, the AI-ready enterprise database from ground to cloud, right? When we mention ground to cloud is from the bare metal on-premise environment to Azure, right? So there are 3 main pillars for this new SQL Server version. AI built-in, develop modern data applications, and integration with your data with Microsoft Fabric. The AI built-in is that this time Microsoft give us for the very first time a new native data type in SQL, which is called vector, in where we are able to store embeddings, right? So in a very smart way, with SQL Server 2025, we can connect to an external large language model, like in Azure OpenAI, for example, right? Generate the embeddings of a specific text. An embedding is basically a representation of a phrase using vectors, right? But now we can physically store those vectors, those embeddings, into our user tables. And then with that, we can do different types of manipulation, like, for example, do a smart searching. What a smart searching is? Well, we have the possibility of, for example, enhance the all the search that we have in SQL. Till now, the only possibilities we have are basically using the like operator within the word clause or full text search. But you have to specify your exact text that should match with what you are searching, right? With AI and these embeddings, you can start providing prompt to your application that will go through SQL and these embeddings. And you can say, for example, return or give me all the articles for your head. And if we're talking about the Adventure Wars database, that basically is a a system that sells outdoor sports item, we're gonna return helmets, maybe glasses, or those kind of things. The word head or accessories for the head will probably not even show up on the description, right? This is what smart searching is. There are several really interesting use cases for this, right? But the most important one is basically when we do this smart searching. Then, develop modern data application. This specific build, there are a ton of new features for developers, and we will cover it later on in few minutes. And of course, the integration with Microsoft Fabric. We know Fabric is this data analytics end-to-end solution, right? Which has 2 years in the market in where we can do our data-related projects from the ingestion, from the storage, the processing, and also the visualization with Power BI, right? In this specific version of SQL Server 2025, we have the possibility to do this integration with mirroring, right? Which basically brings our operational data from SQL Server into Fabric, into one lake in near real time. We will go deep on that in a minute as well. And of course, as usual, security, right? There are more features related to security in this version, like, for example, the integration with Entra ID and also Microsoft Defender, right? And like always, mission critical engines, right? In SQL, we should be able to run mission critical application 24/7 with high availability, disaster recovery. There are also several features on this behalf, right? As mentioned before, assist by Copilot, optimized for the latest hardware. So if you have modern hardware, SQL Server 2025 is really optimized to run on it, right? We move on to the part that is related to developer features, right? As I said, there are many new features in here. And just to do it graphically and step by step, feature by feature, we're gonna describe like the rectangle in dots in the screen is our SQL Server, right? So we're gonna describe all the features for developers. First of all, right, Data API Builder, which is an external tool that connects to SQL Server and basically generates a REST endpoint, right? So we can, for example, configure the Data API Builder to point to one store procedure or one table, and we can have an external application reaching out into this endpoint and retrieving the data through the REST API. This is great to do data integration, right? Before, we have to probably create a link server or an SSIS package or something like that. We go to the next feature, and first time we have native JSON data type in SQL Server 2025, right? Before, we were able to manipulate JSON, right, and store it into a car or embark car data type. Now we have JSON data types and indexes as well to improve the query, right? And also there are several updated T-SQL functions to manipulate to handle JSON. Also in the T-SQL space, there are several new additions or an improvement in the regular expression order, right? So regex, new things in SQL Server 2025. And then 2 new additional features. One of them is change event streaming. This is similar to change data capture to keep track of the deltas, the changes that we do to our operational data, right? Insert, updates, delete, right? But instead of sending this data, these deltas, into a different table on a different schema like CDC does, right? We change event streaming, SQL ship or stream these changes into Azure Event Hub as events. So then we can have multiple consumers connected to the Azure Event Hub and take those events. And finally, REST API integration, which allows from SQL Server to connect to any external REST endpoint. Same as data API builder, so external application can connect to our SQL servers. Now from within T-SQL, we can connect to external REST API endpoint. Right? This is super cool. This is one of the possibilities that we have also to connect to, for example, Azure OpenAI using REST API and generate these embeddings. Finally, GitHub Copilot in SQL, right? And for the very first time, a native Microsoft Python driver for SQL Server. If we go to mission critical, right, we have three main areas: improve concurrency, accelerate performance, and increase high availability and disaster recovery. In the concurrency, one of the features is optimized locking. This is a new way that Microsoft handled the concurrency by doing this optimized locking, so there are less amount of locks for certain type of workload. So in this case, right, we reduce the amount of logs, and with that, with additional concurrency, we have more performance because we have more users working at the same time. In the accelerate of performance area, we have improvement in intelligent query processing, IQP, right? That SQL Server will basically give us the possibility to have better performance with our existing workload without any code change. In the high availability and disaster recovery area, right, there are more tools and more diagnostics ways to handle the availability groups. So now we jump a little bit into Azure SQL. And Azure SQL, we have these two main buckets: infrastructure as a service and platform as a service, right? In infrastructure as a service, these are virtual machines with SQL Server already installed. So we go to the Azure portal, to the marketplace, and we choose the combination of OS, SQL Server, version, and edition, and we will have this created in just a few minutes. One of the benefits is that we have some of the best practices that the SQL community has created, and even Microsoft for installing SQL already applied to this virtual machine. As the name says, infrastructure as a service, we have to take care of the infrastructure behind the scenes. So the OS, the patching, the backups, etc., etc. Then there is another bucket, which is called platform as a service. And within that, we have Azure SQL Managed Instance and Azure SQL Database. This is SQL Server as a service, right? So we don't handle, we have to, we have no idea what is the infrastructure behind the thing. We don't have to worry about the OS. We just only connect to the SQL endpoint, and we deploy our user databases, and we work with that. And then we have these two flavors, Azure SQL DB and Azure SQL MI, right? One, Azure SQL DB is targeted to modern applications, while Managed Instance is more targeting to be the SQL Server, same or almost 100% compatible with the one that we know on-premise, right? So multiple benefit on that: business continuity, high availability, backups, long-term backup retention, and shared replication. These are basically part of the best practices that we have to do, right? And it's super simple in Azure SQL. And the most important benefit to me is scale. We are able to easily scale up and down if we need to, give more power, more CPU, more memory, more faster disk, right? For forever or for a specific period of time. If, for example, our application is running and we need additional horsepower because we are on a peak season like Thanksgiving, Christmas, right? We can scale up, give more CPU, more horsepower, and then when the season is over, we can scale down. This is great because, measure or come up with the proper hardware configuration for SQL, and then make sure that we can predict the workload for X amount of years ahead, right? It's quite complex. So if we have this possibility of scaling up and down, definitely this is a good thing, right? Then we also have SQL database in Fabric, right? As I said earlier, Fabric, this end-to-end platform to create any kind of data analytics project, right? We can create now Fabric SQL databases within Fabric with 3 main objectives. First of all, be simple, then autonomous and secure, and optimize for AI. Simple is because the only thing we need to do when we going to create one of these databases is just provide the name, period, right? In all the other flavors of Microsoft SQL, we have to specify, the service tier, the amount of cores, if it is business critical, if it is general purpose, the amount of B core, the type of disk, the IOPS, etc., etc. Here, we just need to specify the database name, and we have our user database created within Fabric, so it can be used for any data-related project. Autonomous and secure, well, is trying to go in the direction that it does not require a database administrator to go there and handle it and manage it. So that is why it's trying to be autonomous. And in terms of security, right, the most important thing here is that Microsoft, for the very first time, has removed the support for SQL authentication, right? So only Microsoft Entra ID authentication is available. And then everything that I said before for SQL 2025 in terms of AI applies for Fabric SQL database. Right? Here are some of the latest and greatest announcements on this area, right? Integration with Microsoft Fabric, right? With Microsoft, with SQL Server, we have mirroring for SQL, right? So any flavor of SQL Server, call it Azure SQL DB, Managed Instance, SQL Server 2017, SQL Server 2025, or Fabric SQL Database, right? We can synchronize or mirror the operational data into one lake in near real time, right? So if we have our application running in, for example, Azure SQL DB, we have tables, and then this application is, mission critical, and we have to create new products or new, employees, etc. Every time that we create a new, we do an insert, update, delete, this data will synchronize into Fabric, into one lake in near real time, so it can be used, right, to do analytics in near real time. Super, super cool, right? And we also have the SSMS 22, which is the latest and greatest release, right? We have in Management Studio support for 2025, support for Fabric, GitHub Copilot that we will see in action in a minute. If we talk about Copilot, right, we have the possibility of, interact with SQL Server using Copilot, right? There are 2 main skills with Copilot. One targeted to administrators, in where we can chat with our SQL Server or any of the Microsoft SQL components and ask questions related to database administration. For example, when was the last backup? Which SQL Server version am I running? Do I have deadlocks? Why my SQL Server is slow? Do I need to perform update the statistic this time? Do I need to do index defragmentation? Any kind of question that one DBA may, you can interact with this Copilot, asking all the things that database administrators do, right? Also for developers. For developers, it's also interesting because you can ask Copilot to analyze and explain a specific store procedure, right? That is already created. So if you want to learn more, if it is, for example, following the best practices, those kind of things, you can ask this to Copilot. Additionally, you can, if you are brand new into a company, you have your database and your manager tells you, okay, analyze and start, doing the reverse engineering or this database. You can start asking Copilot, right? If you know that, for example, this is a sales-related database, you can ask questions like, for example, which are the sales for the, or which is the product that is in the top line of the selling process, and which is the comparison with the previous quarter, for example, right? And all this using natural language, right? So this is one example within the Azure portal. You can ask, my database is slow, and SQL Server will basically analyze and will detect that there is a query that is using a lot of CPU, and then you can ask a follow-up question saying, how can I tune the high CPU query? And in this case, it's proposing to create a missing index. I know that we have few minutes, right? But I would like you to show you Copilot in action, right? So I have here my Management Studio 22. I have here all my databases, right? I have here Adventure Works, and I will generate a new query. It's important to mention that Copilot will use your security context, right? It's not going to use additional rights because it's just Copilot. No, if you have only read-only rights to 2-3 tables, the answer that Copilot will provide you is based on those 2 tables that you have right? So here I'm connected to the Adventure Works database. So here at the top, I have GitHub Copilot activated, so I will hit on it, right? And I have here my chat window. I can ask, for example, which SQL Server version am I running? And after a few seconds, I mean, it's important to mention that it's a little bit slow to me. I guess that is gonna be faster at some point, hopefully, but not yet. And then, you know, once we get this answer, I have here a big list of questions that we can ask, that we can start asking this question, like, for example, calculate the average vacation hours by shop title, right? We have no idea how many tables, the table names, the columns, the foreign keys, the relationship, nothing at all, right? But, you know, we can start asking this, and Copilot will generate the T-SQL queries for us. While we wait for this, I'm not sure if there are any questions in the chat.
There's no questions from the chat. But from myself, I have a question.
Okay.
I'm really excited to see now customers can create a SQL database within Azure Fabric.
Mm-hmm.
As an Azure infra person, we always do governance, like RBAC control. I just wonder, with this feature, what kind of permissions control is there? Like, will DBA be able to create a different database, which will influence the cost, and also the other, like connection? Is it secure? That will be question come into my mind when I get to know this feature.
So to resume, you want to see the cost, and you know, if a DBA is needed to work, I mean, is needed to maintain one of these, right, or anything else.
Yeah, just maybe one of these. And also, I think here is a really good example to show DBA can have a good usage for GitHub Copilot as well. Yeah.
So in Fabric SQL database is so simple, and you know, as I said, you don't have to specify the amount of cores or CPU or memory or anything like that, right? But you know, it's not, I would say, super ready for mission critical workload, right? You cannot put in Fabric SQL DB your line of business application, right? It's targeted to, let's say, application that will be, for example, metadata-driven application, right? That is why it's that simple. That is why you don't need a DBA to let's say, monitor this constantly. There are certain tools that will allow it to run it any kind of workload, again, not too heavy, right? And you will be able, I mean, you will have several panels that you have in Fabric, and you can, see the activities, your queries, which are the queries that are running. I mean, you may have, or a user may have a tool, right, to identify what the SQL Server is doing. And the idea is not to require a dedicated DBA team for that. In terms of the cost, it will use a chunk of your capacity, right? There is a rule of the amount of your capacity that it will use. It will use 2.something% of your total capacity, depending which Fabric capacity you have, right? But again, it's targeted just to applications that, for example, you need to save the state of one specific product or something, but not to do a heavy OLTP application, right?
Yeah.
So if
Yeah.
I go back for a minute to the query, right, to the demo, right? Here say calculate the average vacation hours by shop title, and here what SQL Server has done with Copilot is create the T-SQL code. So I can apply it here, I can accept it, right? And finally, I run my query, and here I have the answer for my question. The average vacation hours per shop title, right? At no point, I didn't expand the database. As I said before, I don't know that there is an employee table, a human resource schema, right? I have no idea, right? So I can, chat with no problem. Year-on-year sales analysis. I can just provide this prompt, and super quickly and easily, right, it will give me this code that we can reuse and get all the answers. So I can spend the whole afternoon just chatting with my data and getting insight. And then, for example, I can use this code to generate store procedure views, etc. Right? So here I have another one, and I can, as I said, I can continue the whole day asking questions to my database. So I think that we are up with the time.
Yes.
So I made it super fast. It's a ton of information, I know. Again, if you have any question, feel free to ask now or contact me directly. I'm happy to answer them later.
Okay, thank you so much, Javier. And I think it is a really good session, and to show us some new features in the SQL field. And for any questions, feel free to reach out to Javier by using all different methods listed in the slides. And thank you so much for your session. We will hand over to the next speaker soon. Thank you.
Thank you so much. Bye. Have a good day.
Hello. So we're well into the afternoon now, and on the end of the sessions essentially for the day. So a few more left, but we've got one of our MCs here and also going to present the next session. Marcel, welcome, Marcel. Oh, you're on mute.
Thanks, Luke, for the introduction. Yeah.
No worries. I'll hand over to you soon, but I'm really excited to view the session. So essentially, Marcel's going to talk to us about Azure Developer CLI and AI, the AI extension, essentially. I'm quite excited about this because Azure Developer CLI is one of my favorite tools. I bake it into a lot of things, and having recently just created my own custom Azure Developer CLI extension, I actually use the AI extension a lot as a reference point. So really, really interested in that. But thank you for coming and not only emceeing and helping to set this entire thing up, but presenting to us today. So I'll hand over to you to do an intro, but away you go. Thanks, Marcel.
Thanks so much. Look, yeah, so we're continue with the sessions, and here we're going to be exploring the Azure Developer CLI. We're going to do like a deployment from our local to the clouds, right? We're going to be creating AI agents. We're going to be using Microsoft Foundry. It's interesting that Azure Developer CLI has just released an extension, as Luke mentioned, right? And we're going to go through like this session and talking in detail, more in details. So just introducing myself. So Marcel Medina, I'm a software developer, Azure specialist, being the MVP program like for a couple of years. Feel free to reach out to me like through the QR code and get in touch if you have any questions after like the session, or just to for any sort of queries really, if you come up like under from a software developer perspective in Azure cloud architecture as well. And today our agenda is simple, because most of the things we're going to be talking about in here is about like what's the problem that we have and we're trying to solve. And we're going to see that currently there's a lot of excitement in people creating agents, and that sort of transition from your local to the clouds has a gap. So we're going to identify how big is that gap, and then later exploring the Azure Developer CLI, which is going to provide a solution for that. So from your developer experience, you will quickly realize that leveraging the tooling has lots of benefits for you to get going in provisioning your AI agents to Azure. We're going to be talking also about this developer inner loop, what it means, and how the Azure Developer CLI fits within that sort of experience, and demo. All right, so we're going to go and jump and do like some cool demos in here. So you have built an AI agent locally, and now what? All right, so there is, well, there's always like this sort of challenge, especially with the whole excitements with like what's happening with agents, skills. Yeah, there's like a multitude of things happening. And then when you think about agents, how can I jump from my local to the clouds? That's like the big question in here. There's a big gap on what works on your laptop, from what works on your laptop to what's going to work in the clouds. Starting with like provisioning the cloud infra. So as you're running things on your local environments, you're not really thinking about how is this going to be hosted on Azure. And that's a major concern, right? Because without the resources available on Azure, you're not going to be able to run any sort of solution. The other concern is that when you're using the modules, perhaps you're using something locally, maybe you're using something already in the clouds, but when you're talking about Azure and Microsoft Foundry, so how are you going to be deploying that in there? Right? Things it can be a little bit challenging, especially if you're going to do like click ops from your like developer knowledge or perspective, right? So getting access to particular services can take like some time. So deploying some models may require like additional permissions that you don't necessarily have. When we're talking about identity, and when you're querying against your agents or letting your agents to run any sort of jobs, um, if you're running locally, they're going to have access perhaps to a set of tooling that's going to fulfill like particular needs. Like a classic example is that when an agent needs to request weather information, they're like weather MCP tools for that. When you're running like on your local, things work smoothly because you're owning the host. But when you need to use or integrate with any additional services, you need to think about how you're going to configure that. Are you going to use API keys? Are you going to use managed identities? Do you have like that full understanding of how it works? So that's like a major consideration here in terms of security. Not only that, you need to wire the plumbing, right? The connections. So from your web app that you have like perhaps a chat experience to your backend, having like the agents being hosted, perhaps you're running workflows, you need, or even like querying database, you need to think about, okay, how I'm going to connect the dots. And that has like considerations, right? Because if you're going to do this, any clients, you're going to wire, well, the bicep templates and getting like the pipelines available, right? The YAML pipelines. But like connecting the biceps and the having the references right can take like, yeah, backs and forths, right? But also think about your binaries, how they are going to be consuming and connecting to the other services, like through configuration, right? So you need to think about that. And from a developer experience, as you are running on your local environments, you know like what's happening, right? So you have full control, like in terms of monitoring, debugging, if you're using Visual Studio Code, something that you don't have like in the clouds. So yeah, there's some challenge here. And when we look how we can resolve that, we look at Azure Developer CLI. This one, it's not a new tool within the Azure space. It's been there like for a few years already. And if you're not familiar, like this is an open source tool that's going to accelerate your development, like from transitioning your app from local to the cloud, to Azure. And because it's focused on developers, so you have these developer-friendly commands. They're going to map like those key stages in your workflow, right? Your software development lifecycle. What that means? Well, it means that as you're getting started, you're going to initialize your project, and that's going to bring some sort of resource that are going to connect. The CLI itself is smart enough to connect to your application, identify what sort of resource you might be using. And you do with when you're initializing that sort of workflow. You can also like do some sort of packaging if you're probably going to deploy this to different environments from dev, test, in production instances. So you can leverage like that capability where you're having like a package of your things and transition then across environments. And there's like a big part in here with the Azure CLI is that you can provision the resource from your local. So there's a specific command for that. The same with the deployment of the binaries that you create like for on your application. In the monitoring, right? Because AZD provides a way for you to debug and see logs that are occurring and happening like throughout your application when running it. That's an invitation for you to explore a little bit more. There are like lots of templates available on aks.ms/awesome-azd. And I'm not going to dive onto that. I'm suggesting you to watch Jason Taylor NDC session from 2024, where he really goes onto this deep dive. And because what I'm going to show in here is something more specific to agents. And that comes to that idea of AI, an AI extension. So the Azure Developer CLI allows us to create our own extensions. And now the product team has created this AI extension that fulfills our developer needs, where like you can transition from local to clouds and iterate on that. So the Azure, the AI agent extension provides you with a way for you to scaffold and create your infra. You can also do the deployments of those resources in provisioning, like onto Azure, with the AZD up. So with those two main commands, you get things going straight away. Init and up, and then you get things to run. What comes after that is that you have the option to invoke your agents through a remote or local experience with the command agent invoke, or run it like on your local environment, right? Because as soon as you do like the AZD up, things are provisioned on Azure. And then at that stage, things are going to be running in there. But you have this ability to bring like your local or run it on your local and get things there, like for you to develop, validate, and test it. And together with the agent monitor command. So it's really the team, like the product team, has thought about like this developer experience and even provide like more methods, right, for you to check like the health or the status on Azure with agent show, or in the classic commands to AZD down to clean up any sort of resources on Azure. Let me go here like with a demo just to clarify what I'm explaining. So just bear with me. We just bring my screen here. Stop. Cool. So you should be seeing here like my screen. And so for you to, if you're first time getting to hear about like Azure Developer CLI, there are different ways for you to install it, like on Windows, Linux, Mac. I'm using Windows, so I have run these commands, right? The AZD winget install Microsoft.azd, and that's it. As soon as you have that, then you have full control of what the AZD tool provides. What I'm gonna do in here is just to bring like few commands. So AZD, let's say. So there's like this command where you're gonna see that this is an extension, right? So as I run that, you're gonna see that there are some extensions available that I can use. The one I'm gonna be exploring, get this one, is the AI agents, right? Which is a preview. So that's something new, really, and that aligns with this blog post. So if you look in here, this is very, well, it's new in here from March 23rd. So the team has just published this extension, and that's going to help lots of developers, right? Because it wasn't there before. And when we look in here at the extension itself, I'm gonna bring it. I'm gonna run like AZD AI agents, and you're gonna see that it's going to prompt me to with like a friendly TLI that I could perhaps in here just start like creating a template, right? But you can see the Foundry, like ship agents, Foundry from your terminal. I have like some sort of code created already, but what I'm gonna do in here is just to bring one of the repos. And this one I grabbed from Microsoft. I forked just to make sure that things wouldn't break. But this is what we have in there. I'm gonna share like the links. And what I'm gonna do is just simply clone it, and then we can explore like how it works. Okay, I'm gonna go and hit clone that one. And as I have that one, I'm gonna open my Visual Studio Code. And as it opens, right, I have like another, or I have done this one previously. And there was the template that came up. This is a Python template. And what it does, if we look in here, so it's a Seattle hotel agent. So that's going to allow us to do like some sort of bookings of like hotels and rooms. And the code is very simple. You can dive onto it later, but what it's going to do is just going to get available hotels. You're going to find hotels based on check-in, check-out, and the price. And it's a very simple agent using the agent client with like a prompt in here that defines that's a helpful travel assistant. Okay, and what I'm going to do in here, I'm going to just to initialize this project. Okay, so I think like the other one opened. So if I do a little bit more, yeah, I think that should be okay. And I'm going to run this, the init, okay? So that's what I'm going to do. Under like this project. This one actually, sorry, it should be under LS Seattle. Okay. Cool, so that's in there. I'm going to do the init here. And now it's going to identify that I have, okay, what do you want to do? Start a new template or use the codes in my current directory? Well, I'm going to use what's in there. And straight away, it's bringing me a list of, okay, so we're going to have like this starter template. And there's a bunch of files and resources in here to get me going. Should I initialize? Yes. So you can see in here that things are being populated. I need to specify a name. Seattle Hotel Agent. I'm gonna put like demo, Global Azure 2026. Hopefully that goes well. Like different sort of type filters. It's an agent that's going to be responding through HTTP requests. We have two options using like the responses filter or invocations if you're going to do some sort of queries from CLI. I'm going to be using like a UI, so I'm going to be using HTTP on that. Deploy a new model from your catalog. Sure, yeah, I have like my subscription here, and I'm going to be deploying onto like Australia East. It's going to be loading like the different AI models. Let's see if that one goes on, mini, and that's going to happen. And then what I need to do is just that, AZD up. That's, if I do that, it can take like a few minutes. I'm not gonna do it right now. But what you can see is that Yeah, so you can see the files have been created. And this is the major like templates in here, like with the azure.yaml that understands that I'm going to be using a starter. Well, that's the name, but leveraging this particular extension here, like on the Azure Developer CLI, and saying that's, well, that's going to be a Dockerized instance with this reference to GPT-4.1 mini, right? And I'm going to go like from here to the running sample, really. So in here, I'm going to do, for example, I have AZD agents or AI agent show. So this is query because this one I have previously provisioned onto my Azure instance. And you're going to see that this one is running. Okay. So this is there like on Azure for me. What I could do, I could just come in here and say AZD AI agents invoke. I can say, well, I'm going to say something here. Let's see if the agent is going to reply that to me. And this is coming from my local going to the clouds. And that's happening right now. And just saying like, yeah, how can I assist today with hotels in Seattle? And I could just come in here, please like book a room of any budgets. This is my query because I know that there will be like different prompts. You would query me back again, but I'm going straight with the targets here. Okay. Any budget, check in today, check out tomorrow. And then from here, we should get like a feedback and showing all the hotels that I could just pick and choose, right? So that's going there, would like me to book this. Yeah, but you get like the how things work, right? And the other thing, what I can do, I can run it locally. So with that, I can do it, for example, let me do it, run. So this should get us going. That's working on my local host here. Anyways, 88. What I'm going to do is that I could copy this. You can see that there is a local thing in here. And I can simply, well, I think this one, I'm going to go actually. Let me use this one in here. City, Seattle. Cool. So I can do that. What I would be doing, I would disconnect things in here, like, but yeah. So you can see that things are starting to respond. Let's see if I can disconnect that. And hopefully Windows behave well. Anyways, let me see if I can do that. Cool. This one, apparently there was, oh yeah, no, there was like, I think like that's part of the initialization, something here, but it got in there, right? So that got like my instance in here, like running. It just, I asked the question and I could see like things going, right? And the same I can do in here with the monitoring. This one is going to work with my agents there. Like, so I'm saying here, that's pinging the cloud one, okay? And I'm just sharing here. You should be able to see something happening here. Yeah, so you can see that you now can verify that the requests are coming and going. So that like allows us for like a smooth, really validation onto Azure. And you see that as a developer, you can visualize and see like what's going on. Right? So if you have like any particular calls or toolings that you're using, MCP tools, you could verify what's really going on, which is pretty cool. So that allows you to come and explore Azure. Just like just to show what has been provisioned, is that in here, like as I did previously, you've seen containers, right? So they're all like containers, containerized solution. But when it gets to Azure, I'm not used. Where is that? I have like a Foundry, projects, action group, container registry. The registry is here, but I don't have a host for that. So that's like Foundry is using hosted agents. So that's a new implementation. So you have two ways of doing that. You can take like full control by using the capability host, which is an option that it gives you full control. So you could like use container apps and having your instance in there. In my case, it automatically provisions that and using Microsoft resource. So I don't need to manage container apps in here. It's not in there at all. It's just managed by Microsoft. And that, well, has pros and cons, really. But for me, as a developer, coming here and getting to understand, like, wow, get it going, perfect. That it just works, right? So yeah, I think like just knowing that you see here, like the modules having provisioned, the agents, I could just come in here and chat to it, which is the same experience, right? But yeah, you get like the understanding that you have things on clouds, things on your local, and you have like full control of that sort of journey, right? And yeah, I think like with that is really my session here, coming and sharing with you guys. And I guess with that.
Yeah, thank you for that. I've shared in the chat, I have shared the link to the Seattle Hotel Agent GitHub fork in your GitHub repo. Jason Taylor's NDC talk as well. I do recommend that. I've watched it myself in the past. Very, very good. Very exciting. I like the whole point of just being able to shift some of this inner loop stuff and just go, hey, not only are we going to work on the application code, but let's look at how we can deploy these agents very, very quickly straight into Foundry as well. So it makes it a hell of a lot easier, not only for yourself, but other people to pick this up and push it directly. And like that was reasonably quick that you were able to do that. I'm a huge fan of AZD, but the AI extensions just, makes it a lot more worthwhile.
Yeah. That's my invitation, and that's it. Get to the REPL
There's
and explore.
no questions in chat, but before we finish here, how are people wanting to connect to you? Like, what do you have any links to any of your social media or anything for future reference?
Yes, I do. So what happens is that I have shared initially my QR code. Feel free to connect me to it, and yeah, you have like all the details in there.
Awesome. Thank you, Marcel. We'll get ready for our next session.
Thank you
very much.
Yes.
Hello. Hi, Zenon.
Hello. How are you doing?
Yeah, good. Welcome. And Let me quickly introduce Senanar and
Yep.
also his topic, Aspire with Azure. So I will hand over the session to you, then you can start to share your screen, and I will monitor the comments. So if there is any questions, we will have 5 minutes for QA in the end. And now I will hand over to you. Thank you.
Awesome, cool. I start sharing my screen, I guess. Awesome, cool. Just gonna see if I can scale it a bit to have a bit. Nice. I'm gonna close Orinco's logos, but I'm working for Orinco, so I can represent it, I guess. So today, it's gonna be full hands-on session. And what we are going to do is we are going to use Aspire CLI, Aspire and .NET and Agent Framework to, and also Model Context Protocol to develop an MCP tool, and also consume it from an agent. And then if we have time, we are going to deploy that to Azure. For Aspire, Aspire.dev, there's a lot of documentation there. You can just go and have a look. So let's start with this. Okay, cool. I can. So about the setup, we're gonna use .NET SDK, .NET 10, and then we are going to use CLI of Aspire, and the version is 13.2. 13.2 is a very big release dated recently. I have a blog post about what I'm doing right now, step-by-step instructions, so you guys can go follow. I will share the links later on. I can close this collateral. So first we're gonna create a solution file, but I'm gonna use the new format because it's way more readable because it's pure XML and not so complicated. And we can initialize the Git repository. Also, you can use .li to create a gitignore file, so we can just benefit that. Okay, normally if you use .NET CLI before, you can do .NET new list. But what also you can do is, if I take this a bit apart, there is you can install .NET templates, and there's already an MCP template that I installed. But this template use console application and standard IO as a protocol, but we are going to use HTTP. Also, there is AI templates as well available. So what we are going to do is we are going to use .NET new web API template to create our API project. And also we are going to create MCP with the web API template as well. So as soon as we have these templates are created, we're gonna just add actually .NET SLN add. I'm gonna use a bit Linux tricks. So right now this solution contains our files, our projects. So as soon as we are here, we can start introducing Aspire. Normally, if it's a greenfield project, you would start with Aspire new, but I've done a couple of demos about this, so I want to show how Aspire init flow works. So Aspire init is used, if we go Aspire init --help, is used to initialize Aspire into existing code base. This is what we have right now. So let's go through the process. So Aspire in 13.2 come with TypeScript app host as well. We're gonna use C#. So which projects we want to bootstrap, both of the projects that we want to use, and also service default is something that comes with Aspire, and we're gonna add that service default to both of the projects. And creating NuGet config for selected channels is we are using as well. Aspire also asks for AI agent setup. which we should ask very soon. I'm just going to go with Aspire scale file. We're not going to use it much, but it's not a bad idea to use, actually. So now I'm going to go to app host. Actually, let's try Aspire restore. Okay, so with the restore is done, what we are going to do is we are going to use Aspire. I think that didn't restore Unit packages. So I'm going to use add projects. I'm waiting for for some reason autocomplete doesn't work well. That means I'm gonna use this. So we're just gonna add this project that we created. They are both default API projects, web API projects. So we're just going to run Aspire instead of running the project separately. So I'm just going to do Aspire start. This is going to start the Aspire on the behind the scenes, so I can use terminal for other stuff, like doing other Aspire CLI commands. So as soon as it starts, I can close this right now because it's automatically done. So I can go and see my resources here. And I can open the resources. These are default API projects, so we can see the... But the reason we are not seeing traces is because we didn't add what we need to add, which is best practices that come with the Aspire as out of wax, kind of opinionated best practices. So I'm going to do Aspire stop. And also, okay, what we are going to do next is simplify our program.cs for, okay, so we know Aspire can run the application right now. We are happy with it, but what we want to do is to see the traces and logs. We want to do this for both applications. So app.map default endpoints. So when we do this, we will see default endpoints. Also, I think we added here, right? Builder, add service defaults. So if I run it now again with Aspire start, I should be able to see actually what I want to show before we go open the dashboard again and follow the traces. I want to show Aspire describe. It's a new command and it shows where things are running. And we can still go to dashboard and trigger one of the endpoints. Weather forecast. Okay. Well, the reason I want to do this is, oops, sorry, this is, I'm gonna make it a bit bigger so I can go to traces. Now we have traces here. That was important because whole purpose of Aspire is running locally with OpenTelemetry and traces and observability. Okay, right now to start a fresh thing, let's stop our server. I'm just gonna check my time. I'm just gonna replace all these boilerplate to bare minimum, and we're gonna start working with the MCP server. So for MCP server, we're gonna use, let's start from here. So we're gonna use our MCP projects here. But to do MCP, we are going to add a model context protocol.ASP.NET Core to MCP project. And we are going to use HTTP protocol instead of stdio. So let's bring our tool first, which is a very basic tool that we are writing. We don't even need tool for it actually, but you know, it's a demo. So this tool is describing a given temperature with what it looks like. It's kind of like a Bayer mapping. So this is MCP server tool type, and MCP server tool attributes come from MCP. Description is default system attribute. So next is we need to register MCP server and start doing the rest. So builder add MCP. We're gonna use add MCP server. So that's not enough because we want to do with HTTP transport. And we need to register tools with tools. So you can explicitly register the tools, but we're gonna do from assembly. And I'm just gonna do this. So for this part, we are writing a tool that doesn't have a state. So stateless true. So we added MCP server. We just need to map it right now. Map MCP. On top of these, we can expose MCP server that we write to Aspire CLI. But this is in a preview thing, so we need to suppress config thing for it. So let's see. So now I'm gonna do Aspire start. So we wrote an MCP server, MCP tool in MCP project, and we name it MCP. And we are going to expose this tool. So if we remember what our tool called, so Aspire is running, and our API and MCP servers are running. So what we are going to do is Aspire CLI has a command called MCP. So we are going to use it, Aspire MCP. And we can just go for tools, and we can see resource MCP has described weather tool. I'm not gonna bother using it because we're gonna use it in our next step. So I'm just gonna stop current Aspire app host. So we are going to use GitHub models for this demo, and Aspire has integration for it already. So we are going to use GitHub models, Aspire PS. I did stop it. GitHub models. Okay, maybe I was too fast. And so, okay, what this one did, this comment did is on our app host, it add this GitHub model hosting NuGet package with Aspire. So now we need a bit extra packages. Let's add those first before we go. So we are going to implement an agent that use this MCP tool that we implement in MCP server. So it will look like, I'm gonna remove this part because we will not use it. So what we are going to do is get reference, MCP, wait for MCP. So we are going to consume the MCP tool from this server on API project. So we have two projects running separately. But to do this, we need to add a couple of dependencies. So one of them is for consuming the GitHub model as a chat client. This, as I remember, was a pre-release. So we need to just add with the tag dash pre-release, and then we are going to add Microsoft Agents AI NuGet package to API project, and also last, because we're going to expose a tool of MCP server, we need to create MCP client. So if we open our API project right now, let's close everything. We add these Aspire AI, Azure AI Inference NuGet package, which is a preview right now. We added Agents AI NuGet package and Model Context Protocol to use MCP tool. Let's go back to app host and add our GitHub model. So we are going to use GPT-4o Mini from GitHub, as it's free, so you guys can play with it as well. I don't want to go Foundry if you don't have subscription. So we are going to give this the name of the GitHub model. We call it chat, and we are adding as a chat here. This naming might confuse a couple of people, but it's a homework. You guys can go and play maybe. So this is our API project. So first thing we are going to do is we are going to get that chat client. So builder, add Azure chat completion, and we call it chat, right? But we are going to get that as chat client. So this give us iChat client, DI setup. On top of that, we are going to add, we need MCP client to consume the MCP server, right? So we are going to add as activated singleton. Let's do that. So to do this, we need to create an MCP client, and let's forget this part. And this one is generally async method. So let's bring MCP client namespace first. And these will need something here, but this is async method. So, and I need to use getAwaiter and get result here. And this is what we are going to return. But this create async method, wait for an object type of extending iClient transport, and we're gonna use HTTP client transport here. And this client transport, HTTP client transport, is waiting for HTTP client transport options. With an endpoint. So normally with HTTP clients, with service discovery, we could just get this as a very straightforward, but because with MCP and we are working with environment level, I'm going to hack it. So what's happening here is when we add MCP resource as a reference to API project, it sets, because it's exposing both HTTP and HTTPS endpoints. Service discovery is actually just put this, but we know endpoint for MCP client is /MCP, so I just write this. On top of this, we need an agent right now. So for this, we are going to git singleton. So for this one, we need a name for this git singleton, for this agent. And we need to create it. So weather agent. So I'm just gonna get the MCP client that we just register here from the service provider. And then I'm going to get the tools of the MCP, available tools, all the tools, because we only have one tool. And we are going to create a chat client. And this chat client is actually this chat completion client as a chat client. So that's we registered there. So I'm going to return this chat client as AI agent. And the parameters we need here are a name, instruction, and tools. So the tools it's expecting is, as I remember, is AI list AI tool. But the tools we got is MCP client tool. So what I'm gonna do is here, tools, cast. I might be doing something really bad here. And this one is casting it to, as I remember, enumerable. So we can just do to list. I'm gonna copy the instructions and name, which is not too bad anyway. Okay, we have an agent right now. What else do we need? We need to wait to trigger this for testing right now. I'm gonna bring back the weather API, but for that we need a record. And this was our API, but this is a bit modified version of this. So we are getting a chat client agent here. And this chat client agent is the one that we just create here. So if I just run this right now, actually Aspire run, sorry. I'm gonna do Aspire start. So because we are using GitHub models, we need a GitHub model personal access token. And I already have that. I'm just gonna copy from one of my old projects. So manage user secrets. It's gonna ask as soon as we run it. So if we go to dashboard, here. So it's asking for unresolved parameters, and that is because MCP wasn't dependent, but API project is dependent on the chat model. So we are just going to put this here and save the user secrets, so we don't need to reset again. So now if I go to API endpoint and put weather forecast, it's gonna load a while. But we can see here, it's going to GitHub model and use the tool. So if we actually go back a sec, so here we can see the tool call, describer, and if we go to details, we can see all the MCP calls and everything here. So one last thing after here we can do is deploy this to Azure. So I'm gonna do Aspire stop. Normally, we can close this and close this as well. If I just do Aspire deploy here, it's gonna ask me a bunch of questions about where I want to deploy, and I already done that before. So this is a log of deployment, and it provisioned this Azure resource. To do that, though, we need to, because right now Aspire doesn't know if I'm gonna host this on app service environment or anywhere else. So we need to do Aspire add and app insight. Sorry, app service. Aspire is still running. Okay. Yeah. App service.
Sinan, just a reminder,
Yeah.
we have 2 minutes. For this
Okay, I'm not
session.
gonna deploy. I'm just gonna show what I deployed. So App Insight.
Cool. Thank you.
Thank you for the time reminder, because I'm terrible with it. So what we were going to do is we are going to create a two resource, App Insight and App Service Environment here. And this App Service Environment automatically used App Insight. So on top of that, when we want to publish this project as App Service website, so that's what we just do. So I'm just gonna do this. But one thing with deploying apps to Azure App Service, you need to expose with external endpoints, HTTP endpoints. So when you've done that, I'm not going to deploy now because it's going to take a while. I show already the deployment. I'm just going to open the browser and portal.azure.com. I hope I don't need to log in again. So it's going to deploy. So this is what I deployed yesterday. It's going to deploy App Insight because I asked for it. It uses App Service container registry to push the images. Then because I deploy App Insight, it deploy Logantic workspace. It has App Service plan and it deployed things here. And we can see similar dashboard. Sorry, not this one. Oh, okay. Anyway, I think the internal browser in VS Code doesn't sometimes work too well. So it also deployed this dashboard. I just want to show this one. And applications are running here, and I've triggered this before, so we can see the same result.
Mm-hmm.
Yeah, Aspire CLI give you a lot of, Aspire as a framework give you a lot of things. I think I will just share some links.
Mm-hmm.
So this is my blog, this is my GitHub, this is how you can find me on LinkedIn. I use X generally to follow news and stuff, but I already have other than deploying to Azure parts, I already have a blog post about how to do this step by step, and the final code without deploying to Azure, just running locally, is here on this blog post.
Mm-hmm.
Sorry, this is the blog post and this is the final code. So if you have a problem while you are following the blog post and redo this, you can go. And there are also resources I put into the things. That's my talk, I guess. So I think I can stop sharing screen and.
Okay, thank you so much. It is a really cool live demo with everything from CLI. It's like remind me my time in Red Hat every day by using Linux with all the command line and almost no desktop there. And it is really something interesting. While you are doing the session, I'm also search the Aspire to want to do my testing as well. And thank you so much for anyone who have questions. Just reach out to Sinan as he shared his info in the last piece of the session. Thank you so much, and let's welcome the next speaker. Thank you. Bye.
Thank you. Bye.
Yeah, welcome back. How you doing, Stu?
Hey, how are you?
I'm good. Yeah, Stu is a infrastructure as code Microsoft MVP. He's doing a lot of amazing job in the community, contributing to open source. I see you also contribute to what is called Azure Verified Modules, which is cool, AVM. And yeah, so what are you going to talk about today, Stu?
I'm going to show how we can fix the plan noise that you get with shared application gateways. And because I've had some demo bad luck recently, I've brought my little mascot along.
Good on you.
To help.
Good on you. Awesome plan. Awesome plan. Sweet as. I'm really looking forward to it. And yeah, floor is yours.
Okay, thank you very much. Okay, everyone. So yeah, like I said, I'm going to talk about shared app gateways. So what's the aim for today? We're going to do some fairly basic things. We're going to add an app, we're going to remove an app, and we're going to make sure that when we've got an existing application gateway that we can run a Terraform plan against it and not have any infrastructure drift. So nothing too ambitious, you might think. So where does the problem come from, and what's the context? Well, when you've got a shared application gateway, or the reason for having a shared application gateway is often for cost optimization, and you might want to put multiple applications inside it. And when you go through this process of adding and removing applications, you run into this problem. And it's documented on the HashiCorp webpage. Basically, the various properties of an application gateway are architecturally stored as lists within the gateway. So the various backend settings, the HTTP listeners, the SSL certificates, the front-end ports, they're all basically distilled down to a common set of lists. And the problem is when you're adding and removing an individual application, you get a lot of plan noise because you see a lot of things being added and a lot of things being removed. Makes it difficult to figure out actually what is going to happen. What is the purpose of the change that you're going to make? So why is that? It's an architectural limitation of application gateway. And as a spoiler, no, I haven't rewritten that gateway. So it doesn't, what I've done doesn't fundamentally change that. But what we are looking to do is to improve the noise. So just to illustrate the issue, if you've got multiple applications inside App Gateway, so App 1 and App 2, they get distilled down to a common set of lists, as you see, shared between all the various applications. So the solution, and this is a little bit techie, so I will go into the detail as we get into the demo, but just to set the context, it's a combination of changes to the AZ API provider, which is the alternative, some of you might know, to Azure RM, and work that's going on in Azure Verified Modules. So on the AZ API side, there's this new list management property. There's a couple actually, but the one that's relevant is list unique ID property. And what that basically does is it allows you to inject a key into a list, which fixes the list ordering problem. So when the list gets returned from the API, it's basically a unordered list. And this property basically allows you to nominate a property within that list to say, hey, that's the key. Basically turns it into like a map or a dictionary, which then makes the ordering, it makes it order insensitive, which means you can add and remove things and get a nice clean plan. So what does that mean? That sounds like pretty scary stuff. From a consumer perspective, it actually doesn't really matter because you're just consuming the AVM, assuming this gets landed as proposed. From a module author perspective, as we move over to AZ API, there are some sharper edges with AZ API that you need to be aware of. List handling is something that you kind of get as an extra fix, but there's some other areas that we'll talk about a little more later. But the end result is a reliable Terraform plan. So that's part one. Part two of the problem is, okay, so then you've got this way of being able to add and remove applications, but now you need a mechanism to be able to do so without potentially trampling over your existing config. So one way you could approach this is you could track all the various apps inside your TFRs, and then when you want to make a change, you're basically editing a shared config. It works. It's an okay starting point. But what if you could do something different? What if you could actually have it so that each application had its own file? You could drop and add an individual file, remove it, and then you'd be clear exactly which thing you're working with. And it also would mean that the configuration is a lot shorter because then you've only got the single application in each file rather than a very long configuration. So how could you do that? Well, one way to do it is YAML. And again, I'll show this in the demo. So what we're going to do is we're going to add and remove an individual YAML file from the traditional place where the TFRs goes. And then you'll see on the right-hand side, it looks very much like what you'd expect to supply an application gateway. So you can drop an add, remove these, and yeah, and if everything works well, then you should just see the changes that you expect. And Mona is going to hopefully watch over us all and make sure that that is the case. So that's enough slides. Let's switch straight into the demo. So, boom. So on the, let me just get rid of the stuff on the left so it's a little bit more space so you can see the thing. So on the left, you'll see the shared app gateway. There's a link to that coming a little bit later in the talk so you can follow along. This is an IAM Python notebook, which is quite cool because it lets you basically able to mix Python and Markdown if you've not seen it before, and then you can run it interactively. So for instance, there's some prerequisites for this particular module where you need to have some resource groups, some VNets. You could incorporate that if you wanted to, but then you can run something like this and it'll just basically make sure that those prerequisites exist. So if you've seen notebooks, this will come as no surprise to you. This is standard stuff. So skipping down to the deployment, we've got a dev environment that we're working on, and actually if I just hop into the right location, should have done that already. Let's just go down there and then we'll go to application gateway, make sure I get the right one, and then we'll go inside there and we'll look inside the insights and we'll get with this bar over there. So this is our starting point. We've got 4 services sitting behind an application gateway, and we could initialize Terraform, but that's boring. Let's not do that, but I did it earlier. And we could do a plan, and just to illustrate what the plan looks like, you should end up with something like this. You get 6 resources that need to be deployed. And yeah, it's the plan. Again, nothing exciting there. You could also do an apply, and then you'd have to wait 8 minutes. So I decided not on that, not such a smart thing to do. So I did that earlier, and that's what you see on the right-hand side at the moment. So it took about just under 7.5 minutes to deploy this application gateway with these various resources. So then the first thing that you want to do is, okay, I've deployed the resource, and this is always a good habit to get into. If you rerun the plan, you should get something back that basically says, hey, everything's cool. So let's just try it. And again, mine is going to watch. So. It's gone off the screen. Can't see it, Mona. Let's move it up. Perfect. So that's what we want to see. So there's been no changes to the application. It comes back nice and clean. And sometimes you need to do some work inside the module to make that work. So that's good. All good so far. So now we're going to remove an application. Well, how's that going to work? So let me just switch back to the code for a little bit and show you. So inside the module, let's just tidy this up a little bit. Get rid of some of the noise. Inside the module, there's this environments folder, and as you see before, there's these various YAML files which describe the various things. So we've got the backend there, we've got yet another demo app there kicking around. And what we're going to do is basically remove one of these, and then it's going to basically redeploy the app gateway. And it sometimes does this. It's quite annoying. Let's just do save whatever. Let's go back in again, so then it reloads properly. Cool. So where did I get to? So we did the idempotency check, and now we're going to remove the application. So you see what that basically is doing is all I'm doing is I'm just moving one of the existing YAML files and calling it .back. So it's no longer there. So now there's 3. So now if you run a plan, mine is going to come back again and watch the plan. Doesn't take very long normally, as long as the demo gods are playing nicely. So here you see, so the API dev, this is the one that we've just removed. You can see the request routing rule's been dropped there. You can see the probe has been dropped, but everything else looks pretty normal. The other 3 applications haven't been touched. So if we was to run this, then it should work, hopefully. Or you can also do a little bit of, if you want to, you can do a bit of JQ stuff. So if that's a little bit hard to read, then you can basically, as you know, export a, or you may not know, you can export a Terraform plan as JSON, and then you can do your usual wrangling. So this slightly messy stuff that you see there ends up with a nice little thing down the bottom where you get a list of these are the things being added and these are the things being removed. So again, it's JSON. You can do whatever mangling you want. That's just illustrating the point that you can make it even more readable. So then finally, let's go and cook the bun in the oven and set it going. And again, this is fairly quick normally. An illustrating also that this module is, it's got support for WAF and other bits and pieces in there. I'm just illustrating the basic components just to prove the point. So you see there's one change here. It's already showed that because you've seen the plan already. So after the plan, it should go and do the apply, hopefully. Come on, come on, come on. There it goes. You feeling comfortable, Mona? Yeah? Yeah, I think so. I'm feeling fairly confident. Yeah. And there we go. So apply complete. So if we come over here and refresh the topology, we should see the bottom one disappear. And yada, yada, yada. There you go. So now we've just got 3, and now there's 3. So now adding it back in again is really just as simple as renaming that file from back to the YAML file again. So we can do that. At which point now there's 4. And we could run the plan. Yeah, why not? Let's run the plan. Then you can just see what it looks like when you just add one thing. In fact, it probably would have been more sensible if I just ran the apply, because you just then see the plan at the same time. But never mind, we'll do both. We've got enough time. So. Cool, there it goes. There's the plan. And just while we're reading that, I'm going to kick off the apply as well. So we've got a bit of head start. So because you'd never do that for real, you'd always read the plan properly before you go and just blindly apply something. So don't do that in production, folks. There you see, this is the application just coming back, and it's just the 1+1 thing being added, and all the others are basically untouched. It's nice, fairly easy to read. Plan, and you could do the same JSON mangling that you saw before if you wanted to sort of summarize it even more. And there it goes. So that's the plan reran, and then we should see it start to apply. Yep, so it's done. So if we hit refresh over here, we should see the extra item. There it is. It's just reappeared at the bottom. So that's the application restored. So that's basically illustrating how you can have a shared number of applications sitting behind an application gateway, and you can have nicely reusable plans from Terraform. So let's just dig a little bit into what's going on under the covers. So see how the cookie's made. So if we start with the application gateway, so this is from the perspective of the module consumer. So here you see they are currently upstream on my repo. I've just PR'd them this morning. But as you see, all of the various applications basically get landed onto a common set of lists. And there's a bunch of locals mangling, which I'm not going to show, but you're welcome to go have a look, which basically take the various lists from these YAML files and then compress them into a common list of backend pools, a common list of front-end ports, and so forth for each of the items. So this is basically how you can use it. And you saw how it works. You just drop the various YAML files inside there. So what's going on underneath the covers? Let's go look at the modules themselves. So we'll open up, let's make sure I get the right one. That is the app gateway. So if we come inside here and see, this is the magic. This list unique item property basically allows you to specify the various properties that you want to manage the lists over. So in this case, we're saying, hey, for the front end IP configurations, use the name as the key. And most of the time you would use the name because the name is the thing that makes something unique, but you don't have to. So in the example of the backend addresses, there isn't a name property. So in that case, you can use IP address. And you can also use a common separated list of things as well. So if it's more than one property in this case, then you can have multiple. It's basically you need to find some form of uniqueness that identifies individual items in the list. Cool. So I think that's everything I was going to show here. So let me just go back to the deck. Yeah, that looks good. Let's move on. So I talked about AZ API. And so what's happening here, for those of you who are not aware, there was an announcement back in December from the AVM on an AVM community call. Basically, Microsoft have signaled intent that they're going to mandate AZ API for all resource modules in AVM. and it's also preferred for pattern modules as well. So from a consumer perspective, as you see, it doesn't really make any difference. You're just calling a module. How it's implemented under the hood doesn't change. You're still passing the similar things. So why is Microsoft doing this, or why does it make sense? A number of reasons. Firstly, the provider is now much more mature and robust. It's come along in leaps and bounds over the last few years and is now a production-ready replacement. Another key reason is the resources that you deploy are available day zero. So in the Azure ARM equivalent, you see there's quite a deep stack here. You've got the API, then you've got HashiCorp's version of the Go SDK, and then you've got HashiCorp's Azure RM provider. And when new features come out in Azure, there's a time delay for them to be added into the Azure RM provider because they're crafted, basically lovingly crafted for each individual resource. So there's a human basically in the loop, basically doing this stuff, which means they're able to put a lot more smarts into the provider. The downside is that you often wait in weeks, years, months, sometimes even years for a property or a feature to turn up. So the AZ API stack simplifies it. It's a much thinner layer over the ARM API, which means you get day one capability and feature parity and consistency with Bicep. The other benefit from Microsoft's perspective is that they own the entire stack. So from the REST API through to the provider, it's Microsoft owned, not HashiCorp owned, through to the AVM module, it's a thinner stack. So that's part of the reasons why. What does it mean from a consumer perspective for this change? There's a number of properties that will change for all resources. One of them, you may be used to using resource group name as a parameter into a module. AZ API prefers parent ID because it is agnostic to the subscription which is being deployed into. So you don't have that. If you do have a multi-subscription deployment, you don't have to do any kind of magic stuff to aliases and so forth to target the different subscriptions. You can just pass in the parent ID, and that also provides sort of consistency of how Bicep does it as well. If you're a module author, just a hint, tip there, don't try and do anything clever in terms of inferring the subscription ID. Using data sources within modules is not a good idea. The quote from Matt White, data sources are evil. There's a YouTube video at the bottom which explains why. Another common pitfall that people fall into, don't try and infer the location. Same reason, you get known before apply issues. Pass it in as a parameter, keep it simple, don't try and infer it. So, and you'll find as a module consumer, as things move to AZ API, there's sort of a standardization between Terraform and Bicep. So some variables will change, some resource names will change, and there'll be some upgrade guidance when that happens to help you do that smoothly. From an authoring perspective, a little bit more. So we're not going to go too much detail here, but just to give you a taster, when you want to output things from a AZ API module, then you specify them as part of the response export values property block. And the advice there is keep that as lean as possible and just put computed values in there. Don't put everything in there, because then you get change potentially coming from that through the inputs basically end up surfacing through the outputs. So keep it lean, keep it to computed values only. Another challenge with AZ API is it doesn't always know, unlike Azure RM, which is lovingly crafted, it doesn't know when a property will cause a resource to be recreated. So with the exception of name. So it knows that when the name changes, that means the resource needs to be redeployed. An example of that, public IP addresses. If the zone changes on a public IP address, then that means the resource needs to be redeployed. That has to be specified explicitly within the module for the public IP address resource for AZ API to do that in a way which surfaces up to the module consumer. One of the plus points, a huge plus point in my opinion, of AZ API is retry, proper retry. So if you've ever had problems with Terraform and you've had to sort of sleep for a resource to be created, this retry capability is a much more deterministic way of doing it. It allows you to look for the specific error, and then it will do exponential back off, and it will keep trying. And if the error isn't there, then and if it can just continue on and do it, then it will do so. So that means you don't get these non-deterministic issues where you have to kind of guess how long should I wait for. Sometimes you end up waiting too long, and it just makes deployment slower, and sometimes you don't wait long enough, and then it doesn't work. So retry is a huge win for AZ API. And list properties is the new thing that I've just been illustrating, which is a little bit niche and was actually added to fix a problem with diagnostics. It just happens to help with the app gateway story. So summarizing the stack and where I see the direction and the best way to think about this. AZ API is the new modern way of writing Azure resources. It is a thin layer, it gives you day one support, it gives you advanced capabilities, but it's a little bit sharper around the edges. So as a module author, you need to do a little bit more work to make sure that from the consumer perspective, you're offering them a good quality experience. That's where AVM, I believe, will step in and help. So I call that taming the line. It basically provides a community-driven standard to help engineer and wrap up those capabilities and smooth that surface and help smooth the gap between consumer and provider. And finally, of course, it doesn't really matter whether you use Azure OM or AZ API in a module. When it comes to the perspective of a consumer, it's just a module call. So as illustrated with the shared app gateway, and for your solutions also. And with that, that's everything. So just sharing the outputs. So there's a PR proposed upstream for both the application gateway module and the associated WAF module. You can see the links there. There is a shared app gateway, which I've just made public just a few seconds ago. So if you scan that QR code, you'll be able to get to that. And finally, thank you very much. And
yeah, thanks so much, mate. That is brilliant and really, really good. I was going to ask you how do people reach you out, but you've already done that, so that is brilliant. People could just scan that. So two questions. First one is like if someone wants, what is your advice for someone just wanting to contribute to AVM? So like, what is the paved path, or like what is the best what to do if you want to contribute to AVM? And the other quick question, I think all of this is on your GitHub repo, right? If someone wants to go and dig through the details you shared, so that's on your repo.
Yeah, totally. So in answer to the first question, if you go to aka.ms/AVM, that'll take you to the AVM landing page. And if you have a hunt on there, you'll find the contributing section. And there's guides for both Terraform and Bicep contributions. They'll walk you through the process of how you set up your machine and what the expectations are in terms of testing. And very cool guidance and worth a read, because it shows the testing framework that sits behind the modules as well.
Nice. Love it. Thank you so much, Stu. That is brilliant. Always fun to have you. And yeah, really appreciate your time and your sharing your knowledge. Cheers, mate. And Gods, Demo Gods was on your site today.
Definitely, so yes. Good. You see, it worked to bring Mona.
Exactly. This work. Cheers, mate. See ya.
Okay, bye.
welcome back. And hi, Intkab, how are you?
I'm very well, thank you, Marcel. How are you
Yeah,
yourself?
do well, thank you. Thanks for coming like this afternoon and joining us. So Intkab, is a cloud solution architect, has been working in New Zealand, in other markets in the world. And so today you're bringing chaos to compliance. So what are you approaching today?
Yes, it's a kind of an experience which we have recently completed, where in our organization we implemented the Fabric, okay, the complete solution. So it's a combination of the actual transformation of the system, plus for the data we use the Fabric from one stop like end-to-end platform. Okay, that's the information I'm going to share with the people. Okay, and just to give them the glimpse what the Fabric can help them.
Oh, that's great. Yeah, I invite you to share like your screen and bring your slides in, and the floor is yours.
Can you see my screen?
Here we go. Yeah, you're good. Yeah,
Yeah.
just
So, good afternoon, everyone. Thank you for joining me today. I would start with imagine like inheriting a financial system where the critical tax work was still runs on the Excel sheets and a part of the software. Okay, if and one formula goes wrong, okay, or miss the dates, it's the cost for the clients and us also. Okay, so for that one, we have actually transitioned from the old system to the new one with the combination of Fabric and with the zero trust financial services architecture. Before we talk about the solution, let me quickly introduce myself. Over the years, I have been able to work on the few of the bigger organizations like Airbus, Bolt Pro, Telstra, and where I have learned the kind of a small implementations which I have used, okay, for my current company. So every single one taught me the same lesson. Technology changes fast, but the real differentiator is staying curious. As the Satya Nadella, CEO of Microsoft, said, don't be a know-it-all, be a learn-it-all. That mindset actually exactly what drove this project. Today I'm going to share what we learned while turning decades of legacy pain into a secure, scalable project. Let me show you that what was the actual before implementing the new system at TMNZ. Plus, the engagement and the customer was managed across the several disconnected system. Most of the heavy lifting still happened in Excel sheets with the team relying on personal memory and manual efforts. Because of these systems, we could not talk to each other, okay, with the constant missing sales opportunity, and customer experience was suffered, and honestly it was hurting the reputation of the brand also. Ultimately, Team NZ wants to grow into a modern trusted financial service provider for our client. So that was the pain we were dealing, and the big question was how do we move from this chaos to proper compliance system. The answer started with the clear version to build a zero trust principles with the Fabric. For the we didn't just want a faster system, we want a secure and compliant one. We applied three core principle while implementing it. Verify explicitly every access, every data movement must be authenticated and authorized. Least privilege, given just enough access or just in time to the people who are going to use that data. Assume breach. So we implemented the design so that if something is compromised, the blast radius is minimum. So Microsoft Fabric becomes the perfect data engine to deliver this vision, acting as one-stop shop for ingestion, transformation, governance, and analytics. So all while integrating the tightly with secure Azure services. Actually, it was our North Star. With the vision set, let's look at the new system we built around it. Then we name it Skynet. Skynet is our modern Azure native platform. At its core, Azure Container Apps, API management, orchestration handled beautifully by the service bus, SignalR, keywords, and private endpoints, all sitting in a clean hub and spoke topology. Everything is deployed using the infrastructure as code, either the Bicep or YAML pipelines with the multi-level Azure DevOps pipelines. We got a system that is efficient, robust, and far less dependent on a single person. Even with a great application layer, the data layer was still the biggest challenge. Skynet gave us the application layer, but security and compliance were non-negotiable. Here's how we applied zero trust principles across the entire architecture. If you see, this is the actual our implementation for the Microsoft Fabric. We use the private endpoints and VNet for isolation. Keywords and managed identities for least privileged are back everywhere. Application insights and log analytics gives us the continuous monitoring, so we truly assume the breach. And in Fabric, sensitivity levels, row level securities, and data masking for our most sensitive financial and identity data is being used. That is what secure, compliant architecture looks in a practice. While the application and security layers were coming together, we still had a massive challenge hiding underneath our data. Let me show you the data management gap we had to choose. We had to close. As I explained that we were using the Excel files and the other things, okay, for years the data lived in Excel files scattered everywhere. Plus we were using the SQL server, which is hosted on the AWS for our legacy system. More than 20 years of rich data exists there. We needed a kind of a one single stuff, which where we can turn in everything from this old system to the AWS or to the Microsoft Fabric. Fabric gave us the ability to implement the proper medallion architecture, where we have bronze, silver, and gold layers, turning the legacy data into clean, governed, reusable assets. With a gap of clearly understood, let me show you that how we implemented it. So this is the basic Fabric setup we have. Okay, we have the different workspaces for the which we use for the isolation, governance, and deployment. So we have a dev and test workspace and production migration. So whatever is first developed in the dev and test, then migrate to the production. We are also using the HubSpot. So from production, we are migrating the data to the HubSpot. So we provision a new capacity in Australia East because our everything is in the Australia East for the Skynet project. We created separated workspace for staging production with strict promotion control through the Fabric deployment pipelines and design approvers. Security was non-negotiable. Sensitivity levels at workspace and item levels were introduced. Row level security for and data masking and we use the managed identities everywhere. For connectivity, we use the on-premise data gateway for the AWS SQL and the managed private endpoint for the SQL PostgreSQL, keeping everything secure and private. With the foundation ready, now let me show you that how we implemented it. So this is the actual stuff which we need to have it. So our data is in the legacy system. From there, we need to ingest into the Fabric. We need to have the transformation of that data and then push it into the our new system, the Skynet, which is the PostgreSQL database. And then from there, when the database enriched with the new system, we need to push that data back to the Fabric, transform it, and push it into the HubSpot. So we have implemented the different levels. Okay, we broke the work into these few levels. So there is a level 1 and 2 where we ingest the data into the bronze layer. We started by ingesting the data from the old system using the data factory pipelines, and then it becomes from So when I was implemented this data factory pipeline, I haven't started everything from like complex one. I started with a one simple copy activity, tested it thoroughly, and once it is scaled, then we use the lookup, filter, and for each loops to make it a proper pipeline. Then for level 3 and level 4, we did the transformation and silver layer. This was where a heavy lifting happened because the data should be transformed in a digestible level for the new system. So we use the PySpark notebook, which where it includes more than 66 tasks. Okay, and it's a kind of combined of the 2000 lines. Okay, the most important lessons I learned here was a strict separation, that every task, once it is complete, it should do only one activity, and then we go to the next one. We never mix any kind of the layers. We always ingested raw data into the bronze first, did all the cleansing and schema transformation, and then we push the clean data into the lake house. So we have a different lake house for bronze, we have a different lake house for silver layer. Every transformation block was properly documented so that if anybody else in the team want to change it, they can maintain it later on. Then in the last one, the level 5, we did the consumption and push the to back to the fabric. So finally, we push the transform data into the Postgres database, which becomes our new source of truth. We also handle the new transactions coming back from Skynet into the fabric, send the updates to downstream to the HubSpot through the API calls. This journey actually taught me that good architecture is not just about the technology. It's about the discipline in layers, simplicity first, and planning for operational reality. Let me show you demo. Okay, give me a second. Okay, so now this is the kind of the real juicy stuff for the presentation. We have multiple workspaces, as I mentioned before. Okay, I'm showing you the actual one, the staging one, which we implemented. So we can use the different naming convention here. We use the naming uh, convention for the workspace with the company name, then the uh, staging, and then the workspace. Okay, and then the sensitivity level, and then so this is where we are showing the task flows. So these are not the pipelines, these are the task flows which like we can show to the management, like how we are implementing the our work. So every task has some other items in it. So if let me show you first. If you see there is a list of the all the tasks. Give me a second. So if I yes, so you can see all the list of the tasks which are there. But if I select only one task, it is going to show you the only the items which are associated with it. So we have a first, which is the getting data from the old system. Then we are storing it into the lakehouse, and then from storing, we are preparing using the notebooks to transform it. After transforming, we are storing it into the silver layer. Okay, and then we distribute to the our last destination of the Skynet Postgres. But as I mentioned earlier, that in the requirement was to first have a old data, transform it, push it into the new system, and after sometimes when it is being utilized and enriched, we need to get it back to the uh, fabric. And once we get it back to the fabric, okay, we need to store and push it to the new system of the HubSpot. So this first row of the task, which have the items, are only for the first system. Then we have the reverse ingest, as I mentioned here, from the Skynet to the Fabric bag, and then storing it here. And the last, I have made a master pipeline, which actually contains a single pipeline, which is calling multiple pipelines. So let me show you. So actually there is a one master pipeline which is doing the multiple steps. So this is calling first the first part of the pipeline, which is getting the data from the old system to the Fabric transformation and pushing it to the Skynet Postgres. Okay. Let me show you here. Okay. So this is the first pipeline, which not the first one. From here also we can reach to the same destination. If I go here, okay, and if I click on this one, so it is going to edit the first pipeline. So as I explained earlier, okay, I started with a very simple one. For that one, I will show you the simple one first, which is the last one. So this is the pipeline where we distribute from Silver to Postgres. And if you see that I simply created a single task first, because these are the tables. So we have to copy the table from the Lakehouse to the Postgres. So I created a simple copy task and then give the source, what is the information from where it is coming, okay, the Lakehouse, and then the where it is going, and then the destination, okay, the doing the mapping. And so once it is up and running, okay, then I actually come to this kind of point. This is the first pipeline where I already implemented the for each loop. But let me show you what it has done it. Okay, that here I am getting the list of the tables from the old system. So if you see this one here, so we have a connection to the old system SQL, and I'm selecting only the tables which are required for my current implementation. Once it is I got all the list, I'm filtering that tables with the proper naming, and then I'm passing that one for this for each loop. And this for each loop actually is going to run the number of the tables time here. So in my other example, in this pipeline we have around 6 or 7 tables, 1 2 3 4 5 6. Okay, so instead of having this copy task 6 times, we can have a for each loop once, which is actually going to have the same copy task, and it is going to run the number of the tables time it got in this filtered one. So let me run this one. This is a bit big pipeline. It is going to take much time, but I will show you the first few steps just to give you the understanding that how this goes. Okay, so if I run it up, okay, so it is going to execute the first, this get the metadata from existing SQL server. So if you see this one, it runs that one. So if I see the input for this, so the input is the whole number of the tables for this, and then the output is only the number of the tables with the information which I require, the table schema, group name, and the full table name, the number of the tables which I required only. Okay. So that's done, completed once. Then we filter the table names, because here we are getting the table schema, table name, and full table name. Here I'm minimizing that information also from this big information to the small, only the tables name. So if you see here, okay, now we are getting the only 11 rows. That's once it is done, okay, then it is being used for the copy task. As I said that it is going to take a bit more time. Let me explain. Let me show you which one is the easiest. Okay. So this is a bit quick. So if I run this pipeline, so what the pipeline is going to do in the copy task, let me show you that The source is the lakehouse. So it is getting the data from the lakehouse, and then it is putting into the Postgres database, and it is going to show you how it is running for the first time for the first table, which is the organization table. And if you see this one, so it is successful. So it means the data is moved from the lake house to the, so this was the data from the lake house. This is going showing the information more about that task, but let me show you here. Okay. Okay, details. I'm not sure why it's not going back, but it is executing from one task to the second one to the third and all. When it is done for that one, okay, we will come back to on this one. So here I explained to you the master pipeline. The master pipeline is the first pipeline which is getting from the everything from the old server. Now I want to show you the actual transformation, how we did it into the notebook. So Microsoft Fabric as a one-stop shop, it gives provide us everything. So I not only ingest the data, I can also do the transformation of the full data, and then I can move it to the destination also. So this is the notebook which I wrote for our transformation. Before showing you the about the notebook itself, we need to connect before run this notebook. Okay, and there are multiple type of the sessions available. We can have a standard one and a high concurrency. In the high concurrency, multiple tasks can be run at the same time. Okay, and we need to add the lakes also. So let's say in the notebook I want to do the transformation on some of the data lake tables. Okay, then I need to add that one as a data items. Okay, so I added for the bronze and the silver also. Why? Because bronze has a raw data which I transform and push into the silver one. So let me start with the notebook. Okay, as I mentioned earlier, the key in the to save the time is to go with the step-by-step implementation. I haven't skipped any kind of the things. I started with adding the documentation so that any team member can use that one for the understanding. So here we have mentioned about this one that okay, this is the bronze create migration table. Okay, then we did the first the insert path one, but this is the first transformation. Some text form doesn't exist the individual account, so we need to have that one. Then we for the part two, that single text form organizations, we need to get that one, and how the tables are going to looks like after that. So this is the only the documentation we have added it. After that one, actually I this is the first PySpark Python code which are doing the setup and configuration. Okay, once the setup and configuration is done, if you see, this is the output which is showing that okay, what's the previous task done. So I clearly printing it up here, the configuration is complete, then how much time is taking it up. Okay, this time I have added later on, because when we were running this notebook many times, I usually mix it up, that is this task is on- that has been run for this execution or not. So I have added that time later on. This is one of the lesson learned. Then this is the second transformation. So we have done this one, the mapping the account type. Okay, if you see this one, this is the example in the text, and then I did the same implementation in the PySpark. Once it is done, and because it is executed, then it shows the okay what has it done. So it completes the information. Then we did the task 3 where we are doing the mapping. Every time when the task is being run, it is showing the output with the actual information, so that we can know okay that every step is correct. Although it takes a time when you build it up, but actually it saves a lot of time later on. Once, because we can easily audit what is the requirement and is it filled it up or not. Okay, and secondly, if we miss anything, so like here also it is showing that what's the information done. So I have implemented around 66 tasks, and if you count it up, there are around 2000 number of lines of code. But these are kind of the manual steps which we were doing before or with the SQL uh, scripts. Here it's once done, okay, then we can execute it accordingly. So then we have a part 2 implementation. If I scroll it down with taking the time in consideration, okay, so we have all these steps done. So when it is done at the end, okay, what we are doing is we are showing okay that how how these tables are being created, how many number of rows are being generated with that one. So there is a client table which is being ingested with 150,000 records. Then we have this the team table with 2,400 records. Then we have like the user and client information which is 175,000, and then the 130,000 rows. So this is the actual implementation which we have done, where the 3 forms has been done, getting the data from the uh, SQL Server to the Fabric in the bronze one, then doing this transformation using the notebook, and then pushing it to the Postgres. So once the Postgres is update and running it up, then we re-get that data back to the Fabric, did some more transformation and push it into the HubSpot. So this actually gives you the information, and plus uh, all this implementation is been done because it includes the data for the HR eyes only. So that because we implemented the that masking, even myself, okay, if I'm not in the group, I cannot see that one. So we have implemented the whole all the security stuff.
Hey, Cab, yeah, you just have like a couple more minutes, but yeah, that seems like a really interesting implementation. And I got like some questions on
Yes.
that, right? From the Python notebooks, like that you have in there, like I think they're pretty good, and you put like all the tasks in place, and you can visualize like what's happening, right? My question is not only related to the Python notebooks, but it's more related to the any sort of bottlenecks or limitations with Fabric when you're implementing like these pipelines. Like, what was your experience with that?
So one of the thing which I mentioned that you need to have a capacity. So if you have a less capacity, then it takes a more time for a notebook to run. As our notebook, it's a quite big, 66 tasks, and it takes many times of the transformation. So we have to have a bigger capacity, which is expensive. So that's the one of the bottleneck. So when the people are implementing for their personal projects, they have to be considerate about that one, that how much data they are trying to transform. And that's the one thing which you need to consider. That's why I mentioned that when you are running the notebook, you need to start a session. And I would recommend that once the notebook is you already run, stop the session because it is costing per second. So it's a VM which is running behind. Okay, so you the cost, it depends on the company size. As we are a financial company, okay, we need a more kind of the it's like uh, auditing and more kind of the accurate information. So that's why we have went into the more depth. as compared to the individual or the small companies, sometimes that level of the information is not required. So, and the second thing is this, as I mentioned, that we did one transformation where from old system, after transforming, we push into these Postgres. But after that, we are re-ingesting into the Fabric. That was the crucial task of discussion, because whenever you ingest the data into the Fabric, it is costing you. So cost is one of the matter when people who are using the Fabric need to understand. Okay. But Microsoft have many plans. I think if you coordinate with the companies, they can give you this some kind of the real tips which can save you a lot of you know the a lot of time and money both.
Well, yeah. Well, thanks for the explanation. We're here like on time. Like, how can people reach out to you?
Yes, sorry, this is the last slide that I missed. Just 1 second. Yeah. Okay. Yes. So I'm available on the LinkedIn, okay, and the GitHub both. You can see my screen.
Yeah, I'm seeing. Yeah.
Yeah. I'm available on the LinkedIn and GitHub, and plus I think we have a repo also where I will share my presentation, so you can go through about this one. Okay, we can have a chat about the Fabric related or the Azure DevOps kind of stuff anytime.
Well, thanks so much, Cab, like for the time and sharing with us. Yeah, and we have a great afternoon, and see you next time.
Thank you for giving me the opportunity. Have a good time. Bye.
Cheers.
Hello, everyone. Welcome to the final session of the day. Thank you very much, everyone who's stuck with us from the very beginning, and thank you to all our speakers and presenters today. So hopefully everyone's learned something, new contexts, new things to try, and obviously, like, there's many other sessions happening at Global
or just
Azure
found
as
out
well.
something different that they didn't know, right? Or you know, just come across a new bit of learning that they're going to take away from today. It'd be great.
Yeah, the whole point, like some sessions can, you know, be very high level, some are very deep, but they're all about learning something new and figuring out. I think one of the problems that I have in this field is you don't know what you don't know. Like, the more I think I understand something, the more I figure out that I have no idea what's going on. So it's almost like you're chasing your tail, because you're
any profession, specifically in technology, we never stop learning, right? And there's always a new way to do it, a different approach to take to it, right?
100%. So, with that, so Chris, welcome. You're our last presenter of the day. Thank you for being with us for just about all of the day, I believe, as well, in the background, chatting away. So you're here to talk to us about Azure VM Internet Direct retiring. So
well, it's kind of already retired, but yes, it's about reminding everybody why it retired and also what are other options. And I think that's, you know, what I'm here to talk about, right? And look, I'm really passionate about this topic. I'm a networking MVP, and it's something that I think people may not have a full gamut of understanding around it, and also what are the options out there for them to choose from. So I think it'd be a cool little topic to kind of go through.
Yeah, and I'll let you kind of go through and deliver your session. But one of the things I want to touch on for the audience as well is Chris does a whole lot of blogging, brewed in the cloud, I think, off the top of my head, around Azure networking specifically. So if you have any, like we already had a session today with Santosh covering like all the networking components as well, but we've got some really cool networking people within like Australia and New Zealand. So welcome, Chris. I'll leave you to introduce yourself properly and go through your session with us. So
Fantastic. Thank you, Luke. Appreciate it. And thank you everyone for having me here today. It's a real blessing to kind of be involved in some of these community events that we get to do. So yes, I'm Chris Hales. I'm an Azure MVP. I'm also a cloud technology strategist for a company here in Sydney. I'm based out of Sydney, Australia, and I'm definitely enjoying some beautiful weather today. Today, we're going to talk a little bit through what's happened with VM Internet Direct. People might remember kind of some announcements that happened late last year, and then it kind of shifted and changed and delayed. And but we're going to go through that again, and then we're going to start to talk about what our options are for what is the next iteration of how to obtain internet for virtual machines. I also want to note this doesn't impact platform as a service offerings. So things like the SQL databases, Azure ML, things like that, they're not necessarily impacted by this. It's more about virtual machines or resources that are deployed to a virtual network. They need an internet option now. So without further ado, what happened? What happened? Where did it come from this? And I've just realized some of my graphics are broken, but that's all right. We'll push through. So in kind of March this year, it was originally slated for September 2025, but in March this year, Microsoft changed the way that virtual network subnets allow for direct outbound internet. Now, that was effectively a change to the underlying API. One of the things that happens there was they've more or less just stopped it from happening. So when you create a new subnet now on a new virtual network now, it's not open by default. It's technically a private subnet, right, from now on. You can still change it, obviously, but the default is private subnetting. So this implicit source NAT, right, was available to everybody, which made deploying virtual machines super simple, right? You could deploy a virtual machine, you could put a public IP address on it, you could get your outbound, inbound RDP, or if you didn't put a public IP address on it, you still had internet access, so it could still reach everything on the internet. So that implicit trust of NAT versus what Microsoft wants us to do is to take more of a defensive measure and more of an explicit trust. So rather than being implied, we need to make a decision about how it gets to the internet, which is really important. Uh-oh, slides not moving. Oh, okay. Yes, I've got some broken slides here. Let me just see if I can change this slightly, because this is going to make it a bit more challenging.
It's interesting while you go through that, because I think a lot of people, like, this change has been coming for a while and they've even pushed it out. But I think it's interesting because for those of us who've been using Azure for quite a while, it's almost like, hey, what's going on? And then a lot of things like Azure Virtual Desktop as an example, it's like, well, this is existing VNets will work, but when you start to scale them out, then you start to run into kind of inconsistent and like behavior.
Yeah.
So yeah.
And, is everyone able to see my screen now? Better now?
Yep.
Working. Yep. Fantastic. I guess, and that's one of those scenarios, right? It had a blowout effect, right? Which is not necessarily immediate. It's going to be long term. But I think the other thing is that we're so used to it just being implicit that we need to change the way we think about that so that we don't fall into the trap. And we need to also modernize those older virtual networks and subnets that we've deployed, which is important as well. So yes, before, like I said, that implied magic SNAT, you deployed a virtual machine, hey, it's got internet, fantastic, right? But now we need to deploy a virtual machine you're not going to have on a brand new VNet, a brand new subnet, you're not going to have internet. So unless you explicitly configure it. And there's definitely, like I said, plenty of options. And we're going to wrap through a couple of them today. So that explicit configuration. So again, this is not Microsoft trying to be difficult. It's them pushing us all to a better security posture, right? We want to make sure that we make an explicit choice to allow internet from a destination or from a source, right? Whether it's if you've got a 3-tier architecture, for example, and you've got databases that don't need internet access and data tiers or application tiers that don't need it as well, why give it internet? So it's about making sure that we have an explicit decision to why they need it. And then how do we provide that in a secured way, or at least a controlled way? So some options I'm going to cover off in some detail. I'm going to not go too deep on some of this because for those that know me, I could probably talk about this stuff for a good couple of hours on each one of those solutions, because they've got some really good valid points. They've got some really awkward points. So the high level summary here is NAT Gateway is a super simplistic approach. It's quite a low cost and it's quite a low complexity. So it's that concept of the same kind of magic SNAT that occurred originally. Essentially, rather than Microsoft deploying it for you in the background and in the black box that is the Azure platform, you're actually deploying it as a resource and you're controlling it, right? So there's a concept around that. It also allows you to have a guaranteed single IP address, egress IP address, which is also important for some security aspects. Obviously, there's an Azure firewall. You can do that. It's probably a little bit more costly. It's got a little bit more complexity because it's got a lot more features, and it's more designed for that kind of security first organization that want to have inspection and they want to have visibility of their traffic and so on. So that's one of those challenges that we kind of face there. Anything that's currently behind a load balancer, so if you've got a web tier that's got maybe 2 servers behind it that you're doing some high availability between, you can also leverage that same load balancer, those public load balancers, as an outbound as well. So you could leverage that if you're only giving internet access to those external facing tiers. The network virtual appliance is a sticking point with a lot of different customers. The best way or easiest way to explain this is if you've got an on-prem environment currently, and say you've got a firewall vendor like Palo Alto or Checkpoint or Cisco, then you have an ability to potentially deploy that solution or a very similar solution of the same thing in the cloud. So you could use a network virtual appliance, which is essentially just 2 virtual machines or multiple virtual machines for high availability. But it creates a lot of cost because you're now managing a whole lot of load balancers on either side of it. You're managing the 2 virtual machines, you're making sure that they've got availability and high availability. And it also kind of extends your capability to maybe do a bit more multi-clouds kind of stuff. The other one, which is a little bit of a varied cost because there's kind of 2 ways of approaching it, which is those express routes and site-to-site VPN connections. So people that have got hybrid connectivity already with their Azure environment, you could choose to just go, well, I'm maintaining a firewall over here on-prem. It still functions, it still works. Why don't I just send my internet traffic out through that? You can do that as well. So using your on-prem for your internet breakout and stopping that any kind of internet breakout. So again, more of that security conscious kind of company that's got the heavy investment potentially in their on-prem security solution and want to see that inspection and see that granularity of traffic there. So option 1, the easy button is what we call it, because it's literally single resource or a couple of small resources, the NAT gateway and a public IP address, and away you go. And then you simply associate that with subnets. And there you go. You've got outbound internet just like what you had before with that whole source NAT approach. So it's a simple approach. It also allows for auto scaling up to the kind of 50 gigabit per second. So it's quite a strong kind of opening. It's got the scalability that you're looking for. It's one of those things that you've still got that capacity to kind of to at least determine which subnets should have internet access, which ones shouldn't. And it's quite simple to kind of maintain and manage. Again, it's a PaaS component, so a lot of that responsibility falls to Microsoft, but you still need to kind of manage and understand and maintain your own kind of configuration inside it as well. So one of the downfalls of it, obviously, is that there's no filtering, there's no inspection, there's no rules, right? So you can't say this machine can go to these sites. There's no level of inspection or content filtering or any level of control when it comes to that part. So again, need to consider what your organization requirements are versus what you can achieve. Option 2, Azure Firewall, probably one of my favorites, mainly because I'm a networking nerd and security nerd, but a really good solid solution, right? It's Azure Firewall, and there's 3 tiers of Azure Firewall. There's basic, standard, and premium. So you can get away with something super basic. Like, so when I mean by super basic, it does maybe the layer 2, layer 4 kind of, sorry, layer 3, layer 4 kind of options, right? So this source address to these sites, or this external address, that's achievable. Or it can go outbound onto this port number, right? Or to this port number externally, and so on and so forth. So it's a very simplistic form of a firewall, but it's still a firewall, right? So you still get that slight level of inspection and that capacity to do at least basic rules around IP to IP or port to port. Obviously, the standard builds on that again with just some additional functions around inspection, and then premium, and then further advances on that again, where you've got things like the TLS inspection, the IDS, URL filtering, and web categories. So you've got that real rich kind of layer 7 firewall capacity at that point. And the standard's like that step in between. It's still got all the inspection, probably got a little bit more broader kind of capacity around things, but doesn't necessarily have all the bells and whistles of something like TLS inspection. So and FQM filtering and so on. So centralized logging, also really important, and it's fully managed, right? So it's a fully managed PaaS component. So the only thing you're managing is essentially your rule base, right? The unfortunate side of that is it's quite a bit more expensive, right? So the figure I've given you there is just based on current pricing inside Australia East for $520 a month, roughly, on the basic, with about a terabyte of egress data. So remember, you're not charged for data that comes into Azure. You're charged for your virtual machines making traffic outbound, so egress data, not ingress. And it does kind of require a bit more of a hub-spoke architecture. So if you're not someone that's got a hub-spoke architecture, or you've got a bit more of a dispersed architecture, you need to do need to consider how you get your traffic through inbound and ingress through that firewall. So typically with virtual machines, you would use something like a user-defined routing table to point your traffic to the firewall. So it's a little bit more complex in that scenario, but it's a lot more of a favored. So kind of this and the NVAs are kind of like the 2 kind of mainstream kind of approaches to this for the security conscious kind of organization. Virtual network appliance, like I said, that's the more complex one. It's definitely more. It's the same thing. You can do almost the same thing, if not more, than what you would have had from Azure Firewall. You can have it like you're doing all your SD-WAN if you're using Fortinet, for example, or Checkpoint and Palo Alto also have NVA products that are off the marketplace that can achieve the same thing. Same thing with Azure Firewall. However, you're now in control of all of it. So it's not the PaaS offering that manages all the underlying infrastructure. You now have to manage the NVAs themselves, so the virtual machines that are themselves, the load balancers, the public IP. So you're managing a lot more of the ins and outs and the technical components that make up the solution. And it also still relies on that hub and spoke architecture. So you still need to be using UDRs, for example, to move your traffic to it. So again, and there's probably a slightly more costly, right? Because it's not platform, it's not scaled to a platform level. So you've probably, you've got 2 virtual machines and you've got extra load balancers. So it's probably a slightly more higher cost, once again, higher than probably something like the Azure Firewall. And then the site-to-site VPN express route piece, again, it's if you've already got the hybrid connectivity set up and you've already got the security investment on-prem, this could be a really good option for you. It allows you to leverage your current connectivity, whether it be site-to-site VPN or the express route, and move all of your internet traffic back down through it. So you can move by, again, leveraging UDRs and also with site-to-site VPNs, or if you're using express route, you can utilize your BGP routing in order to, I guess, effectively advertise that the internet is accessible through your express route. And site-to-site have a concept called default site. So you can set your default local network gateway as the default site, and then it simply says, okay, I'm going to allow internet traffic to flow down through that site-to-site VPN. So a little bit more latency with that hairpinning approach, but it's, again, kind of want to maintain control on-prem, want to maintain the level of inspection and visibility that I might already have through my firewall, and then just treating the cloud or Azure as essentially a different spoke to my on-prem environment. Also, a big thing there would be to consider the bandwidth requirements, because if you're leveraging ExpressRoute for all of your business activity, you've also got to be now accounting for your business activity plus your internet, right? So you've got to think about your bandwidth sizing there. So the decision framework, the very simplistic traffic inspection. You need to think about things like firewall or NVAs. Otherwise it's like the NAT gateway, which will get some, but nothing to the level of detail that probably most security professionals would like. Existing load balancer, if you've got one already and it's already leveraging that, could you consider using outbound rules for that instead, right? And leverage it out the same way. That hybrid environment, that's where, again, that ExpressRoute site-to-site VPN could be a good option for you there. And if you're looking at more of a budget constraint and budget consideration, the minimal viable product is probably that NAT gateway, right? And then if it's more of that security first kind of concept, you want to look to the firewall. So some implementation tips: audit your existing virtual machines, audit your existing virtual networks, and test this kind of functionality inside a non-prod environment. I think that goes without saying of pretty much everything we all do. Monitor the source NATs. So this is more typical specifically to the load balancing scenario. We have what we call port allocation exhaustion, which occurs inside load balancers, where we have, say, we've got only 2 or 3 inbound ports that are allowing through our public load balancer, but we've got 5 servers underneath it. And those 5 servers go bang and they go to the internet, right? So they've got ports for DNS, they've got ports for web traffic, they've got ports for system traffic, they've got port for update manager. So all of a sudden they start to exhaust the outbound port request, that SNAT port exhaustion. So there is an Azure monitor workbook just to monitor that part, and there's actually a metric for it that you can monitor it to make sure that you're not exceeding those limits. And document your architecture. Some of the times considering private endpoint, if you're in that hybrid connectivity model, maybe considering some more private endpoint deployment could be a way to reduce your outbound requirement, right? So rather than it going out via the internet to get to something that it could have potentially gotten through a hybrid connectivity model through using a private endpoint. So maybe think about where you leverage your private endpoint a little bit more. And that's it. That's all I've got. I think I'm almost bang on time. A little bit early.
Yeah,
but I'm opening up for some questions.
I do have any
feedback for me today. Actually, I'd like to. If you've got any feedback from today's session, please use the QR code and submit some feedback.
QR code over here as he points this way.
Yeah.
I do have a stupid question that just occurred to me. The new network virtual appliance capability, versus route server. So it's been a sticky one. Jose actually put out a really good article about the NVA. For those that don't know who Jose is, he's a product manager for the networking space in Azure out of Redmond. And he's done a really good piece around where does the Azure NVA fit versus the route server. They cover a really similar kind of requirement and concept. Ultimately, the Azure NVA is almost just a step above the route server. The route server can only do eBGP, and has some limitations around its size of route tables and size of route peers, right, and the amount of route peers it has. The NVA is just a slightly more advanced version of the same thing, but also has some of those additional kind of concepts where you could quite easily lift it up to a firewall. Yeah. Maybe it's for those sort of cloud native-ish larger organizations versus route server might. Yeah, I'm just trying to think of where I would place them. A bit more of the still running some on-premises things, may not be as large to need full capability and mesh networking.
Yeah, it's definitely one of those challenges. And I think the NVA is really struggling more that multi-cloud context where you've got probably that scenario where you really, or really strong kind of use case for NVA that I've seen recently was Azure Virtual WAN. So if you've got multiple vWANs across globe, then the NVA in the middle of that's really powerful.
Yeah, because it's vWAN, not hubs, which I always get confused about. It's like,
it's not
wait,
hubs,
but we've got multiple hubs. It's like, no, virtual WAN is different to the hubs within that. So it's always confuses me when people start talking because people like the terminology gets interchanged with that. It's like, Are you talking about multiple virtual WANs, or are you talking about hubs within the same virtual WAN?
And it's such a unique thing, right? Obviously, we get that scenario, and networking guys are horrible at it. We love our TLAs, our 3-letter acronyms, but we also love just swapping them randomly. So yeah, we're very bad at that in networking world.
I don't see any more questions on the chat.
No.
Yeah. So for people that I know want to get into networking for the first time and want to learn, because obviously there's a bit of a difference between on-premises networking and the network obfuscation through Azure in terms of like the Hyper-V layer as well. So what would you recommend? Microsoft Learn Docs? Is there any other resources to kind of get?
You know what? I say this with a pinch of salt. On-prem networking skills are still so relevant to the cloud, and all you need to learn is just a little bit of translation language. How do I, if I'm doing this in my corporate data center, how do I achieve the same thing in a cloud? And it's literally all it is it's instead of it being a VLAN, it's a VNet. And it's simple. It's really basic language shifts.
Yeah.
So, and Microsoft Learn have a really good series, and there's a certification around Azure networking, the AZ700, that has a learning track that as I'm now coming on board, I'm a newbie to the MVP program. I'm hoping that I can get involved a little bit more inside the learning track for that particular certification, because there's some really cool things that are in that. So look at the AZ700 learning path. That's a really good fundamentals. Also, there are plenty of people out there that are doing like kind of like the network fundamentals for the cloud. There's a couple of good YouTube series around that as well that have got the more of that language piece of doing here is actually this here, and they actually also go a little bit beyond Azure. They kind of go if it's this in your VLAN here and it's a VNet here and it's a VPC over in AWS and in GCP it's called this as well. So people are doing that a little bit further and exploration as well.
The tips for kind of that I always think in the back of my mind is treat the NIC as a router, and network security groups as an ACL that flood down to the router, that flood down to the NIC. So I think like if that's how I tend to think of it, and I think it almost simplifies what's going on, because you're going, well, actually, if you just take out everything else and you consider all the resources connecting to a NIC, and then that's your router, where's that traffic going from that place to that place? And it makes it a bit, I don't know.
And the network topology right now in Azure has had some recent changes in kind of middle of last year, had a really good uplift. You know, we can now do packet capturing natively inside the cloud now, which is a bit of a mystery, right, and a bit of a dark art in before that, but we've now got really clear packet tracing. We've got very clear IP flow verifications now built into the portal. So if you've got an Azure virtual machine, you can go to the network card, and there's a whole another section under that for Network Watcher that has a whole lot of additional features now that are very valuable when it's troubleshooting that, well, why can't I get to here? Why can't I get to that? And it will go through and validate your network security group that's associated to either the NIC or the subnet, and it will also go through ASGs if they're there. So it'll iterate through and help you troubleshoot that process. Network engineers are also incredibly tactile. They love to get their hands onto it. Virtual networks don't cost you anything to build and to put together. So go ahead and create yourself an Azure free account and just throw a whole lot of VLANs into it, throw a whole lot of virtual networks into it, and get things connected, and just get a couple of virtual machines on either side and just validate your thinking, validate how you process, how you would think they're going to connect.
Yeah, that's a good, so there beats nothing else than getting hands-on, and to refer to a previous session as well that Marcel done on Azure Developer CLI, you could essentially wrap a lot of those Azure networking resources into an AZD deployment as well, and then spin them up, do your testing, spin them down when you don't need them. So
I think one of the other things I always like to try and challenge as well with network engineers in particular, they love their CLI. So go ahead and learn Bicep. Learn a little bit about how Bicep works and how Bicep works in networking in particular, because I think it's actually really quite cool. You can kind of get a flavor of how it kind of builds out and comes together through something like Bicep as well, without having to learn the whole Azure resource management structure, right, and all the JSON behind that and underneath it. So if there was, I think CLI is a really easy way to start, right, when we're going from kind of network 101 over here and what we would do in our Cisco CLI to Azure. I think definitely the Azure CLI is the right place to start there. And I think if you're elevating beyond that, the packages like Marcel showed us earlier today are a really good elevation of that. And then beyond that as well is then going towards that full automation of Bicep.
Yeah, it's a good call out, and then work your way up to like, oh well, service endpoints are outbound and things like that. So yeah you can get it. You layer on that knowledge from bit to bit. So
yeah, definitely.
Well, thank you for coming and presenting to us today. I think that pretty much really on time now. So yeah, thank you for being the last session of the day and very
thank you.
Well, and we'll be back in just a couple of minutes just to finish it off. But thank you very much, Chris. Thank you.
Thanks, everybody. Thanks for having me.
You're on mute.
Yeah, I'm mute.
Hello.
Like that. We're finishing, and they're like, oh, so excited. That was a great day. Yeah.
Yeah, really good.
How you guys feeling about it?
Feeling amazing. Feels really good. Awesome sessions. So many things to read about afterwards.
Yeah, that's true. I really want to show my respect to all the session speakers today. Like their effort do the contribution to the Azure community and also give such awesome sessions.
Nice.
Yeah, thank you so much.
It's been an amazing day. Yeah, I'd really appreciate you guys coming here and sharing, just introducing speakers and going along like this journey, right? And also thank you all the speakers for being available and coming to share like their expertise and knowledge. Yeah, I learned lots today, really. I wouldn't be able to pinpoint this session or this session. So we kind of have coverage from different areas, that different expertise. Yeah, to be honest, I learned lots. It was a really fun, interesting conversation sessions, right? We had throughout the day. Yeah. How about you guys? What do you guys feel?
Yeah, I agree. I myself learned a lot of stuff and a lot of things to chase. All the speakers have shared something interesting. Yeah.
Yes.
Yeah, it's like my for those who've been watching throughout the day, you might have noticed a change of hats, just to keep things interesting. So I'm not really much of a hat wearer, but my hair is getting less and less. So it's the only time that I've actually, but this was, if I go back all the sessions, so there's Seattle Kraken one. That was a non, and then started with this. So, but I think it showcases, the I guess the layers of not only the community but the session types and all the information. So, it is. I said in a previous session, it is what you don't know what you don't know. And like these sessions among everything else happening at Global Azure is always great to just share it with people, because you don't know where people are in their journey, and people learn different ways as well. So
Yeah.
take these off before it scares me, but
Yeah, well, in Global Azure has not finished, right? So we're here like just one side of the world. So there will be like a full day still happening on the other side. And yeah, I invite like people to jump to globalazure.net and to check other sessions, right? Because yeah, there's still plenty to happen, and lots of sessions going all over the world. And
Exciting.
yeah, with that, well, again, thanks guys, and thank you for the audience. The sessions are going to be split later on, like maybe in the next month or so. And then individual sessions are going to be shared on the different channels. Yeah, and knowing that we're like on a Saturday afternoon, it's a great day over here in Brisbane. I'm going to take like a break, enjoy the weather.
Yeah, man. Yeah, you earned it.
Yeah.
awesome. Thanks all.
Right.
Awesome.
See you
Thank
guys.
you. Bye.
Cheers. Okay, bye.